1, 2, check, check. 1, 2, check, check. 1, 2. Checking 1, 2. Check, check. The handhelds, are they for the table? Or are they in the box? Okay. Main.
Rail infrastructure is critical to our daily lives. Building and maintaining this infrastructure is an increasingly challenging endeavor. Headwinds are significant and evidenced by the following data points. Emerging and advanced economies are facing an infrastructure problem with a looming infrastructure cliff, estimated to be a global $18 trillion underinvestment problem. A report by McKinsey found large construction projects typically take 20% longer to finish than scheduled, and on average are delivered 80% over budget. And a study of 600 construction leaders estimated that their projects lose almost 2 full working days each week searching for project information and resolving conflicts that arise from a lack of coordination between stakeholders. So it's clear that more will have to be done with limited resources available. And information technology, when properly deployed, will be the future centerpiece of future super efficient and profitable rail infrastructure asset management. However, the reality today in many organizations is that it is hard to get control of the documents, data, workflows, and processes across the life cycle of rail infrastructure assets. Multiple parties, different systems, different file formats, multiple data schemas. And as a result, stakeholders Hello, everybody, and a big thank you for the opportunity to share some perspectives with you about how SAP and partners can help you future-proof railway infrastructure asset management. Also, a big thank you to Oos from SBB, who will present a customer point of view on this topic. Properly deployed will be the future centerpiece of future super efficient and profitable rail infrastructure asset management. However, the reality today in many organizations is that
Check, check, check. 1, 2. Check, check. 1, 2, 1, 2, 1, 2. Two. Check, 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 check.
Hello, everybody. Opportunity to share some perspectives with you about how SAP and partners can help you future-proof
Hello, good morning. I'm Victor Kinlock. I'm the Managing Director here at Metis. Thank you very much for all being here today to join us for the second RIAM Summit. Now, I'd like to keep it short because we're running a little bit late. Really just to thank all the speakers who helped in regards to the research process to build in this event. It's really about collaboration and really giving us something that we can kind of share and hopefully get some best practice from. I'd like to share and thank all the speakers and presenters who are here today, giving us their valuable time. I'll leave it there for now because I'd love to introduce our co-chairs, Peter Boom and João Rocha, who will now take over and introduce the rest of the presenters. Thank you very much.
Good morning, all of you. Thank you, Victor, for giving us the honor to chair the conference, and we try to make that in the best possible way, together with João, with whom I'm working, collaborating together already in a project for East West Rail. We will say a few words around this as part of the introduction. Maybe, João, you want to introduce yourself first?
Sure. Good morning, everyone. My name is João Rocha. I'm currently the head of asset management and maintenance at East West Rail company. And welcome, and I'll let Peter do a bit contextualization of the session today. And we will start by giving you a brief overview of what we're doing before we kick off with speakers.
Thank you. So my name is Peter Boom. Boom, always people start laughing, of course, when you are at the reception desk checking in a hotel. So Boom is the right pronunciation. It means tree in Dutch. I'm working for Royal Haskoning DHV, focusing on asset management and digitalization. And Royal Haskoning DHV is a global active company, working as an engineer, consultants, and project management consultancy. And we are also working in the UK, which we will tell a little bit more about in the next slides. Our home base is in the Netherlands. There's also somebody from ProRail today on our list of speakers. So ProRail is a big client for us. And also at ProRail, you will learn more about that today. Digital ways of working is very important to implement. And I think this also relates to the topic of the day. We are now at the moment definitely more than we were before COVID, that everybody understands that we have to make a big transition in the way we move, passengers, in the way we move parcels and freight. And rail is an absolute piece of the jigsaw that we have to make all together. And I think railways is more and more in the picture. In order to achieve a more sustainable way of doing things together. And in order to do so, we need to speed up things. And I think I can also say and share with you that railways is not the most innovative sector in the world. Normally we are staggering a little bit behind airways, roads and things, what happens. And even when you speak about road and, for example, freight transportation on the roads, what I really dislike is when I pass the motorways in Germany, and they are nice to drive, but then you go under an overhead line that they built on the A5 motorway in order to give the possibility for trucks using pantographs on trucks to get more energy and power their batteries. And I think, wait, what are they doing here? Are they copying the concept of railways? We can do so much better. And for this, we need really a drive. And this drive is also coming from digitalization. And this is the topic for today. And we will speak about sensors, we will speak about information systems, we will speak about SAP solutions, digital twinning, and that's also one thing that we would like to start with. Right.
Absolutely. So Peter and I, as he mentioned, are working together in a project, East West Rail project. So many of you may not have heard of this project, but it's a new railway project in the UK trying to connect the cities of Oxford and Cambridge. We basically are a new project and are trying to implement new ways of working, be innovative from the very beginning, and use digitalization and innovation as much as we can to achieve our outcomes. So we want to be better for the customer, for the passengers, for the freight operators, for everyone. We also want to be cheaper and be delivering the project on time and on budget, always keeping the safe element of the railway, but also thinking about the sustainability and the environment. That's a key thing for us. Obviously, we need to run a reliable railway, high performing, and for that, we need to be working in cross-domain and also adopting digital technologies and innovation as much as we can to ensure that we do things in the most cost-effective way. So we want to be doing predictive maintenance. We want to be looking into condition monitoring, understanding the performance and condition of the assets and intervening at the right time. And also this would enable us to achieve sustainability, both from an economical perspective, but also from an environmental perspective. And to achieve that, we need to be connected to an ecosystem. And we believe that this can be done through harnessing digital twinning capabilities. And that's why we partnered with Royal Asconing and are developing a joint collaboration work to really touch on their experience. They've done this with other companies elsewhere in the Netherlands, particularly. And together with them, we believe that we can set up this properly and really start making advances in digital twinning in the UK as well. So I'll let Peter now explain a little bit about what digital twin means for us.
Yeah, of course, everybody will have his own definition about digital twinning. Just a few slides to explain, or even one slide to explain the concept, how we look at things. It will also come back during the day that you speak about the digital twin being a virtual or digital copy of an asset that is out there. And but of course, the question is, how are you going to use this and how do you bring that to life? And there should be something animated. Yeah. So of course, it's important to use sensors, to use control systems, to use other inputs from satellites and what have you, in order to be able to describe the status and the situation of your asset today, or of your complex of assets, or an entire railway line or station. And this you will do to understand how it's currently, what the station, what the status is as is. And when you then are modeling these things using machine learning or other algorithms, you can also say something about how is the status as predicted. So what will possibly happen and how can you avoid risks for the future or manage things better. And if we are then adding also other ways to play scenarios, for example, and use simulation as an alternative to figure out offline how you can maybe change or modify your assets. You can try out and find out for yourself how this might work out in real life, and also there avoid things or optimize things in a better way. And so we come to a prescriptive situation using artificial intelligence, machine learning, and in the end, when you close the loop, you come to the ultimate situation that you have, in fact, machine-to-machine integration. You can really use it to also change again the physical state of the asset. So by that way, you can close the loop from CAPEX to OPEX and make it a useful tool. Easier said than done, of course. For this, we started with East West Rail first, starting from their strategic objectives, drawing also a roadmap. And I think, João, you will present a little bit more about that.
Yeah.
The way we are approaching this.
Yes. So as Peter said, we started with how can we use digital twinning to achieve our outcomes and objectives. And so that's sort of our starting point. We then understand the business requirements, engage with stakeholders to understand if they meet the requirements, or sorry, if we need to revise them, and how can we achieve what we are being asked to do. Digital twinning will come then to support us achieving those objectives and deliver what we need to deliver for the customers. And then we can also use it to measure the performance, measure ourselves, and then go back to test if we are achieving what we set out to achieve and validate our approach. We have an enterprise architecture that defines all the services and capabilities that we need to deliver. And that's pretty much what we use as sort of the baseline and allow us to compare and understand that we are delivering all the services and capabilities that we have to the customers. And if not, we then have the opportunity to identify the areas where improvement needs to be done. So digital twin is effectively a live thing that's going to be used to not only support what we want to achieve, but also check and confirm that everything is being done consistently. So this was a very, very quick tour about what we're trying to do. And throughout the day, we'll see lots of use cases, lots of applications of digital twin, other innovations and technology being used in the railway sector to drive performance and to achieve better outcomes, which I think is a really step up, and we need to accelerate this. And through the collaboration of the people in this room, I think we will may be able to speed this up and really start being successful. And I think this sets us up for the first speaker of the day, Stephen Dennis from the Office of Rail and Road, or the ORR. Stephen is a professional and experienced chartered engineer. He's the head of asset management at the ORR and focuses on monitoring network rail, asset, and financial performance across maintenance and renewal activities. He champions best practice by adopting whole life system-based asset management approach and also trying to improve data quality and optimize decision-making. His presentation is going to be on integrating the whole railway system, train, signaling, power, track, and screen doors, passenger information systems on board and in the stations, measuring customer satisfaction in million kilometers between a service affecting failure. So, Stephen, the floor is yours.
Thank you very much for the invitation to come along today. I'm not sure I'm going to cover everything there, and I suspect my presentation will be the least technical one today, but hopefully I'll set a bit of a background and maybe set out some of the challenges that as an industry we face. So what am I going to cover today? Well, really just a bit of an introduction to the Office of Road and Rail. Perhaps talk about the periodic review process. It's quite a key. Every 5 years, we need to reset the railway. And we talked about our role in setting infrastructure asset management requirements. And then we talked about, well, perhaps how much infrastructure owners, customers, and funders have slightly different desired outcomes. And then I was also going to touch on how we use consumer expert panels to perhaps give us that independent view. I think as engineers, we all think we know what the customer wants or what the customer needs, but actually maybe the customer has a slightly different view, and it's always useful to get that third party challenge, I think. And really just what's our role in trying to improve the passenger experience. And briefly, we'll touch on some of our work around ticketing and accessibility. So a little bit about the Office of ORR. So we're really we protect the interests of rail and road, and we want to improve safety, value and performance, which I think all have a technology and digital requirement. Today and in the future, we're an independent economic and safety regulator. We're only answerable to Parliament. We also regulate the High Speed 1 and we've got some impact on Channel Tunnel. And we're a really small organisation. There's only about 300 of us in total. So quite a lot of our staff are out in the field. About 150 of us are in the safety area. The engineering team is only about 30 or 40 people. And I think just to get some I think I read recently, there's something like 190,000 people working in the UK rail industry, and there's only 300 of us. So that really reflects and prioritises how we work as a regulator. And we're guided by principles of best practice. And it says we should be risk-based. So we try and put our limited efforts where we can. We also have to be evidence-based. So we're always challenging and asking for the evidence. Where's the evidence to support that conversation and that discussion? We're targeted, so we look at specific concerns or area where we're responsible and where we think we can add the most value. We have to be proportionate. You know, if it's a relatively minor issue or item, would we get involved? Probably not. If we think it's something that has a serious concern or safety implications, then we would put a lot of effort and energy into that. We also have to be transparent. So we have to be able to explain the decisions we've made and why we've made them and on what basis we've made those decisions. And if you go to our website or go to our homepage, you actually find a huge amount of information. Every time we do a piece of work or we undertake a piece of work or we engage a consultant to do some work on our behalf, inevitably we will place that report on our website for everyone to see, to explain why we've done and what we've done. And we also, as an organisation, we go out and consult. We ask industry what they think. If we're proposing to change the way we do something, we ask stakeholders to feed back. I thought people might be interested in just kind of understand where the money comes from. And last year, so it was a bit of a strange year because obviously that was a COVID year, wasn't it? But the government had to put a lot more money into the UK rail industry. And they had to put just under £17 billion into it. Some of the money comes from freight. A relatively small amount came from fares that year, sort of reflecting the drop in passenger usage. A little bit was generated from Network Rail, from their commercial activities, HS1, core value lines, etc. But as a comparison, I put what it was the previous year, which was probably a more realistic year and a more common year. So you can kind of see the difference that there was a real shift between government funding and fair payers funding, and how it's really shifted last year because of COVID. The latest figures will probably be due out probably November of this year. And I guess it's probably going to be somewhere between the two, but probably swinging back more towards the 2021 model as more passengers start to come back into the service and demand builds again. So Network Rail, in order to operate, has to have a license, as do all operators. And I'm not going to read the whole thing because it's sort of written in sort of very legalese, but actually I think there's some really key words I want to pull out. So it talks about best practice. And I suppose we could all have a debate as asset managers, what does best practice mean? What does it look like? And maybe we'll touch on that later. But it also says that they should meet reasonable requirements of the persons providing the service. That could be train operators or freight operators. But it's also got to be able to meet funders' requirements and also potential providers or potential funders. So that might be someone who's thinking of operating a new service, or it might be someone who's thinking of putting some third-party investment into the railway or building a new line, etc. But then if we look at 1.3, it says it's also to a greater extent reasonably practical. So we can't ask for something that can't be achieved. So we've got to be proportionate and realistic. And it's also got to be about, is it affordable? There's always an affordability test. So how do we decide what's affordable? Well, every 5 years, we have a periodic review process, and this ultimately impacts on the customer experience. It's a statutory process which we lead, and the key objective is to establish the level of funding required for mainline GB railway and the outputs and outcomes it should deliver to rail users and taxpayers over that 5-year period. At one level, it's quite a simple process. Every 5 years, funders, governments set out what they require from the railways, and they set that out in a high-level output statement, HLOS. And that gives a brief overview of what the funders want from the railway for the next 5 years. And then they also provide a statement of the funding available. So they kind of go, these are all the things we want, and this is how much money we're prepared to put into the network. And part of our job is to kind of match those two. Can they achieve what they want to achieve for the funding that they think they have available? And there's a brief diagram of what the periodic review process looks like in terms of time. At the moment, we're in phase 1. So we're receiving the early submissions, we're doing our consultation, we're asking stakeholders what they think. And I would encourage anyone, if they've got an interest in the industry, to engage in that feedback process, engage in that consultation, so we can actually understand what people think. Have we got the priorities right? Are we focusing on the right things? And then towards the end of this year, hopefully government will issue their HLOS and their SOFAs. There might be some delay, who knows? There's potentially, well, there's definitely going to be a change in government, isn't there? Or a change in Prime Minister, will there be a change that may delay? We have to wait and see. And then once we get to the start of new year, Network Rail will then submit their formal plan to us. We will then review it, and then we will make a determination of whether we think the output requirements will be met by what's being proposed for the money available. And hopefully we can kind of square that equation. And then we will start next year. So what do we focus on? So we focus on the business drivers. You know, are they being met? Is it legal? Is it meet environmental, financial, etc.? The strategic plan should kind of set out how it's all going to work together, how it all pulls together. Asset policies, we're looking for those to deliver the lowest whole life cost. We're looking around for life cycle delivery. How are you going to acquire new assets, operate and maintain dispose of them? And then really what the outputs look like. How's that going to look like for the customer? What's it going to look like? Is it sustainable? Is it efficient? Is it effective? And I think it's fair to say that actually the UK railway is a really safe railway. Yes, there's been some unfortunate incidents, but on the whole, it is very safe. Performance, I was talking to someone earlier, and we said, well, is performance improved? Yes, it has. Reliability has improved over the last 10 to 15 years. There have been noticeable improvements in performance. Asset sustainability. So in terms of how we measure that in very crude terms, are assets being replaced at the rate at which they're being worn out? And also efficiency. So they've got to be stretching targets. And a lot of those will be around, can new technology deliver some efficiencies? Can they deliver some savings, better ways of doing things? So we always talk about best practice asset management, and in very simple terms, we kind of default to ISO 55000. And we're looking for that to support the strategic needs, the tactical needs and the operational needs. And we want to see that line of sight, that they all tie and they all link together. So if there's strategic plans and models, how do they then impact on the operational? If there's an operational model, how does that feed back into strategic plan? So what are we focused on? So what are we looking? So we're looking for a culture of continuous improvement, and that would be supported, I would argue, by adoption of new technology. It needs to be sustainable. So, and I think that's a challenge for all of us just recently. We've had a very long hot summer. The previous couple of winters, we had very wet winters. We've had storms. The whole environment's really changing. And I think that's really going to affect the way we think about how we deal with assets, how we maintain them, how we replace them. High quality asset data. So I think our decisions can only be good as the information on which they're made. Obviously, we've got to think about safety, long-term needs, take account of funders' priorities. Are we giving them what they've asked for? Is it really clear what we've decided to do? There's the competence of those making those decisions. People making those decisions, do they really understand what they're making them and what's the impact? And if you decide to defer some work, what's the impact of that? Maybe you can say, well, I'll put it off for a couple of years, but that could have some long-term implications, justification of proposed work, and identifying the implications of long-term asset sustainability. Are we okay for time? Okay, good. Okay, so sort of key challenges we're working on now. We're talking with Network Rail colleagues around this, and it's really that relationship between spend and performance. If we spend more here, will that improve performance? If we spend less, what impact might that have on performance? And sometimes that's quite a difficult equation to kind of work out. Freight versus passenger services demand on infrastructure. So I think we all want to increase the amount of freight on the network. That seems to be a really sensible thing to do. And I think you talked on that, Peter. But the impact is, do freight trains have a very different impact on the infrastructure? You need to maintain the infrastructure differently if you're going to increase the number of freight trains. And I know when I speak to some of my rail colleagues, they really hate freight trains. Not really hate them. That's probably a little bit unfair. But they worry about the impact that freight train has on the track network. What's affordable today and the implications for the future? So if I spend a little bit more now, will I save money in the future? If I spend less now, will it cost me a lot more in the future? And I guess these are pretty standard asset management decisions we all wrestle with in our industry. How might asset life change? If usage patterns don't come back and demand does stay at less than it was now, as we all decide to work 2 days in the office and 3 days at home, perhaps in a hybrid working situation, does that mean the assets will last longer? Will we get some extension of life out there? Maybe that changes the way we do. Will new technology change current norms of expected asset life? As our knowledge improves, will we be able to target interventions better? Do things at the right time? Or maybe better materials, more modern technology be more realistic? And one of the things we're really interested in now is how might investment in one asset area benefit another, or vice versa? So if we spend more money on drainage, might that then improve the condition of embankment? So we have to spend less money in maintaining the embankment. So it's about trying to work out, look, I think we're supposed we need to take a systems view as opposed to looking at assets in isolation. I'm sure you won't be able to read all this thing, but actually we have a whole host of key performance measures and performance measures which we monitor. And we agree then with Network Rail as part of our periodic review process, and they're then reported against in appropriate frequently. Some of these are reported every 4 weekly, some of them once a quarter, some of them are reported annually. And actually the vast majorities are all the results of practically everything here you can find is fined and we report publicly. So if you're that interested, you'll find it either on our website or Network Rail's website. A lot of information is made available for those that are interested. I suppose the question is how think about passengers. What do passengers really complain about? And I pulled up this graph with I found was really around complaints volumes. How does it complain? And it's not quite the measure we talked around per 100,000 kilometers, I think it was, but it's a measure between 100,000 journeys on the network. And at the moment it's 28.5 complaints per 100,000 journeys. And there you see that's the top 6 things that passengers complain around. And one of them is sufficient room. One's obviously they're very concerned about punctuality, facilities on board, and they're slightly happy now around ticketing, fine facilities online, and complaints not fully addressed. And surprisingly, if you look over the last recent history, those 6 things are the things that are continually being raised by customers. It doesn't change a lot. Sometimes the hierarchy changes. One is more prevalent than others, but on the whole, it's those 6 things which customers complain about. So I suppose if you fall around from an asset management point of view, probably punctuality and reliability is probably the one that we can probably most impact. But this is one thing I thought was really interesting. And I think this really reflects how technology has really changed our lives now. You know, if you were sort of, I suppose, back in the end of the 90s, if you wanted to find out some train information, you had to pick a phone up and speak to someone on the phone. And now we see that actually that's really dropped off. Yes, there's still a core of people who need to use that means of communication. But actually, I guess we all reach for our phone now. I know before I left my house, I just checked to see whether the train was running, and it told me it was running 1 minute late. So I could have a slightly leisurely stroll to the station. So it's really changed the way in technology, real-time information, getting into the passengers, getting into the customers. Has really changed that now. And lots of open source information out there. Passengers, so we don't set ticket fares, that's a government decision, but we do expect companies to be fair and transparent in how they do it. And I think we've seen a real step change in how people buy tickets now. You know, most people buy them online now, don't they? The vast majority do. You choose your seat. It's like an airline type model. You know, I think you look at when you're buying your ticket, what facilities will be on board the train, what stops it will be making. There's just so much information there. And accessibility for all, I think there's a reasonable justification to say that the railway needs to be more accessible. And one of the really positive things I saw around some of the open source information, and I'm not quite sure it's in place now, but people will be able to see what station lift is working in advance of the journey they make. So they can plan their journey. And if they're particularly worried, go, well, how will I get from the platform to the booking office? They were actually able to see in real time, is that lift working? And that's a tremendous change, and things that never before, you know, people would have to hope it would be working. Now they can check in advance. But you know, we recognize it can be costly. So it's got to be on a case-by-case basis and must be affordable. As I said, I'll briefly touch on this. We know we don't need everything. So we have an expert panel made up of the wise and the good from the industry. And we can really test things with them. So we're thinking of doing this, does it sound reasonable, in advance? So that's really what we use, and they're actually really helpful. So recently we've been talking to them, we've done some work around technology adoption. We were able to share our thinking with the expert panel, and they were able to really give some really valuable feedback that perhaps we as engineers wouldn't have realised. So summary, so we're required to make evidence-based decision. The periodic review is the key activity. More accurate and relevant the asset information, the better decisions we make. Perhaps the direction of travel is perhaps more important at that moment in time. So I think trend data is really useful. Environmental sustainability is becoming a bigger part of our thinking. And I think as an industry, we need to really think about how we're going to deal with the challenges that are yet to come, and whether historical data is really going to provide those answers. But ultimately, we need to take a balanced view, needs to be taken. And thank you very much for listening. You want to do it now at the end?
Jason will present, and then we do joint questions. So I'm not sure if this doesn't seem to be working. So I'll introduce the next speaker, Sinsin Su. She's a regional engineer for track in Network Rail. Sinsin and I actually worked together when she was head of track engineering at Network Rail High Speed. And she's now leading the Eastern region in Network Rail for maintenance and renewals. She's a recognized technical expert in railway track engineering, with particular focus on switches and crossings and vehicle track interaction. Sinsin, please.
Thank you. Hello. Good morning, all. Thank you for coming, and thank you for Victor for inviting me to this conference. So today I'm talking about technology and asset management and Network Rail perspective. Okay, so I'm the regional engineer on Eastern region Network Rail. So that's the largest region within Network Rail. We have about 6,000 miles of track. So that's about a third of the infrastructure. So as Steve mentioned, a lot have changed since the pandemic. So the good things from the pandemic is that we have a boom in technology, in communication and digitization. So our business have had to change as well. So we had transformational changes with this wave of innovation, and then our businesses have to be reimagined. So in addition, we had some site access changes as well, which is a big challenge for us, which started last year after a fatality of our workers. So access is now very difficult on track. It has to be line blockages or possessions, so it's very difficult to get on track. So a lot of our inspection and maintenance work has now moved to nighttime. So we have to reimagine our business model. So today I would like to present a few case studies of what we have done over the past 2 years. Okay. So 3 case studies today. The first one is about the cross-industry efficiency program using in service train data recording. So how best is it to inspect our track? The best method is to use in service train, isn't it? Because they run so often, so many trains an hour, and covers the whole network. So why won't we use it? And then the second case study is about using remote monitoring of S&C. So our experience with Connox. Many of you might have heard of Connox. It's a sensor, acceleration sensor. I think it's from Germany. And the third case study is about the Class 153 S&C inspection train and AVA. Okay, so all these have been successfully used on Eastern and nationally as well. So this is the case studies for today. So with the cross-industry efficiencies, this is actually a national project. So we have worked with like 24 of the operators listed here on how we can use data from their train. Okay. So the first thing we looked at was the forward-facing video. So we did some benefit calculation, and then we derived that if we can capture all the forward-facing video, we could actually save some inspection hours, boots off ballast, of about 100,000 hours. So before the pandemic, this is only available from our inspection fleet. That covers about 60% of the network, but most of it is nighttime videos. So it's not very helpful, not very useful for us. So with this IM program that Network Rail started a year ago, slightly more than a year ago, the infrastructure monitoring program, we started extracting forward-facing videos from the talks. And the talks were very, very collaborative. And then they would upload the videos for us, and then we could share it on a platform. So the development of a platform was key because we need to collect so much data onto one single platform. So the platform that we use is AVA system. It's called AIVR. It's automatic intelligent video review. So what happens is that the train captures the forward-facing video and uploads into the cloud system, and then it's straight away available on your laptop. So you can have footage that was like 30 minutes ago after the train finished running the track. So, and if you look at the bottom, that's the interface, user interface with AVA system. So you can see all the gray lines. Those are the available footage. So this is an older screenshot. So actually we have 90 to 95% of daylight coverage now. So you can click on the gray lines and then you could see the videos, and the videos would have like, it could be today, or it could be last week. You can click on any of the dates and you have the direction of the train as well. So some of the videos are on the tail lamp on the back of the train, some are in the front of the train. So there's a variety of videos that you can pick on. And then it helps the maintenance a lot, because sometimes when we struck an animal or something, we can play the videos and see if the fence is being damaged and all that. So it helps us with our inspection. So these hours that we said we could save was For example, vegetation. So we can use the forward-facing video to see if there's any vegetation obstructing signals. We can look at even structures and all that. So those are the MST, which we call it, a maintenance schedule task that we can save. So these people would then be in office in a safe environment, reviewing their videos instead of going out on site. So the next benefit that we found was using unattended geometry measurement system, the UGMS, and also using plane line pattern recognition. With this, we can save a lot of boots of ballast as well. So at the moment, our measurement train only covers about track geometry measurement trains only cover about 90% of a network, but 10% of it is still being inspected manually. 10% is a lot. 10% is like 2,000 miles. So, so what we can do is use UGMS from in-service trains. So actually we have 16 units which has UGMS at the moment. Most of them are on Hitachi trains. So they're on Great Western, they're on East Coast Main Line. So we can start using the data now. So we have a platform set up now that we can use the data and then compare run-on-run to see the deterioration rate of the track geometry. So by using UGMS on in-service trains, then we can sort of like deploy the IM fleet to the 10% that it's not currently covered, so that we can save the manual inspection. So we're having great engagement with the Roscoes and fitting more and more of these units. So like Anglia, they have a new fleet of Bombardier trains, class 720 coming in. So we're working with them to put these UGMS units on. Okay, so so the map there shows what the strategy is. So we're going to cover the UGMS on the main lines. So that's the strategy for Network Rail. So the third opportunity that we identify is OLE monitoring. So we started putting some cameras on it. So we've used several different designs to see which one is the best. So so we also have a strategy for the OLE deployment, which is the map shown in the middle. So this is where we're going to put them. A dewirement and all that is very, very damaging to performance. I think on East Coast, we have so many dewirements already. But on East Mids, we have a few class 360 trains with PanCam and the measurement device. So we managed to like prevent dewirements. I think about 6 of them already in the last few months because of the camera. So we think that using that, we can save about 30,000 manual inspection hours and reduce service affecting failures. Okay. So with this industry efficiencies program with in-service train data recording, we think that we can save about 24 million per annum. So that's benefit from reducing boots on ballast. That's all the non-productive time traveling to site and all that. And inspection can be more efficient. There's also the opportunity of, like, for example, I said, preventing the dewirement failures. So Network Rail Infrastructure Monitoring Program is now up and running, 38 million per annum, but with 20 million pounds in investment extra, we think that we can deliver 24 million pounds per annum. Okay. So the next step for this program is actually a rollout. So with the strategy all in place, we're now rolling it out with the UGMS and with the OLE monitoring program. So we are monitoring the benefits delivered. So we are working very closely with the TOCs. For example, I called the Greater Anglia engineering director to talk about when we're installing UGMS and all that. So we're working very closely with our IM program, which is asset information team, as well as the TOCs. So to reap the benefit. So now we're also working with the depots to monitor the benefits delivered. So for example, if we start rolling out the forward-facing video with the algorithm, which is, I think the algorithm detects when the vegetation will grow into the infrastructure, we can then proactively manage the vegetation. So we can sort of like calculate the benefit that we derive from using, for example, forward-facing videos and all sorts. So this is in progress at the moment. So the next case study is using sensors for remote monitoring of S&Cs. So there are various different sensors on the market at the moment. So we have used Yaltech, a small company from Wessex. We have used Connox from Germany. We have used Swix, also a small company. So there are various devices that you can use to measure the vibration of S&C. So they also have different fixing mechanism. Some of them fix onto the rail, some of them fix onto the sleeper, various, some of them on the point operating equipment. So it's just, you have to understand your failure mode before you start using the device. So with Connox, we have about 1,000 of them on Eastern alone. Okay, so it's piloted in Doncaster, Luton, and several places more than a year ago. Right. So this is all these graphs are from Doncaster Depot, from ATME Josh Chambers. So this is an example of the vibration of the crossing and the wheel passages, and the crossing is a good one. So you can see that the data is quite consistent. Okay. So the data is presented over dates and the acceleration value, vertical displacement, yeah. So the acceleration is double integrated to the displacement. And this is a poor performing crossing. So the acceleration or the displacement is all over the place. Okay, so we have to do something about this crossing because it will fail. Okay, so we can use it to also measure maintenance effectiveness. So this side, this crossing S&C side was having large voiding of more than 3 mil. So we went in and did some manual repair, but within like 6 months or less, 5 months actually, it went back to the same amplitude of voiding. So we decided to tandem temp it instead. So we monitor the tandem temp effect, and it actually lasted more than 60 days. So it's more effective than the manual repair. We're still monitoring it, so it hasn't gone worse yet. So this is an example of, we're trying to replace the ballast on track. So we use a vac to replace the ballast. So after the dig, you could see all these acceleration, vertical displacement going up. And then after temping, it went stable now. Okay, so we can monitor the effectiveness of any repair work that we've done. And this is another example. So we reduced the speed, we reballast it, we parallel temped it, and then we monitor the displacement, and then we increase the speed, line speed accordingly. So we can monitor the condition of the track following work. Okay, so this is just an example of the tandem temp that was done. So this example is showing that we have a poor performing crossing, and then we put in a new crossing and everything is fine. Okay. And this is an example of, we had a crossing that's not performing very well. We went in and well repaired the crossing nose. Look what happened. I mean, I spoke to a lot of maintenance engineers. They said, yeah, that's exactly what happened. Most of it, it's almost hit and miss. because well repair is not very scientific. They just use a big ruler and says, okay, this is fine and all that. So that's what we're working on now. So we're working on refining the repair process, the tools for doing the repair as well. So deriving the benefits, you have to understand the physics of what is being measured, because you have so many different sensors. Which one do you use? I think the advantage of the CONOC system is the platform that you use, because it's very easy to view data. You know, with other sensors, we find it's very difficult. You get the data, you can't easily manipulate the data or change the data and convert the data into information. So the platform is key. So with this method, we have consistency of measurements, not someone going out on site and says, oh, it's banging. Oh, actually, it's about 6 mil voiding. But this, we have a consistent of measurement. So as I said, platform that converts data into useful information. And above are what helps improve efficiency. Okay, so we go to the last case study. The class 153 SNC inspection train. So Eastern as well as Southern decided that we need a dedicated inspection train for SNCs, because there was like a boom of all sorts of technology. Some people wanted to use drones and all that. But on Eastern, we had several derailments on one year. I think it was like 2020. We had 4 derailments on Eastern, all due to wide gauge. So to us, dynamic measurement of the geometry is key. So we pursue this class 153 SNC inspection train. So this is what the schematic of the instrumentation looks like. So the train has about 6 cameras, including a forward-facing camera. And we work closely with One Big Circle, who provides the AI/VR platform. And then the data after a inspection run will immediately transfer to the cloud and then goes to the laptop for anyone who wants to use it. So it's almost immediate. So the only thing that the inspection train doesn't do is that it doesn't flag up block the line faults. So our normal inspection train, if they detect, like for example, a block the line twist fault, they will call the control center and block the line. But this train doesn't, it only has a driver. It does not have a on-train technician to do that. So this is something that we need to work on to change our standard. But the good news is that we don't have a lot of block the line faults. I think we had 3 last year nationally. Okay, so this is what the train looks like. So it has all the equipment in the train itself. There's all these cameras fitted under the train. I think the maximum speed of the train is 75 miles per hour, and it will measure at 75 miles per hour. So this is the AVA platform, as you can see again in the bigger picture. So all these little round things on the top are the recording that's available. If you hover on it, it will say, like, for example, the 10th of March, 2022, the time and all that. It'll tell you what train it is as well. So this is an example of the output from the cameras on the bottom, and it also has a thermal camera as well. So the thermal camera is good for detecting like overheating, points heating, bonds and all that. Okay, so you have you can adjust the lighting, the brightness on the of all that on the screen to help with the inspection. And then you have the track geometry as well. So this system has a simple track geometry measurement system. It measures the gauge, twist, curvature, and the top. So this will show you where this is showing the curvature and the cross level. So you can see whether there's any spike, and you can look at the image. Okay, so this is then, the train was developed to replace BVI, basic video inspection. So this is the patrol diagram for this particular S&C site. So the blue line says you have done the inspection. The red line says you haven't. So you need to do the inspection. And then there's a drop-down menu. So if you see, like, for example, in this case, you see a missing clip, you drop down the menu and say missing clip. And then at the end of your inspection, which you do sit on the desk and do all these, they produce a basic visual inspection report. So if you click on the view, it will have all the photographs that was captured on that particular site. And then we're starting to use cameras on the side as well to help with like inspecting conductor rails. And we're also still working with the AVA system, One Big Circle, to develop the line scan speed for structural inspection, because I think we have motion distortion at the moment. So we're trying to overcome this difficulty so that structures team can use the video inspection as well. Okay, so in summary, understanding the deterioration rate and failure modes and condition of asset. So, to identify the most appropriate technologies to improve asset performance and reliability. So you have to choose the correct technology, understand what you're trying to measure so that you can make full use of it. So for example, the Carnox study told us that we had so many depots piloting Carnox, but you need one depot to own it. That depot, Doncaster, has someone who is really keen on technology, so he took it and ran with it, but some other depots don't. So utilizing in-service trains and appropriate recording and monitoring technologies, this will require working in collaboration with suppliers, universities, and train operating companies. Collaboration is the key word here. So, and then the third point is converting data into useful information that can be understood and utilized by end users and railway maintainers. That's the biggest challenge for us. And that's it. Thank you.
Space for a couple of questions from the audience. Anyone has any questions they would like to ask either Stephen or Sinsin? We also have the opportunity to have, if you have any questions online, Victor, is there any? We do have one question online.
So the question was about the process with the inspection train. Does the operator only validate proposed default like missing clip, or does he have to find it himself in the image?
Well, it's actually the operator doing the inspection using the video. So the inspector would be using the videos going sleeper by sleeper and then identifying what's missing or what is the defect. It's like a basic visual inspection, but not walking on a track, but on the video, if you like. So they identify the missing clips. I can identify like cracks on the sleepers, and they put it down, and then it generates a report. Hope that answered the question.
Is there any?
Yeah.
Is there any kind of machine learning system?
Yes. It's manual for now, but as I mentioned before, we are incorporating algorithms. So AVA is working with, for example, the software Hubble, which calculates, predict the vegetation growth rate that it will encroach into the railway gauging envelope. So the algorithm will say, okay, in 3 months' time, this will happen. So we can cut the tree, plan in the maintenance activity. So we are working with different suppliers on that.
Hi, yeah, it's Brian Haddock, Network Rail. Just a quick question for Steve Dennis on your presentation. How do we build long-term thinking into a 5-year periodic review? I'm thinking in terms of long-term sustainability and climate change adaptation.
Sorry, Brian, I didn't quite get the start of that question.
Okay, so just in reference to your the 5-year periodic review, how do we build long-term sustainability and climate change adaptation into a 5-year plan?
So I think although we talk about a 5-year plan, our challenge to Network Rail is really to give us a much longer plan. So we're talking about the finance required for the next 5-year period, but really we're looking for those asset policies to span out 20, 30, 40 years. So really we're looking for what would be the impact based on the knowledge we currently have in maybe 4, 5, 6 control periods time. Obviously, no one can guarantee what the funding will be future, but at least it gives funders, I think, some forward visibility of what might be required, and they can plan on that basis. And then every 5 years, you kind of have to revisit the assumptions you made. How has your knowledge improved? What's changing all the time? And given the rate at which I guess the climate appears to be changing, then maybe those plans will have to be more dynamic. Hopefully that answered the question.
Yeah, thank you. I guess it's just that if we spend something in 5 years, then it could have ramifications for the next 5-year period. That's all.
For sure, for sure.
Yeah, can you hear me? Yeah, it's a question for Network Rail. Can you elaborate a little bit more on the challenges you have? So what is the challenges with the data? Is that extracting data? Is that the quantity of data? Is that the visualization of the data? Is that getting exceptions out of the data? Is acting on the data? What is it? All of the above.
All the above, yes. I think the key thing is to convert data into information so people in the front line can use it. So there's no point giving them tons of data when they're trying to do their day job and then trying to interpret the data as well. So the platform for presenting the data, the failure mode and all that, failure rate, deterioration rate is very important.
Problem today is that you're using the platform that are provided by the sensors themselves, or do you have any kind of overarching platform that allows you to get that data from different sensors and visualize it in the way the users want?
Yes, I mean, if you're saying like one single platform with everything in it, I don't think we need that. As long as it's web-based, we have a good platform for this particular application. We have a good platform for that. I think it's good enough if someone can use it. So that's the new generation maintenance engineer. I think they need to be able to use all these platforms and decide what is good or what they need to do.
Thank you, Sinsin. Thank you, Stephen. We move on to the from Johan Sackner and Asset Management. And Johan is a solution manager for transportation asset management.
Hello, everybody, and a big thank you for the
unit for travel and transportation at SAP and digital asset management. I'll move quickly into the presentation. So if you could play the video, and I think after the video plays, we will.
Hello, everybody, and a big thank you for the opportunity to share some perspectives with you about how SAP and partners can help you future-proof railway infrastructure asset management. Also, a big thank you to Urs from SBB, who will present a customer point of view on this topic. It is a privilege for me to present with Urs, who is a seasoned professional and working for a leading railway. In this session, we want to share the following. Introduce you to SAP's digitalized rail infrastructure asset management vision and solution capabilities, give you a sense of what customers are doing with SAP in this space, and share infrastructure asset management perspectives through the eyes of SBB. Rail infrastructure is critical to our daily lives. Building and maintaining this infrastructure is an increasingly challenging endeavor. Headwinds are significant and evidenced by the following data points. Emerging and advanced economies are facing an infrastructure problem with a looming infrastructure cliff, estimated to be a global $18 trillion underinvestment problem. A report by McKinsey found large construction projects typically take 20% longer to finish than scheduled, and on average are delivered 80% over budget. And a study of 600 construction leaders estimated that their projects lose almost 2 full working days each week searching for project information and resolving conflicts that arise from a lack of coordination between stakeholders. So it's clear that more will have to be done with limited resources available, and information technology, when properly deployed, will be the future centerpiece of future super efficient and profitable rail infrastructure asset management. However, the reality today in many organizations is that it is hard to get control of the documents, data, workflows, and processes across the life cycle of rail infrastructure assets. Multiple parties, different systems, different file formats, multiple data schemas. And as a result, stakeholders involved may not be working on the current operating picture at any point in time. The reality of many solution landscapes today is pockets of solution excellence with suboptimal connectivity integration, causing data loss across and within asset lifecycle stages. The consequence of these inefficiencies is that we are reducing the value of asset data. The 2 graphs on this slide explains this notion well. If you look towards the top graph, the pink line indicates very nicely how we take a significant step back in terms of value of asset data because of a predominantly file-based data management approach. In order to drive improvement, we need to follow a true digital approach. So move away from a project-centered file and records approach to a business-centric database approach. This implies having digital engineering at the core of our thinking, moving from electronic files and structured data sets to digital information that will help us gain reliable insights and make informed decisions. SAP's solution to this challenge, to the challenge described before, is to digitalize the end-to-end infrastructure and asset management lifecycle, achieve new ways of working together collaboratively, and bring together all key stakeholders in a collaborative asset management data environment. It is a solution that will help rail infrastructure organizations run simple but intelligent, because it connects all the stages of the asset lifecycle. It closes the loop between maintenance strategy definition and maintenance execution. It enables real-time health monitoring of connected assets. It has the concept of business networks that enable collaboration at its core. It contributes to safe and sustainable operations due to embedded environmental health and safety capabilities, and it empowers the employees through mobility and augmented reality. In the next few slides, I want to provide you with a 30,000-foot view of what our solution for rail infrastructure asset management entails. Rail infrastructure is a very complex engineering system. It is also a very complex business system. For that reason, the solution supports the following asset types: discrete, linear, and mobile assets. So any asset that we might encounter in the rail infrastructure space. And it supports all business stakeholders, be it an asset owner, an asset operator, a maintenance service provider, internal or external, as well as a multitude of other parties involved throughout the asset life cycle. Let's take a closer look at building and renewing rail infrastructure. SAP's digitalization approach is based on 3 pillars: collaboration, the digital twin, and the digital thread. So first of all, collaboration. To transform, we need to think and work in terms of business networks. Multiple stakeholders working together across organizational boundaries, internal and external, spanning all phases of the asset lifecycle. A cloud-based collaborative asset management digital platform will enable industry transformation across the asset lifecycle through collaboration between people, processes, and assets. Secondly, the in-dimensional intelligent digital twin. The in-dimensional digital twin provides an intelligent 3D digital representation of an asset to which users can attach multiple additional dimensions. These dimensions provide rich detail, history, and attributes about the assets, which can include but are not limited to design information, documentation, cost and budget schedules, project timelines, GIS information, and other critical project and asset information sources that would otherwise remain siloed and separated. All stakeholders can search, access, and contribute to these dimensions using the in-dimensional digital twin as a central access point for these data sets and dimensions. Then thirdly, the digital thread. With collaboration and the in-dimensional digital twin in place, we can now truly weave a digital thread. Key to innovation is digital information, not just at a point in time, but across the complete end-to-end asset life cycle. To capture real-time, accurate information across an asset's life cycle requires a digital thread running from planning to construction, commissioning through operations, maintenance, and refurbishment, eventually to disposal and decommissioning. This digital thread captures information such as how the asset was designed, how it was constructed, how it is being used, how it has been and should be maintained, when it needs maintenance, and how the asset could be improved. This digital thread enables more than collaboration between teams. It provides end-to-end integration of business processes and the systems involved. Let's move on to maintaining rail infrastructure. In the next two slides, I want to share with you the core pillars of this capability. So we keep the three pillars described above or earlier in place, but we add very specific intelligent asset management capabilities. So stepping through them in sequence. So number one is an asset register. This is the central repository of information to have complete knowledge about all my assets. It is integrated with core business functions such as finance, logistics, warranty, etc. And it enables harmonization and collaboration. So the ability to connect GIS and the EAM worlds, perform master data governance, and enables connection with OEMs and service providers around a common view of the asset. Secondly, asset performance management. Know the importance of every asset and measure its performance and have a recommendation for its life. It provides embedded methodologies such as risk and criticality analysis, RCM, and failure modes and effect analysis. And at its heart, it closes the loop between maintenance strategy definition and maintenance execution. The third core capability is generate dynamic maintenance demand. So it enables condition-based maintenance and predictive maintenance to change our maintenance mix. So doing less preventative maintenance, thus driving down our maintenance cost. We can perform digital inspections and simulations based on finite element models, and we can perform AI-based visual inspections. Moving on to number 4, that is all about plan, approve, and orchestrate. With the solution, we work from a single backlog of all work types, orchestrated with supply chain, procurement, and finance. It provides intelligent business planning capability for long, medium, and short-term activity planning, as well as inventory optimization. Number 5, schedule and dispatch. It intelligently provides optimization and prioritization of work with capacity management and resource assignment. And it can help us manage field crews as well as workshop operations. And then lastly, mobile execution provides maintenance applications on mobile devices to keep the technician close to the maintenance activity with all information needed at hand. And it provides collaborative work order processing, so working across organizational boundaries with maintenance service providers. So then moving on to support for sustainable operations. The solution has a keen sustainability focus. Embedded sustainability insights and actions form a core part of the solution. This helps customers to ensure efficiency gains, social responsibility, all while mitigating risk. Core solution capabilities are support for circular economy. So here we think about equipment repair and refurbishment, and management of infrastructure, recycled and waste material inflows and outflows. It supports people throughout the value chain through integrated environmental health and safety and incidents management capabilities, and provides advanced building infrastructure management through real estate, facilities management, and energy management. SAP's vision is to promote intra-industry collaboration by bringing together people, processes and technologies to deliver a single digital source of truth and transparency across the entire asset lifecycle. As noted on the slide, SAP works with partners. Partnering is very important for SAP. So the question, why do we partner? We are aiming to transform the way an entire industry value chain works. In this infrastructure value chain spans engineering and enterprise systems across 3 asset views: construction, maintenance, and operations. Partners have deep domain expertise, niche skills, process knowledge, and implementation experience, along with global reach. And SAP has the technology and the track record to bring these together. We are partnering strategically to solve an industry problem. SAP and partner solutions complement each other and integrate using SAP's industry cloud approach. In closure, I want to share with you a few perspectives about what rail infrastructure customers are doing with SAP. But before I share that, I just want to share with you my observations around 2 core pillars of digital transformation. And these 2 pillars that we see on the slide do not run in series. These are activities that need to happen in parallel, and SAP is uniquely equipped to support you in that journey. So first of all, it's about the renovation of core systems. So in a nutshell, reduce the number of core systems using a future-ready SAP digital platform. For example, combining the EAM and GIS worlds. The result is use less money to keep the lights on and have more money available for innovation. And then industrialize innovation. This is about innovating quickly and with the emphasis of innovating at scale. So not having innovation sitting in a corner, not being part of the digital thread. You can deploy the latest digital technologies, driving this innovation while keeping a stable core. So just a quick summary of activity examples, and the examples I group into 3 buckets, as we can see on the left hand of the blue block on the slide. So it's all around the 3 blocks for me. Activity buckets would be improving internal enterprise capability, and I note a number of activities that I observe. The second bucket is enable cross-company collaboration. This is an activity that we see picking up quite a bit across the globe. We think about collaborative work order processing, establishing a common data environment, and establishing an asset collaboration platform. And then the last bucket is obviously large-scale digital transformation projects. And on purpose, I call out this to make the point that you don't have to only do big full-scale digital transformations with SAP and partner solutions. You can start at a point small where you experience the most pain and start the journey there. So just please keep that in mind as you perhaps think through what SAP can support you with. In terms of customer examples, in a moment we're going to hear from Us, how SBB looks at rail infrastructure asset management. And then a second data point is in the presentation. I will share with you a link to a recording that was done in March of this year, where Norfolk Southern and Accenture presents what Norfolk Southern is doing with SAP in the rail infrastructure asset management space. So with this, I will wrap up and I will hand over to Urs. Urs, thank you very much, and over to you.
Thank you, Johan, for your presentation, and it's a pleasure to follow you and go a little bit in details what Swiss Federal Railways does in that transformation. Maybe we go to the agenda, and I would like to give you some insights in the current status of that S4 HANA transformation that we have at SBB, and the effect it has on our asset and service management, especially also in the rail infrastructure division. And I think it's very important to understand that we are going into a paradigm shift when it comes to we call the closed loop in maintenance management. I would also like to shortly show you about some relevant building blocks, architectural elements that we think are important when it comes to scoping that transformation. And then there are two important details, I would say, about maintenance management. It's learning how to use and take benefit from condition-based maintenance or even prediction, and how it can affect the business process. And the second point I would like to make is about collaborative scenarios with third-party service providers that support us in our maintenance execution. And then I would like to finalize and summarize on these points. Very first slide is about our new strategy. That's something that I would like to start with. We redesigned our SBB strategy with a focus on 2030. And as Johan already mentioned, you can also see that sustainability is something that is on strategy with us as well. That's a very important pillar in our strategy. And I think on the right-hand side, I would also address the efficiency and economical aspects that we want to improve. And these two aspects of that strategy are also highly linked with asset and maintenance management. The slide here, there are some facts and figures about SBB. I think important to understand is that we are an integrated railway in Switzerland. So we are organized in divisions. There is a division for rail infrastructure, which we are going to talk about later on, consisting of 4 networks: the telecom network, a water network, important energy network, and of course, and not the last network, is the rail network itself. So as infrastructure division consists of these networks, there is another division for passenger transportation, consisting the purchase, maintenance, overhaul, and operation of the rolling stock assets. And then we have a cargo freight division, which is mainly dealing with freight aspects. And last but not least, there is the real estate division with facility management. And important to understand, we have a And we see ourselves as having an infrastructural facility management and a commercial facility management. That's also important to understand when we are in that transformation on S/4HANA, that we see that there is support for both for the infrastructure and for the commercial facility management. SBB has around 30,000 employees, and maybe in that time of a lot of discussions about sustainability and energy production, we produce 90% of our energy that is used for the operation of the rail infrastructure and rolling stock assets by ourselves with hydroelectric production of the energy. So here we see a structure and a kind of a roadmap that is related to our S/4HANA transformation. We have an SBB program running and going on that is dealing with the introduction and establishment of the S/4HANA system. So we already have in use the ECC R3 system right now, and the goal is really to standardize and harmonize also on IT architecture level. And S/4HANA is our core system when it comes to these 5 topics, which are finance, purchase, logistics, project portfolio management, and enterprise asset management. So enterprise asset management is one of these 5 main topics that deals with that standardization and harmonization at SBB throughout all the release units that we have, what are depicted here and attributed by RE1 to RE4. And that means that we have major releases mainly on a divisional level. So the divisions that I was just describing are represented here in these release units, RE1 to RE4. And as you can see, we are currently, we have finished the design for the first release and are close to finish the build for that core system for RE1, and we will go live next year. And affected is the first department of SBB infrastructure. It's the energy network. So everything that is, deals with the energy production and distribution. And then it will be followed by a release for real estate, SBB real estate division, and then later on in 25 for rolling stock, which is part of the passenger transportation division. And in the end, the 4th major release will be infrastructure, all the other networks that I mentioned earlier. And I was talking about some building blocks and scope elements. It's very important to understand that we want really push the standardization and harmonization in IT architecture, in business processes, in the data we process, and also in the methods that we use. As Johan mentioned, for instance, how we design maintenance strategies so that we rely on failure data management using FMEAs or RCM assessments, just to give an example. We also want to standardize on other aspects in the maintenance, especially so that we have a common understanding and also a common support by an underlying system that is well known and accepted. This slide is about that paradigm shift I was mentioning earlier. I think it's very important to understand, and Johan mentioned that also, that we close the loop between the execution. That is an aspect we already have very well supported by SAP today. But furthermore, we want to have the possibility also to define the appropriate maintenance strategy for our assets over the life cycle of the asset. So that means we need to learn and adapt, and therefore it absolutely makes sense to have a PDCA, a plan, do, check, act, closed loop if you want, so that you define a strategy, that you plan appropriately, that you execute, that you analyze, and then adjust if necessary, especially on the maintenance strategy level. So this is a kind of simplified architectural overview and should summarize what just has been said. It's also a view on the solutions we have in our first release unit for energy. As mentioned, the core system for business process support in asset management, project portfolio management, logistics, purchase, and finance is S/4HANA. And then on top of that, we decided to go for the asset performance management and asset intelligence network solutions. We are convinced that these solutions will help us to close these loops that are also depicted here on various positions. A good example, I think, is what Johan also mentioned, is that we want to enable our workers out in the field, that they have the relevant information about the asset. They are standing in front of it and planning or executing maintenance tasks, that they have the information they need to take decisions and also to return and to give feedback what they just did, what they executed, what they what condition they inspected, especially on rolling stock or infrastructure assets, so that the information is relevant that is being treated. On the right-hand side, you see also what we learned is a platform we see is important, and this is helping us to learn from the data, to include the data from the assets. We call it Enterprise Analytics Platform. It's something that is built with other partners, and we then integrate the relevant information into the business process support on the left-hand side, where we see the SAP solutions as the core solutions for that support. So these platforms are interacting and are helping us to close the loop, also when it comes to, for instance, condition monitoring or prediction. And on the left-hand side, with these factories there, that shall represent our service providers, our external partners that are based on our maintenance definitions. They execute what we share and collaborate with them. So they execute what we have defined for our assets, and they also give the relevant feedback. So that's all integrated. It's about working with the same IT platforms on the same data and following the same business processes. On the next slide, I would like to quickly run through the life cycle of assets. What we learned is for the different divisions, it's important that we have the same view on how we treat and view assets on their life cycle. And there we see the potential on specific positions in the life cycle to harmonize the processes, but also the methods I mentioned earlier, but especially also the data that is shared between divisions, and where we can benefit from an integrated system. So here we come to an example that we will have establish in the first release unit for energy department. It's about that condition-based maintenance approach we want to introduce. We already we will also use mobile asset manager with a lot of checklists, and we will check especially on failure mode level. So we want that our maintenance tasks are accurate, that they have an effect on the asset. And therefore, we decided also to do a proper RCM assessment on critical assets, or at least to define the dominant failure modes. That's what you see in the step A. And then from there, you have a proposal on what task should be applied. And in C, you also will have representation of how we can use and see condition data on indicator level with the relevant threshold and rules applied that affects directly the business process. It's not just monitoring and exploring that data, it's really trying to connect what we get from the enterprise analytics platform directly with the performance management and learn from the data, trigger the business process, and for instance, directly open a notification to that specific equipment or asset. And on the next slide, you see the other scenario that is very important when we deal with our service provider. It's about collaboration, work order management, as we call it. This is really new for us to execute it on such an integrated way. So we really are interested that SAP Asset Intelligence Network is a core element of our solution, that these networks of partners are relevant, and that we are also interested and investing a lot of effort, time, and also engagement for motivating our service providers to be part of that network. And I think for the release unit 1, we will work with external service provider that help us to inspect our energy transmission lines. So that's a relevant use case that we will start with. As you can see, there are other examples, of course, for facility management, for elevators, for instance. That's a very interesting use case as well. And of course, also for rolling stock, if our rolling stock, for instance, is maintained in workshops from our service providers, we want to have the data feedback directly in our system, and so to really continue to write down that digital thread that Johan described. That takes me to the final slide and some key takeaways and lessons learned. I think the S/4HANA transformation is a trigger for a business transformation as we see it. We are trying really to follow that that design from scratch. We want to redesign the business processes as well. We want to improve the integration of the data we are working on throughout the divisions, but also inside the divisions. There is a lot of harmonization potential. We see that the closed loop is a paradigm shift that really helps us to improve the maintenance we are currently executing and learn from the data and optimize what we do. We learned a lot from proof of concepts and example use cases that we integrated, and we really are sure that failure data management has an important role in that transformation. We, as already mentioned, collaboration, work order management is a key element in that transformation that helps us to scale later on. And what we learned is it takes time. So as Johan proposed, start early, start step by step, use case by use case, and also trigger that business change that is very important in this transformation. So thanks a lot. Johan, I hand over to you.
Good, Urs, thank you very much for those very insightful perspectives. And, you know, coming from an organization like SBB, I think this, you know, would be interesting for many people to listen and learn from your experience. So I want to conclude our session quickly with the following takeaways. In the session, we've covered, looked at, you know, what's driving some challenges in the rail infrastructure asset management, then what SAP and partner solutions can do to improve that. We shared with you our vision and high-level solution capabilities. And we shared with you some customer perspectives like SBB and what they're doing on their transformation journey. I think my ask for you is, if you are interested to learn more about what SAP is doing in this space, I've given you a link there, a hot link that you will have in the presentation that you can explore a little bit more. And also I invite you to register for a free SAP hosted rail infrastructure asset management webinar that is taking place on the 13th of September. So it's a 2-hour webinar, and we will dive into a little bit more detail, looking at how digital technologies is reshaping railway infrastructure. So welcome to attend, and the registration link is in this slide deck as well, and on Mietis's website. So with that, I want to conclude. A big thank you to Urs, as always great privilege to present with Urs. And we are going to question and answers now. So thank you very much, everybody, for your time, and we will speak again. Thank you to Urs.
I believe we may have both of them online. So are there any questions for Johan or Urs in the audience here, or online for that matter? Yeah, I think everyone is dying for a coffee. I do have a question for them, for Urs particularly. I'm not sure. Can you hear me, Urs?
We can hear you. Hello, everyone.
There he is. Okay. Morning. Yeah. So I'm curious to understand what benefits SBB has already realized from this digital transformation, and they can be either financial, in terms of performance, reliability, maintenance cost reductions. Have you achieved that already, or are you still going through the process of implementing this and haven't established the benefits just yet?
Yes, that's correct. We are still in the transformation. So as mentioned in the presentation, we will have our go live next year. We are still preparing. We have finished the design, and we are currently by finishing the build. Correct. We are still in the transformation. So as mentioned in the presentation, we will have our go live next year. We are still preparing. We have finished the design, and we are currently by finishing the build. Correct. We are still in the transformation. So as mentioned in the presentation, we will have our go live next year. We are still preparing. We have finished the design, and we are currently
with the answer. But thank you for that. Any key lesson that you want to share on that digital transformation process that you've learned now and perhaps might be useful for the audience to learn as well, because I believe a lot of people in the audience is also going through the process.
I have a huge echo in what I say, but I try. I understood your question. I think I mentioned it in the presentation. As this transformation is really challenging, I would really propose to begin with that transformation, the point you are in. What I say, but I try. I understood your question. I think I mentioned it in the presentation. As this transformation is really challenging, I would really propose to begin with that transformation, the point you are in. What I say, but I try. I understood the question. I mentioned it in the presentation.
I think we're having some technical issues. Thank you for your answers. I think we'll have the opportunity to speak. We have the webinar next week as well. So if you want to register, I believe you can do it still. And there may be an opportunity there to ask more questions, and hopefully we'll not face the same technical issues that we're facing here. So thank you very much, Johan and Urs. I would like to bring the session to an end. We have now a network break opportunity, and we will be back, I believe, at 11. We're running a little bit late, but I think there's still enough time for
I'd just like to remind everyone that Johan and Urs are also online. So unfortunately, as you saw, digital is always an issue at these events. But if you do have any questions, they are actually online and they will respond to your questions as you send them. And we also have a colleague here who will be here to take any questions during the break. Thank you. Have a good morning break.
Portugal experience on the topics of this session. Just a few information.
Yeah, I think it works. Yeah. Can you understand me in the back of the room? Yeah. Victor asked us to start, and then hopefully more people will join us later on. It's my pleasure to continue with you in the next session. We have 3 speakers, of which one will be online with us. But I'm lucky that we have here Martijn next to me of ProRail and Tim from Network Rail. And Martijn, just a quick introduction. You have been focusing very much on lifecycle costing. You created a model that is very well used. You have a lot of users within ProRail. And you are going to explain us now how this works, why you did it, and what are the benefits of it. Yeah, please, the floor is yours.
Good morning. My name is Martijn van Noort. I'm working for ProRail for the asset management department. And I am involved in lifecycle management, in social cost benefit analyzing, in business cases, and also in sustainable decision making. Today, I want to tell you something about how lifecycle management is applied within ProRail. It started all in 2001. We developed an Excel-based tool for a lot of people within ProRail. They can use it, and we learned 600 people to use making calculations, but it were only cost calculations during the life cycle. So after a while, the question came, what is the difference, or what's the relation between RAMSI, reliability, availability, safety, healthy, and environment, and cost calculations? So I started to integrate these models or these methods into one method, and I started with the planned and unplanned disruptions. So from that time, we also calculated the disruptions based on the number of trains, the number of passengers, the delay minutes, and the value of time. After that, other parties, not only the asset management department, but also the project and system department joined and used the tool to make assessments. Then we also introduced a business case report into the tool. So we made it easier to share all the results of the calculations with the management. In 2016, I added more social benefits like emission reductions, like CO2, but also noise reduction and other benefits. At the end, a few years ago, we changed we rebuilt our Excel-based lifecycle management tool into a web-based application. And now we have a web-based application. It's very simple to use. It's used by all employees who need it. And it contains 6 steps from the initiative to the business case report. And we can also give accounts to engineering companies like the company of Peter to use them for us to make asset management calculations. The tool also gives a lot of nice graphs, and you can make sensitivity analysis for all your cases. But now I will tell you more about lifecycle management when you use the tool. First, the ambition of ProRail is very high. We want more trains, we want more passengers on the busiest corridors. We want also 100% safety and very good reliability and 0 accidents. But we also want to reduce our costs. And I hear you thinking that you cannot combine it. You cannot have a better performance and you cannot reduce your cost at the same time. But in the next sheet, I want to explain that it's both possible because lifecycle management helps to realize this ambition. Don't worry, this is my most difficult sheet today. Here you can see 3 cases, A, B, and C. And each case has 3 solutions. And of each solution, we determine all the costs during the life cycle, but also all the social costs like train-free periods, disruptions, but also noise, CO2, etc. So what we do is we add them together, and then we choose for each solution the lowest one. So we choose for the first case A3, the second case B1, and the third case C2. And then you will get the optimal situation. You could also choose the lowest cost. So when you always choose the lowest cost, you will choose A2, B1, and C1. And then you can see in the next pillar that you have the lowest cost. But what happens when you always choose the lowest cost? You will have the worst social cost. They are very high. And that is not what we want. You can also choose always the solution with the best performance. So the lowest sum, the lowest social cost or an availability cost. If you add them and together, you will see that you will get the best performance, but your cost will be sky high. And then you can also choose random. And then you have a kind of average situation. And the average situation of all the cases before, so all the project, I made it on that last pillar. And what do you see? If you have the average and you look to the optimal, you can see that the costs are lower in the optimal situation, and also the social costs are lower in the optimal situation. So when you have one method and you use it within your whole organization for all your studies and all your cases, you can reduce your costs, but you can also have better performance. So what else do we use? Lifecycle management. First, we want to avoid short-term thinking. So we have projects, but they have a long lifespan. So all the costs in the maintenance phase are during the whole life. So you want that your people think about the cost in the future. We want also to avoid decisions based on emotions. And I know a lot of decisions are based on emotions. We also want to make transparent decisions. So when you are a few years later and you have new colleagues and he asks you, why did you do that? Why did you implement that new system? Then you have to go to your decision and know why you made that decision. So as I told, it's very important for ProRail to have the value of planned and unplanned disruptions into your decision-making process, because it is one of our largest ambitions to reduce them. And we also want uniformity in decision-making. So it cannot be that we have one expert in the north of the Netherlands who decided to maintain his switch, and we have an expert in the south of the Netherlands who have the same switch with the same condition and who wants to renew his switch completely. So we want that is a uniform language used. At the end, there's only one target, and that's to get the best price performance. What kind of asset management questions can you solve with lifecycle management? I collected some. So do we maintain this high-speed switch, or do we renew it for a normal switch? Do we implement this new system immediately, or do we wait until the old system is at the end of life? Do we run this work in a time-free period of 1 week, or do we do it in several nights? Do we choose for electric switch heateners, or do we want to maintain it on gas? If we renew this track, shall we combine it with other projects? All these calculations you can make with lifecycle management to collect the cost, to collect the number of unplanned, planned disruptions, to collect the number of CO2, noise, etc. So cases where lifecycle management is applied within ProRail, it's you have the case, do I want to invest, yes or no? Do I want to maintain or renew? What types of train-free periods do I want to have? You can also compare a system A and a system B, and maybe you can say, I need a system C, so you have to develop the system C, and then you can also know what may it cost and how good must system C perform to be better than system A or B. You can also make clustering of projects. Sometimes when you cluster a project, it will be more expensive, but your hindrance will be lower. So you can also make a calculation. Or do I want to add functionality, yes or no? And now I have three sheets with some examples where you can reduce your costs. When we have a project, we have a lot of investment costs, maybe in the beginning of the project, and then during the lifespan of your project, you have a lot of maintenance cost. But you have also that an availability cost of the time-free periods and also the disruptions. And what you see is that the project leader wants to be in time, in scope, and the money must be within its budget. And at the end of the project, he wants to reduce some scope or some things to have its budget realized. And then he reduces his investment cost, or the client wants to reduce the investment cost. And what happens? The maintenance cost increase, and also the social cost increase. And at the end, it's the question, is this good for the asset owner, and was this a good solution to do? And I think in a lot of cases, be aware of decreasing your investment costs. When you use your asset longer, the average cost of your asset will decrease over the years. But at the end of the lifetime, your cost of maintenance and your cost of disruptions will be increase. So it's very important to take them together and find the best period for renewal of your assets. And the third is that when you have a new construction project, use asset management of use lifecycle management as early as possible in your construction phase, because at the beginning of your construction phase, all the possibilities are open. You have a lot to choose, and at the end of your phase of the project, when you are going to operating, then the possibilities are not enough to reduce your money, reduce your costs. So start early. Then I developed a little matrix for myself and for ProRail to find out how good we are in lifecycle management. And when you want to implement lifecycle management within your organization, you need some conditions and aspects. First, you need a good leadership, so that the management of your company believes in lifecycle management and steers on lifecycle management in all the areas I mentioned. But you also need the acceptance of employees. So it's better that they make their decisions and their lifecycle assessments by their own because they want to do it, than when the manager or the management ask it to do it, because then it's more like a duty to do it. The best thing was when I had an expert and he came to me and he said, Martijn, I used lifecycle management tool and I put 5 scenarios and I thought it would be B, but at the end, I'm now convinced it's D I have to do. That's the best thing you can get when you want to implement lifecycle management in your organization. Third, you need knowledge and skills. So you need some super users and experts. You also need a good method in your organization. You have to know which parameters you have to use, and I advise to validate it by an external party. We work together with people of the government to set, to validate the parameters we use. Then you also need very good input data. So you need data about your assets, failure rates, but also data about when you have failure, how many trains, how many passengers, has a lot of delay minutes. Then you need a good quality system. Who is checking the life cycle calculation, who is checking it, and who is approving it. And then when you are good in lifecycle management, you apply it in all the areas I mentioned. And at least transparency, it's good to have one database where you can collect all your assessments, so others can see what you have done, what you have decided, and at the end, you can also calculate what the benefits are of using lifecycle management in your organization. That's it. Thank you.
Thank you very much, Martijn. I'm sure there will be a lot of questions because you just showed us, or maybe you didn't show it, but you told us about that you have a magic application. It almost answers all of the questions that you might have. Probably there will be a round of questions from the audience. But now we will continue first with Tim Kearsley. The questions after the third speaker. You're responsible for infrastructure management strategy. Please introduce yourself and then take it away.
I will do, yeah. I seem to have broken the equipment, but never mind. I'm sure whilst we're fixing that, yeah, Tim Kearsley, Head of Asset Management Strategy at Network Rail. I previously worked in the water industry for about the first half of my career, about 20 years, and the last 15 has been with Network Rail. What I'll try and do is build on some of the themes that Martin raised there, because there's a huge overlap actually between the work that we commission and undertake. Network Rail, and I'm going to start with an introduction of what we are and what we do. For those who aren't familiar with it, obviously we've got a very diverse mix of assets. We're also the oldest railway in the world, and that brings certain challenges to do with life cycle management. What I'm going to do through this presentation is to look at an example of, in the detail, what we do to manage our track asset, and that will build a little bit on some of the themes that Sinsin Hugh raised earlier, one of our regional colleagues. And then I'll look again at what Martin's described there, which is overall asset management across our asset portfolios, how we bring all those assets together. When I joined Network Rail, I was really quite surprised at the complexity of making the network work and perform. I knew it would be more complex than the water sector that I was familiar with, but it was probably one order of magnitude more complex than ever I realized. And that obviously presents all sorts of challenges as to how we manage going forward. Our total asset base is worth about 500 billion, or rather it was when we accounted for that in about 2018. Of course, inflation and other burning pressures around the world now would mean that it would be some way north of that. And we get about £5 billion a year, that's 1% of that number, to maintain and actively renew that equipment, some of which is now 175 years old. The actual requirements in this space as to managing lifecycle interventions and using technology to support that varies quite dramatically depending on our stakeholders' perspective. You heard from our regulators this morning, Steve, representing that view, and they really want to understand the long-term implications of what we're doing, what that pattern of investment needs to look like, and what performance can be made from that investment over time, and what the balance needs to be between renewals and maintenance. As we move through our organisation, our engineers, of course, want to know a little bit more about how they can use these insights to assure themselves the infrastructure is safely performing and where they need to target that investment to retain that level of performance. And then towards the bottom here, capital projects and actually the maintenance organisations, that's much more about what's the next life cycle intervention? How do I know that I'm selecting the right maintenance intervention? Or as Martin has just described from a project perspective, how do I make that choice about where the capital gets deployed? Martin made a point in his presentation about the importance of data, and I'm going to start there, because actually all the technology and all the elaboration of our analysis is for naught if we don't have the right data. So what this slide attempts to represent is that as of today, we've got project data coming in, increasingly complex from BIM models and other point cloud solutions. We've also got aerial solutions, LiDAR, the sort of capture of that data from train that Sinsin spoke of. You've got drone, and you've got other real-time panoptic measurement going on of our network and how it's changing. And then, of course, you've got the historic work bank and the historic records around the infrastructure. Our infrastructure is so complex and so varied. These things have been historically managed in separate ways with different conventions. And of course, one of the key challenges for us to make a really savvy decision is how we collate and align that data. So we've spent a lot on technology programs helping to make data lakes more available, helping to give the patching together, if you like, of those disparate data sources and making that available for analytics. We're trying all the time to add in more from external sources, third-party data and representation. Again, Sinsin mentioned there the role of our train operating companies and the work that she's doing brilliantly to allow that trading of data. But equally, we've got that from other infrastructure organisations and operators, not least from a flood risk or a weather management perspective, which I hope Brian Haddock will talk of later on this afternoon. And then finally, there's a question about how all that is served up across our business. How's that visualised? Is it visualised in the correct format, in the right way, in the right convention to meet the bits of the business that we're trying to support? What I'm going to do is move on to a track example of that, and actually one of the more recent platforms that we've launched and made available to decision makers across the business. This slide here talks to different interventions you can put to track depending on how early you found the defect or the fault within the track. Left to a visual inspection only representation, whoops, I need to go back. Left to visual only, we'd have to re-rail when those defects get to a certain level. And that's very expensive. That's sort of £250 a linear metre. Our old conventions were very much around that visual on-site inspection and finding defects in that way. Where we got clever and where we were starting to use technology, we could find earlier in flight that challenge, and we could invoke different solutions, which were a good deal cheaper. In this case, milling is represented, a heavy, if you like, scraping of the rail, which can be delivered for £20 a metre and can prolong that rail life quite significantly. Of course, with the more elaborate techniques that Sinsin started to talk about, UTUs, that's ultrasonic testing, stuff like eddy current positioning through the rail, we're able to capture repeat patterns of data much earlier. And so we can invoke much lighter, perhaps more frequent, but much lighter and lower cost solutions to keep that rail going. We spend each year about £1.5 billion on our rail. So 30% of all the money that we spend goes on the track asset. And therefore, it's really important to us to continue to focus on this and exploit new technologies so as we can manage that life cycle more effectively. Not only does that have life cycle cost benefits, it obviously benefits our ambition to keep our assets going longer, reduce carbon. And of course, it serves up better performance for our customers as well by reducing the number of track defects and speed restrictions that we put on. To get there, though, we do need all of these mechanisms to come together and to be pulled together from a data perspective. Again, because Sinsin put so much effort in earlier to describing many of these, I don't want to reiterate those, but there is a good deal of network-wide performance monitored from actual traffic moving around the network. We've made some important changes there in the last few years, particularly the launch of that eddy current capability that picks up these defects earlier, and the way in which we're able to pull that data together and visualize it. And again, Sinsin spoke of some of the things that we're doing regarding visual imagery there. We also, at the top here, do repeat network surveys about twice every 5 years. They're very expensive to do, but that elaborates for us a change perspective down railway corridors. And so we can start to look at how the performance of the earthwork, the performance of drainage, the performance of the near environment around the railway is itself having a bearing on track. I think historically we were focused a lot more on the track, and therefore sometimes we would go in and make a track intervention when really the root cause of that lay elsewhere. And that's what we're hoping to get from these, this new insight. So what do we do with that? Well, we pull all of that together into a nice little bit of technology platform, an analysis tool that gives real insights. It gives insights regarding repeat traces. Whoops, I'll go back. Repeat traces, repeat patterns of change within the infrastructure. It means that at a moment in time, we can take a snapshot at a location and we can start to put trends on that as to where we think that asset will move to and at what point an intervention will be necessary. And for me, this is mind-bogglingly good when I compare back to where we were 30 years ago, for example, when I entered the sector. So I think the challenge around, are we embracing technology enough, remains. We've still a lot more to do there, but we've come quite a long way in some contexts. So these sorts of tools and techniques replace what used to be people having to print out stuff separately from separate systems and visualize them against the glass window. It was as bad as that historically. So you see that just embracing the mechanisms by which we can capture that data, align it, and put it in these very visually appealing and obvious solutions makes quite a difference. Also associated with this, and one of the questions earlier, we can start to hang basic machine learning off this. It can start to prompt for us some of the changes that are being observed versus the algorithms that we set up in the tool. So real-time repeat measurement of new data coming into the tool will start to reveal those differences and improve our learning and drive those decisions to an even further point. So what I'm going to go on to and go back to, I guess, is where Martin was on lifecycle costing and how we look to take this sort of data and insights and draw that up across each asset to make some really savvy lifecycle decisions. Martin introduced this slide. Mine's a slight variant on it, but I don't intend to cover everything that Martin said. Suffice it to say, it's the alchemy of asset management. Yeah, it's absolutely, I've used this virtually in every asset management presentation I've given over the last 15 years because it says so much and it's so true. But equally, some of the things that Martin said to be true, we're wrangling with all the time. How do we put lower cost, short-term measures in that are good and savvy? And this is a challenge to us right now. You can imagine our funding outlook post-COVID and with all the challenges that we face, it's likely to be more constrained than it has in the past. We've got less people traveling on our rail network, for example, and therefore with lower revenue comes an expectation we can manage that more cost effectively. Martin mentioned the difference and the balance that you strike between those various options. And we've certainly found in our lifecycle cost modeling work, and there's colleagues in the room that started this journey about 15 years ago, that at times there's not a lot of difference between some different strategies you can invoke, either to life extend or replace the asset and renew the asset. So striking the balance is right, not leaving yourself in a position where you've invoked a whole lot of low cost things which are going to introduce a performance problem that then becomes very difficult to manage, but at the same time not over investing just to secure incredibly high performance as an outcome. I think what I was really taken by in Martin's presentation was the way in which the tools that ProRail have produced are accessible and in use across the business. And in Network Rail, one of the things we've focused on in the last 2-3 years is taking what have been expert models run in expert teams centrally and getting them up onto a common web-based platform. And our intention there is absolutely to share those more widely and give better access to that sort of insight rather than at a summary level. And so we're on a bit of a journey there. And we've looked at, and we're using a couple of platforms there from Copperleaf and from Arcadis Seams, for example, tools that you're probably familiar with. They aren't the only ones available. I'm not trying to pitch for them. I'm just explaining those are the sorts of mechanisms that we're using to improve access to those solutions. And what does this give us? Well, what it does, and this slide just is a quick representation of, on an asset by asset basis, it allows us to look at different funding scenarios and what will happen to that asset over a period of time. I think the challenge came in earlier to Steve from the regulator about how you bear in mind the consequences of those long-term impacts on a 5-year, perhaps, spending horizon. And these are precisely the tools that give you that insight. They allow you to be able to forecast the change consequences of different funding levels. Here in the bottom left, it's describing what's happening on an asset by asset basis. So each asset is interrogated and then wrapped up at a portfolio level to see which of those assets are changing their condition most, and on balance, what happens to their overall kind of remaining life or net worth across the network. So again, from an operational perspective, we can understand the future financial liabilities, and we can start to plummet into some of the performance and other outcomes. And I'll come on to that in a second. The other thing, very crucially, is funding. And so associated with this, you'll get a different funding profile. For some reason, when we do this, we always show there's a bow wave of funding coming, which our regulators are a little bit skeptical of. But I guess if you take the point, it's a 175-year-old railway. It is getting older. Our customer expectations are for more trains, more reliability. That's certainly been the paradigm we've been operating in. I think what we're looking to now is finding more learning, more cost-effective interventions where we're able to, and some of our assets, so as we're able to sort of life extend further and spread out that funding requirement. The outputs that we're able to simulate and understand is a bit of a work in flight. So we've got fantastic analytics that tell us the performance that we've delivered. And you'll see here a trend in service affecting failures and how that's declined over time, broadly halving. And when we look behind that, we understand what's driven that. And therefore, there are things that we can associate with the modeling to give forecasts of the future. But it's not deterministic. It's a highly complex system and network, as I described earlier. And therefore, what this can do is pick up patterns of expectation. And again, at a portfolio level, what we'd expect to see. But that very much leaves the challenge over to Sinsin and colleagues in regions to plan out exactly how they achieve that. And how, using Martin's examples, they moderate and get that blend right between the full renewals and some of those lower cost interventions. We've also shown a significant reduction, long run, in safety performance on the network. So not surprisingly, that's a key driver for us. And understanding more from our models about the asset state, its condition, the better data that we've got to be able to preempt an intervention before a safety event occurs. These are all things we continue to strive to get better at. This is my last slide, which just simply serves to demonstrate what I said before, which is that in this space, we've come a long way, but we've still quite a bit to do to get to that panacea of really having transparent and visual analytics from technology that tell us all the things that we wish to see, and are able to do that on a frequent and readily repeatable basis. We still have expert teams that it sometimes takes 6 or 12 weeks to fully complete cycles of modeling, rather than actually be able to be more agile with that. That's obviously a constraint on how many scenarios we can run. So they're forecasting asset condition well, we're linking that to asset failure, but then you start to ask new questions around societal benefit, carbon, environmental implications of this. And again, by association with some separate analysis, we can draw some conclusions there, but we want to integrate that into one tool. So as you can play with that, you can play with the various outputs from the tool. And that's something we're actively researching right now, and will again require new technology and new support in the way we elicit and understand the data that we use. In summary, therefore, I think I've shown that there's a broad number of questions that we're trying to ask here. There's a broad number of technologies that we're going to need to continue to exploit to gather data, to collate that and analyze and visualize it, and the platforms that go with that. And I would make the point that we've come a long way, and it sounds like Martin's come a long way as well in 20 years with ProRail, but we know we've still got a long way to go to really get to the position that we would like to be at and would like to offer to our stakeholders, regulators and funders. That's it for me. Thank you very much.
Thank you very much, Tim. An excellent presentation. I think we are now switching to João Morgado, who is Asset Information Manager at the Portuguese National Rail Infrastructure Manager. They're not only managing rail infrastructure, but also road infrastructure. It's an integrated company. And I hope that the Technics can now provide us with his pre-recorded video, and then he will join us in the online panel.
So good morning, ladies and gentlemen. Thank you very much for the invitation to join you in this session. So I'll try to share what is the current Infraestruturas Portugal experience on the topics of this session. Just a few information about Infraestruturas Portugal. So who we are a state-owned company, which was born in 2015 from the merger of the former national rail network manager called Refer and the national road network manager in Portugal called Estradas de Portugal. So we are now following a combined model in terms of transport infrastructure management, including both roads and rail. We manage more than 2,500 kilometers of rail and more than 14,000 kilometers of roads. We are more than 3,600 people. And regarding the specific topic of this conference, we are ISO 55001 certified since 2019. So that gives us the proper framework for asset management, either for the rail network, for the road network. Sorry. So everything that I will be presenting is somehow aligned with this framework provided by the ISO 50001 standards. My idea for this discussion, I just went along the potential questions to discuss in this session, and just decided to pick some words, some keywords, some sentences, and connect them to detailed examples of what we are doing in IP, and trying to share with you some short messages and some potential answers of the questions that are included in this panel sessions. So starting with having clear processes or a clear process map, and at the same time to how to model the impact and deliverables of the investment. And one first example that I want to share with you is how sure are we about the condition and the performance of our assets now and over time. I think this is a challenge for every rail infrastructure managers. We manage a lot of different assets from the technical point of view: tracks, switches and crossings, bridges, tunnels, signaling, power installations. So all of them behave, and their condition is assessed in different ways. And so good morning, ladies and gentlemen. Thank you very much for the invitation to join you in this session. So I'll try to share what is the current Infraestruturas Portugal experience on the topics of this session. Just a few information about Infraestruturas Portugal. So who we are a state-owned company, which was born in 2015 from the merger of the former national rail network manager called Refer and the national road network manager in Portugal called Estradas de Portugal. So we are now following a combined model in terms of transport infrastructure management, including both roads and rail. We manage more than 2,500 kilometers of rail and more than 14,000 kilometers of roads. We are more than 3,600 people. And regarding the specific topic of this conference, we are ISO 55001 certified since 2019. So that gives us the proper framework for asset management, either for the rail network, for the road network, sorry. So everything that I will be presenting is somehow aligned with this framework provided by the ISO 50001 standards. My idea for this discussion, I just went along the potential questions to discuss in this session, and just decided to pick some words, some keywords, some sentences, and connect them to detailed examples of what we are doing in IP, and trying to share with you some short messages and some potential answers of the questions that are included in this panel sessions. So starting with having clear processes or a clear process map, and at the same time to how to model the impact and deliverables of the investment. And one first example that I want to share with you is how sure are we about the condition and the performance of our assets now and over time. I think this is a challenge for every rail infrastructure managers. We manage a lot of different assets from the technical point of view: tracks, switches and crossings, bridges, tunnels, signaling, power installations. So all of them behave, and their condition is assessed in different ways. And for instance, when IP started 7 years ago, we felt the need. So how can we access in a common way how our assets, our network is performing? And what we found was a lot of different scales to access the condition of the assets, and this happens everywhere. So we have bridge management systems, other management systems for other type of assets. All of those have different scales, and that is, as I said, it's common to find. But when we try to model the impact and try to communicate how we are performing in terms of the management of our network, we found the need to define a standardized approach in reporting the condition and the performance of our assets. And one of the first challenges of this merger process back in 2015 was, how can we report and communicate the condition of all those assets in a way that people easily understand, not being experts in the switches and crossings or track or signaling. And what we developed was a common framework, putting together existing data from each asset type, but transforming those data into what we call management information. So information that we can easily understand. An asset is green or is red, meaning it's good, it's not so good. And this challenge and the outcome of all this process allowed us to share and communicate and measure the impact of our investments in a clear way inside the company. So one of the key achievements and the message that I'm trying to share with you is that we need sometimes to speak the same language. What you are seeing here is a simple dashboard that includes the condition of all assets managed by IP, even though what we are seeing right now is switches and crossings, but we can see it for bridges, we can see it for the track, we can see it for tunnels, and using all the same scale. And when you look back, we can easily see how is our network, how is a specific asset group is performing all over time. And that this doesn't work not only for the past, but also to forecast and to use the same language all across the company to communicate how we expect to the network to behave in the future. At the same time, we also found this is particularly important in terms of being transparent in communication, and that a sum of this information was already included since 2019 in IP's corporate website. So we are not sharing the details of every asset, obviously, but what you can see in the bottom right image is a print of our website sharing yearly what is the condition of all those asset types in the national rail network and also in the national road network. So this is the first message. In terms of processes, I guess it is of extreme importance to use a clear and understandable way of communicating how our assets are performing over time. A second message, and selecting these sentences here to optimize the value, incentivize more spend, and to ensure the lowest asset life cycle costs. We also think it is very important to look at the medium to long-term effect of if we foresee a specific maintenance strategy for the coming 5 years, we need to know what will be the condition of the network, then those 5 years, and in 10 years and 15 years, and try to have a clear way to assess what will be the expected evolution of the network condition, not only as a whole, but even looking at specific asset types, for instance, track assets. If we follow a certain investment or maintenance strategy, what we can expect in medium to long-term time frame. And again, being a public company, I think it puts us an additional pressure of having a special ability to inform and clarify our investment options, as well as providing different scenarios that could include a proper balance of cost, risk, and expected performance all over this time. So, I mean, we as infrastructure managers, we cannot deal with one existing scenario. We need to clearly have the capability and to develop the right tools to help us to check what is the impact. For instance, a specific cost reduction in a given time frame, what we can expect from the network condition, or if by opposite, if we desire to achieve, say, in 10 years, 15 years as expected network condition or a distribution of network condition states, what it will take in terms of funding needs. What you are seeing here is an output of a specific tool we are developing in a European research project called IntoSmart tool within the Shift to Rail program, intended to support us to do this kind of exercise for track assets. However, track assets behave this way, but there are other assets and that probably need different and personalized and customized approaches. For instance, bridges and tunnels, they differ significantly for other asset types in the rail infrastructure, and they are designed for decades. And for instance, in steel bridges, we need to consider specific degradation mechanisms like fatigue that usually are not considered when we look to other assets that have shorter lifespans. And fatigue is not easily accessed. It's not observable in terms of the standard condition assessments that we made. And we, as infrastructure managers, again, need to have the right tools to look at these special assets and to have a clear way of accessing as good as possible this individual behavior of a given asset. And of course, we need to use technology. I'll share just some screenshots of an effort we are also doing within a European research project called IntoTrack3, and there was developed a fatigue assessment system based on numerical modeling and some inputs of specific structures. And what we have developed is a digital twin framework where those prediction capabilities or those modeling capabilities were included in order to estimate the fatigue remaining life under different scenarios within traffic or loading of the train. So this is important to have, again, the right tools to help us to identify specific realities for specific assets. Another important message in the now connecting to a systematic overview in terms of asset management systems. What asset management systems are owners implementing? Well, I think we all as infrastructure managers have the challenge to progressively have asset management systems, including all the asset portfolio. Otherwise, we cannot act proactively or preventively if we don't have a proper management system or asset management system for a specific asset type. And just to share with you that even though much thing is already done, we still have important challenges in this field. For instance, for 8 retaining structures, we are implementing a management system. We estimate to have more than 2,500 assets in the railway network and over 20,000 in the road network. And at first, the challenge is that we don't know the exact amount of the inventory. So from the beginning, we need to tackle the challenge of building an inventory from scratch. And what we tried to do is to check if different technological solutions, LiDAR imaging, the use of drones, the use of helicopters, of mounted equipment with those kind of laser imaging, tried can or couldn't not help us to have the challenge is to build from the scratch the inventory. And for that specific task we decided to test what would be the effects of using different technologies. We decided to test, for instance, LiDAR imaging using drones or mounted equipment on rail cars, or using an helicopter in some stretch of the network, since it is a mountainous area. And this first challenge was to build the inventory and to check what kind of technological solutions would give us the best results in terms of the resources and the costs associated. At the same time, there was the need also in the development of this asset management system to develop the risk-based approach. And this risk-based approach, it's not used only to treat the outcome of an inspection, but to be used at first in order to prioritize the inspections. I mean, without knowing the condition of significant amount of assets, we use this risk bridge even to program and to plan all the inspections, selecting potential higher impacts on the network operability, selecting those earth retraining structures in, for instance, areas with higher slopes and mountains and normally subject to rockfall or this type of events. Regarding some potential efficiencies in maintenance scheduling and how that could save us in terms of cost reduction and adopting some preventive measures, it came to me the following question in order to answer the questions of this panel. So, I mean, are we using all the existing data before enrolling in costly and network-wide monitoring systems? So are we getting the best result we can from the data that we already have? And we, with that question, try to access the following. For switches and crossings, we checked what what would be the output if we, using data analytics, can look at the log files of the signaling system that was previously unused information, and from that, those log files understand additional information on the behavior of each switch. And what we found was that using some algorithms of data analytics, obviously, we could at first to accurately estimate the number of movements of each switch that was information that was not available previously. And I mean, with this, we can perhaps adjust the maintenance plans, because we know how many times that switch works, and previously that information was not available. Additionally, from the same process, we got the behavior of each switch in terms of the movement time from one position to another. And what we discovered is that we can identify, in some cases, some pre-failure patterns. I mean, if the time is somehow different from what is the traditional and the normal behavior of that switch, that could mean something, and it could say us, okay, that probably will have a failure in a near future. And as I said, this was previously unused data, and with those processes of data analytics, we could try to relate and adjust maintenance plans, and probably identify pre-failure patterns. At last, one of the topics included in the question for this panel is the use of new digital innovations, and how can they help to understand the real-time health of our networks. And what I would like to share with you is another ongoing project that we are performing in IP, which consists of the use of satellite data. Free satellite data that comes from the satellites of the European Space Agency, that using this technique, this synthetic aperture radar interferometry, can help to detect vertical displacements. We, with those satellites, have information of every point of the Earth's surface with with an interval of 6 days. And with the proper algorithms, we can try to estimate vertical displacements, and that could help us in the early detection of movements in rail assets as an additional tool to other and more conventional monitoring techniques. What we are currently doing, we are testing for known bridges of our network, also for earth retaining structures, and for trying to understand in locations that we know that we already face some problems of vertical displacement, if that information coming from the analysis of the satellite data can help us to validate this connection, and in other cases to help us to act proactively. So this is a technology that several companies are developing, and what we are trying to understand is that opportunities and limitations for the mission of rail asset managers. So these were the examples that I prepared, just to give some short and in some cases detailed answers to the questions that we have in this panel, and I look forward to hear from you if you have additional questions on this. And thank you very much again.
Yeah, I think we can applaud now. I think João is real time with us now. I hope.
Yes, I am. Good morning.
Well, we have got now ample time to have partly a panel discussion, but moreover also questions from the audience and here in the room, but also from the people who watch us from home or from their offices. For the online viewers, please post your questions in the chat. Yeah, Who is speaking now? Is this Joao or not? Or that's the technical crew? Yeah. Victor, do you have any questions from the viewers at home? Fine. Yeah. Okay. Okay, but for now then let's concentrate on the in-room audience, so maybe that's safer. Is there anybody from our audience that has questions to Martijn or to Tim?
Thank you. Hannes Neel from Infrabel. I have a question for Martijn regarding the calculation you do for the overall cost of a project or a new asset. You talked about the unavailability cost.
Yes, we have the unavailability planned. So when you do maintenance, and you have the unavailability because of disruptions. And we calculate it with the number of passengers who are delayed and the number of delay minutes. And we take into account the value of time. So the value of time is determined each 5 years within the Netherlands, and it's published by our government. And then it's making the sum, and then you have the social cost of the unplanned and planned unavailability.
The real cost then of a minute delay?
Yes, the real cost are a cost of repairing or something, but they are taken into account in your life cycle cost calculation. So you have your cost.
No. I was still talking about the cost of the unavailability. So you said like so you take into account the number of passengers, the number of minutes of delays.
Yes.
But then you still have only a number of time multiplied by the amount of passengers who have the delay.
Yes. So the number of passengers
behind it.
Yeah, so the number of passengers who has delay minutes, and we have a value of time, and the value of time contains the willingness to pay for that time. So it are social costs, but it are the costs people of the Netherlands will pay to avoid that hindrance. And that we take into account, and that are the social costs. And above the social cost, you have your normal cost of repairing and other investment costs.
Okay. I hope it answers for now. Maybe if you want to know more, maybe during the break, you can have a look at the model of Martijn and discuss it in Dutch or Flemish.
Peter, I was going to add that Network Rail does something similar. In the UK, we have a delay repayment scheme for our passengers where they're disrupted and delayed. Therefore, we can quite readily account for what that liability is, that financial liability for us, either in closing a line, putting on replacement bus services, or in delaying the passengers. So I don't think that we've yet got quite to the level of sophistication to include that wider economic benefit, not within specific project business cases, but I know in discussions with Treasury, we put those factors in as well. So that's not so much a location by location basis as kind of a portfolio macro level case as to why we're committing the level of investment that we are.
Okay, thank you, Tim. Musa, you are having a question, right? Can you have the microphone over there? Maybe?
I have a question for Joao from IP. So I'm Musa Issa from SNCF Réseau. You speak about the lowest asset lifecycle cost. So I would like to know how you are going to ensure this.
Hello, can you hear me?
Yeah.
Well, I don't specifically presented a model like, for instance, Martin presented, allowing to do detailed calculations on the lowest asset management, lowest asset life cycle cost. What I tried to show is that in terms of the available tools that we use, we need also on every time to show what would be the cost of different scenarios. So my point on that part of the presentation was
the questions from Portugal seems to be a little bit difficult for the technicians now. Is there other questions in the room here for Martijn or Tim? No? Do you have questions to each other?
I think I was just going to
presentations.
I think I can give more insight again as to what we do in the UK in terms of lowest whole life cycle costs. So the UK government publishes a book they call the Treasury Green Book. And in that, it describes all of the parameters, including discounted provisions for the value of money over time. So you can do a full economic analysis. And as Martin said, you play in there the absolute cost of your intervention and the maintenance, and then that risk premium that you put on top to performance that we spoke about earlier. So there's a published set of requirements that we follow, which allows us to look at equivalence in the long term for the various forms of intervention that we're planning to adopt. And in that way, you can either justify the larger upfront expenditure because it pays back over time, or a smaller incremental cost upfront because, yeah, that's more cost advantage in the long run.
Thank you. Questions? No? I have a question for you, Tim, if I may. You also just mentioned in your presentation that you are looking at asset performance trends. Do you also look then into the future, for example, say 2030, and knowing that trains will be faster, there will be shorter follow-up times because of the TMS and things? Do you simulate with these kind of scenarios also in the way how you should maintain your infrastructure?
Yeah, so I mean, you ask a really challenging question there. As I showed earlier, we've got these long-term trends, and colleagues of mine have done enormous amounts of work trying to determine what changes we made to be able to achieve that. And also what's running against us. So the weather is more aggressive. We have repeat patterns of weather that disrupts, as well as the extreme events like we saw with the heat this summer. So to a greater extent, we understand what's driving these performance parameters. So we can have a go at looking to the future. What happens if we put more traffic on the network? What happens if that traffic is more aggressive? What happens therefore to our track degradation? And we can model that. And what does that mean in terms of the service affecting failures associated with it? So these are all things that we can have a go at. But what you tend to get out of it is a sense of the direction and the likely envelope rather than it actually being any more precise than that.
Yeah. Okay. Thank you. Yeah. Maybe one question for Martijn. How many users do you have for the application currently?
I have at the moment we have 200 accounts, but you will see that there are often users and users who use it only once a year or once in the 2 years, because project leaders has their project, they have to make a business case, and then they have their project, and they need it after 1 year. They need it, but we have also very often users, and because it's now one database, and I maintain the database, I can see who starts an assessment. So at the moment, 1 or 2 free assessments are started every week.
Okay, and that's impressive. How do you make sure that the results coming out of that model are accepted by all of the users or their stakeholders?
Yes, we try to explain the parameters, and they are validated, and we have also some audits. So that's the reason they believe it, but you have also to check the input. But in the past, we had some engineering consultancy who made assessments for us. And then we got a large calculation, and then we had to look to the method to check it. And now we only have to look to the input to check it, because also all the engineering consultancy has accounts to go into our tool and use the tool for the decisions.
So the method is accepted widely, at least in the Dutch rail industry?
Yes, they have to use this tool, yes.
Yeah, okay. In fact, I have a question. Oh, there's a question from Grant. Yeah. Does somebody have a mic there?
I have a question for Tim in terms of the models that you showed. Most of it is still related to infrastructure degradation. Do you have any models for climate change impact? Because that's going to be, firstly, more unpredictable to a degree, and secondly, going to have an impact across multiple asset systems as a railway system as a whole. Is there anything that Rail has at the moment or is developing to address that challenge that is coming?
Yeah, that's a great question. And we are certainly researching what we can do to improve what we have. I think later on this afternoon, Brian Haddock, one of my colleagues, may give a little bit more insight into this. I'm not trying to steal Brian's thunder, but from an engineering perspective, we've mapped and tracked for 20 years changing patterns of the consequence of weather events. And that's given us an insight to put alongside UK-based Met Office data, real modeled simulations of what's driving that change. And we're seeing quite a lot that's changing actually with the intensity of rainfall and when that actually occurs. And we can associate that with patterns of asset change and failure. So outside of our life cycle cost models, we can do some extra analysis that says what proportion of those type of events do we expect to occur, and how do we amend the model result to reflect what's likely to come to us. So we're at a stage where we're putting some calibrated judgments, if you like, and quantification to it. But what we haven't done yet is to build that and factor that into our models. And I think it'll be quite some time before we do. I think it's an advantage to see what that effect is outside of the model, rather than effectively lose it in a black box, if you like. So we've got there with the flooding and the seasonality of rain. Heat is a greater challenge in that we have less of those events. They're less frequent, but may become more significant. And just a quick word on that. We have seen that the kind of savvy investment we've put into the railway over the last 20 years is bearing fruit. So we've put in more robust track solutions. We put in new designs for our assets, which means that actually the weather that we encountered this summer, we saw proportionally less problems with than we did in 2002, 2003, which was a lower temperature event. So we can actually, again, start to look at patterns as to how we're changing aspects of our portfolio, making them more resilient. But ultimately, you're going to end up with a service risk associated with that. And that's what we're playing with, is what's the cost-effective point that we transition towards, not how do we absolutely prevent it, because that would be cost prohibitive.
Okay, thank you, Tim. Victor, do you have any questions? No? Or can we continue? Okay. So we are going to continue in the final part before our lunch break. We have two more presentations, of which the first one is coming from France, finally. Ms. Lea Lucas, you're going to introduce us into the wonderful world of BIM, Building Information Management. I think most of you are familiar with it. And for those who aren't, you will give some nice examples. Please, the floor is yours.
Hi, so I'm Lea Lucas. I'm an architect and BIM manager. I've been working for SNCF Réseau for more than 2 years now as a BIM manager and head of a small BIM and 2D synthesis unit. I'm working on the project EOL, and my main focus is on the design phase. Today I will present the benefits of BIM on the project EOL. But first I'd like to thank Victor for letting me, for having this opportunity to be part of this event. I'll start my presentation by giving a bird's eye view on the project EOL. Then I will explain why BIM is a complex approach on this project. Following this, I will illustrate the clash detection and management process with an example, and then I will break down the process into the main key steps. Afterwards, I will describe how we do signals visibility analysis on this project. And finally, I will point out how we use augmented reality on site. I will conclude with the openness that BIM has given us on this project and how we started using with one main use case on the project, but then we ended up with several ones, which makes BIM a huge success on this project. EAL is a complex railway infrastructure project with a budget of several billion euros. It concerns the extension of the train line RER-E to the west of Paris, and it will benefit nearly 9 million passengers with 400 trains that will be circulating on this line every day. It includes 56 kilometers of redesigned tracks and 42 operations to be commissioned in 4 years. The difficulty lies in the fact that the phasing is very complex and the infrastructure is highly dense, and also in the fact that the site works are happening on a site that is still in service. The part of the project that is being managed using BIM is 10 kilometers long. It's composed of 300 BIM models, which is nearly 13,000 objects. It's divided into 31 sub-projects, and currently we have 33% of the clashes that are being detected using BIM. But I would like to precise that this percentage is not very accurate, because it takes into consideration all the clashes detected since the beginning of the project. And at first, our model was not at a sufficiently advanced level to let us detect the clashes using it. So this number is increasing as our model is becoming more elaborate. On EAL, we have many companies that are producing BIM models, with nearly 190 persons who are directly involved in creating models of diversified disciplines such as tracks, catenary, and signaling. The main reason why we decided to use BIM on this project was to identify the clashes more efficiently than we used to do it previously. We will see with the following example how modeling signals can have a major impact on the catenary designs. This image shows catenary gantry, which is in blue, and which is obstructing the visibility of the signals that are just behind it, shown in white. This visibility problem was detected using the BIM model just 3 days before the site works. So the catenary studies were rechecked and the gantry was moved, as you can see it in the second picture, to avoid masking the signals that are just behind it and that should have been installed in 2 years. If we hadn't detected this problem at time, we would have installed the catenary gantry at the wrong place, and we would have had to move it again in 2 years, which would have been very expensive. So this is just one example, but we have more than 200 clashes detected using the BIM model, and that we are currently treating. Now, what about the process? In order to succeed in clash detection and management, things need to be structured. I'm not going to detail all the steps of the project. I'm just going to go to the main key steps. So first, we need to fix a common goal. And according to the chosen goal, we have to define the model's requirements. The requirements in terms of geometry and level of details, but also in terms of information. At this stage, a workflow is established and a common data environment is put in place and the rules are set. It's important that every person working on this project feels concerned and respects the tasks that are assigned to them. For example, some will be modeling, while others will be checking if the models are compliant to the requirements previously defined. If so, the model is added to the global one, and if not, adjustment should be done. Then we can start the clash detection process. But in reality, things don't happen in such a linear way because we receive new models all throughout the project. As a first experience with clash detection on AI, we tried using a clash matrix, but the tests were not that conclusive because we found out that it was very time consuming and not effective enough. We had more than 6,000 clashes detected at once, some of which were not really rational, but just automatically detected. And obviously, we didn't have enough time to go through all of them. That's why we came up with a new method to do clash detections that's more tailored to our needs. What we are doing now is that every time we receive a new model, we clash it with the global one, considering that the latter is reliable. And in this way, we can measure the impact of the newly received model on all the rest. Afterwards, we list all the clashes in one single file, and we fill the main information, like the location, the concerned disciplines, and the person who will be in charge of the coordination of this clash. And we illustrated with a screenshot. This tool becomes our main management tool. It helps us to follow up on all the clashes till the moment that they are solved without forgetting any of them. One thing is really important about this tool, it's that it's very simple and user-friendly, so anyone can use it, even if the person is not trained to use a specific model analysis software. In the field of railway engineering, signals visibility is a main and fundamental concern. In such a rich and complex environment as AI, we have often objects that are masking the signals. And that's why checking that the signals that will be implemented are clearly visible before implementing them on site is very important safety-wise. We have 3 methods that we use on AI to check the visibility of the signals. I'm not going to dwell on the first one, as it just consists of positioning ourselves at a random place on the model and analyze what you can see. For the dynamic method, it represents a simulation of what the train's driver can see while approaching the signal. And it helps us to do a virtual and anticipated site tour which is revolutionary in the field of railway engineering. The third method is a mathematical and objective one. It consists of creating a fictive 3D object, which represents the area of the driver's field of view, which needs to be clear. And using this object, we can do a clash detection to see where in this area objects are interfering with this area. And we created as many cones of visibility as the different types of signals that we have. In order to create them, we have to take into consideration several settings, like the train speed, because it helps us to know if the signal needs to be seen at 100, 200, or 300 meters ahead of it. Then there's the tracks axis that gives extra information about the positioning. We also have the driver's eye line. We have the standing and the sitting position, which give extra information about the height. And then the signal's shape, and we make sure to add in every signal created a visibility circle, which enables us to create the cones. Now I'm going to play a video which explains how augmented reality is being used on site on AR. Can you play the video, please?
Ce matin, on est allé à Montagny pour faire le déploiement de nouvelles technologies, projet à la Manche. L'idée, c'était de dire, est-ce qu'on peut amener des objets virtuels sur le terrain pour que les gens du terrain puissent s'identifier quand ils font un trou. S'ils font un trou en Europe, il va y avoir un escalier plus tard, un mur, et nous allons dire, c'est bizarre, on est en train de creuser là pour faire un massif, alors qu'il y a autre chose qui arrive. Ne pas faire les travaux qui devront être faits 3 mois plus tard ou 6 mois plus tard. En fait, on va aller du temps avec les entreprises qui sont en train de participer, et puis on va gagner de l'argent parce qu'on ne peut pas faire 2 fois les travaux, on a de l'argent. Là, en fait, par rapport à la position de la traverse, en fait, la structure en bois est un peu haute. Ce matin, on est venu confirmer sur le terrain les inquiétudes qu'on avait faire sur les plans, principalement de la base vue. Donc, les livres ne sont pas forcément sur le caniveau, mais la zone de terrassement sera fortement en attente. Le caniveau, on va se concentrer exactement entre les deux séries. Déjà, de pouvoir avoir pour prendre des murs et savoir, par exemple, à ce moment-là, durant la testing d'un signal, très facilement par rapport et donc, ça permet de faire des faire des gens de bien se concentrer et qu'ils puissent remarquer la différence entre le concours de référencement et le concours de référencement ainsi que la cause de la voix. Ça me fait peur.
Avec les 2 journées la semaine dernière et cette semaine, on a mieux défini le potentiel d'application. D'abord sur la réceptivité des gens, c'est un outil qui est simple et qui est utilisable avec la tête. Donc ça, c'est hyper important. Le potentiel d'aller répondre à un besoin. C'est des données qui sont intéressantes. Et puis là, vous êtes formé, on découvre que faire des choses sur le côté finalement un champ des possibles assez intéressant. Il faut dire que toutes les fonctions de paiement, il y a un énorme potentiel.
Pour moi, c'est tout bénéfice. On vient de le faire en termes de
So at the beginning of my presentation, I was focusing on how we are using BIM on the design phase. Now this video showed that you are also using BIM and augmented reality on site. Now we are trying to find out new ways to use BIM and augmented reality even on the design phase. So what we are trying to do is to adapt the method to all the participants, since every entity working on the project has different problems and different needs. The fact that we have one single model that is updated regularly and which includes all the separate models that we have, whether they are created internally or outsourced, and whether they are for design phase or execution, helps us to identify the clashes earlier and then to start the adjustments much sooner. So we save time, but we also save money. The estimated amount is about 5.4 million euros saved in just a few months. And of course, we also have a gain of a quality gain since the studies become more reliable. The means that have been put on EOL have allowed exceptional results. And this gave new impetus to using BIM on other projects at SNCF Réseau. The key is to adapt the methods to every project's needs and its budget. Thank you.
Now, leave some room for asking questions to you, Leah, but first we will have a presentation of Malcolm Taylor. He is an expert advisor on digital at Crossrail International. Is Malcolm in the room or is he on the, oh yeah, there you are. Okay. Yeah, you are one and still are one of the front runners on using digital and innovations and also BIM and digital twinning, right? And the floor is yours. Thank you very much.
Yes, good afternoon. It's a real pleasure to be with you today to be able to present and talk to you. My name is Malcolm Taylor. I'm a chartered engineer. I've been working in rail and infrastructure projects for a long time now. And I had the privilege of working on Crossrail, joining Crossrail in 2009 and have worked there since, over 10 years on the project, and moved into working on Crossrail International, which is a UK-owned, UK government company. And we work on projects around the globe, advising major clients about introducing and creating railway projects. So the scope of what we do and the scope of what I would like to do today is really talking about digital twins from a client perspective, really trying to make sure that and highlight some of the issues that have been talked about today, really making sure that infrastructure owners don't get seduced by people putting up very pretty looking diagrams of lots of digital things and trying to hide some of the issues that come from an infrastructure perspective when we think about using digital technologies. I'm just going to run through some things that might be a little bit simplified for many people here, but I think there are some very clear and key issues that we need to recognize with digital twins. So a few just general slides, and forgive me if this is all rather obvious, but I think when it comes particularly to infrastructure, not just in transportation, not just in rail, but in other disciplines, construction and the technology in infrastructure has not been particularly effective in terms of digitalization. And there's a lot of evidence to show that with McKinsey and the like 7 years ago. And if you look at that change, that typical sort of Moore's law about the increase of technology capability. And I remember my time at Crossrail over 10 years, things like storage costs had dropped about a factor of 15, processing power up by a factor of 20, bandwidth by about 20 as well, cost of sensors dropped. The timescale of the way in which technology can influence the way in which we do our work is very, very significant. So there's a lot there, and particularly we have to be very careful of people who are heavily into that technology, selling us solutions to lots of problems we never knew we had. And there are lots and lots of technical ideas that people come up with, fantastic ideas that we can grasp and try and use. But again, something of that from that similar sort of time frame that I was being very conscious of is that you get quite a lot of hype in this, and you know, some of this stuff is really amazing, but you've got to be mindful about how much use it can actually be. Quite a few interesting surveys, again, and I'm keeping it all to that particular point in time, about use of technology and people bringing in technology into their business. And I'm thinking not just, it's not just in the world of operation and maintenance, but just into their business. People bringing in solutions and processes that really just don't fit. And we have to be really, really cognizant of that. I'm still trying to work out what blockchains are. I was talking to somebody the other day about how important it was in construction, and it kind of is, and it has its place in terms of some amazing things it will do for us in the future in terms of accounting and the way in which we transact. But you kind of got to be a little bit careful to make all that happen. So when I start to think about digital twins and data, and you know, the issue of even what Mr. Mercado talked about just now when he was talking about using technology for forecasting and the like, things like the Elizabeth line, data and information is absolutely fundamental to the daily operation and safety of our railways. Absolutely underpins the whole operation and working on that basis. Information for the way in which the railway gets managed and used and the like. And I'm sure we all kind of know this stuff. When I go back to first principles about data, when we're creating these railways, when we're managing and using them, we go back to first principles about thinking about these assets. Again, we're talking about, you know, what information do we need? We collect information about our assets, length, breadth, width, you know, warranties, all of this stuff gets collected. A lot of data and information that has to come together. And again, from what Mr. Mercado was saying about transforming existing data into information. Well, this data and stuff that we collect, that comes together. When we start adding sensors to it, of course, we move into a different ball game. We start getting sort of 24-hour day, 7-day week type of reporting information that can come in, that can help us with data analytics, give us performance measures, and help us manage our railway. We get this sort of virtual feedback loop, this golden thread of information that runs around from our basic asset data. Digital twins still need all of that. We still need, with digital twins, all that basic asset data that comes together. The data that helps us describe how in which our assets are shaped together, how they fit, the basic building blocks that come together. And when we're talking about BIM, we're talking about storage, of this information, somewhere to store it, and then thinking about how we use it and bring all of that together. And the interesting thing, I think, with data, this data DNA, the characteristics of that are the same across most of the railways. Everything, huge amounts of data come from different sources, different types. Even if I look back at Crossrail project, we see the importance of structured data to enable data to fit together as lots of jigsaw puzzle pieces, but it needs organizing and structuring across the piece. And everybody needs to be using the data and information in the same type of way. But you have to get structure to that data and that information, as well as, and that also applies to our world of digital twins. I think most people are aware of, when we talk about digital twins, and we've often talked about you build two railways, the physical and the virtual. The digital twin is, as I showed on that other side to me, that enabler of making things happen. It's not the digital twin actually that's the really important thing. It's the data and information about how it's used and how it works. Because we get the data, if it's coming now through our sensors, bringing into the ability of those sensors to give us information, to start doing some processing, start doing that analytical modeling and helping us to understand what's going on. It may give us insights as to what's happening. We talked in the couple of speakers ago talking about things like the length of time it may take to understand, let's say, things like fatigue in steel bridges. It takes a long time to actually understand what's going on with that. Very hard to predict. So the digital twins can give us insights directly or indirectly, just depending on what they're going to do. So for me, when you start to get into the detail in this, in a sort of old analog world where information was being used for maintenance, it was very much a fix when fail. As we start to move into a more smarter world with predictive and smarter analysis, we do head into that world of digital twins where we begin to get real-time information, making us much smarter, giving us that prediction of what may happen to our assets so we can manage and maintain them effectively. And again, it goes without saying, there's a lot of evidence now to demonstrate that that world is not just better for our end users, better outcomes in terms of reliability, but commercially, in terms of return on investment, it's much more effective. And so we have a world where, as we move forward, thinking about how do I make digital twins happen and fit them into this, we have all sorts of questions to ask. For me, it's interesting. It's not really an issue of technology. It's a question of understanding what you want. And when I look at my colleagues in automotive and other areas, and anything to do with sort of mechanical units and pieces of plant, digital twins are pretty well advanced, pretty sophisticated, and you can see with the type of sensors, even on locomotives, even on wagons now, that world of technology is great for digital twins. Curiously, and it's been touched on before, the asset life of these types of pieces of equipment are much more similar to the whole life of actually the type of equipment that is being used to create those digital twins. When it comes to the infrastructure, it's a lot, not flaky, but it's a lot less advanced, I would suggest to you. We have much more of a problem when we think about the sort of geography for long linear assets, or things are spread out all over the place. We have, and there are ways, of course, in which we can overcome those types of problems. But we have issues about networks and things spread out, communications over long distances, and those types of things. Lots of technology available in terms of different types of sensors, transducers, those types of equipment that can give us all sorts of really clever types of information. But it's actually understanding what type of information do we need. We can get information about the slopes of embankments, how much they're moving, how much, et cetera, which we can actually do direct analytical calculations. Much harder when you come to thinking about, fatigue cracks in a steel beam. But understanding the performance indicators of our infrastructure is absolutely critical to standing back and saying, what do I need in terms of a digital twin? Because the world of sensors is, as I would suggest, pretty well covered. Lots of issues about the way in which you can set them up, but those types of technology challenges, I think, are pretty well advanced. We have to recognize we can't manage everything, and there's a whole sort of set of discussions in there. We do need to think about the risk management. We talked about Network Rail a little bit earlier on, the criticality of key assets, capturing those, thinking about the whole life costs, using costs not just in terms of cash, but costs in terms of carbon, bringing in carbon costs, so we could begin to understand those type of the environmental issues. And the prioritizing and planning are really, really important to bring this together. I think another perspective when it comes to thinking about data and information here is that we do have some standards that can help us with data. ISO 19650 can help in terms of data and information management. It's not perfect as a standard in terms of information, but it does help understand a lot of the information management side. And of course, you've got the classic ISO 55000 in terms of asset management. But actually, if you look at standards for digital twins, there are many, many standards, and that can be a bit of a cul-de-sac, a bit of a warren to get lost in there in terms of some of the ways in which digital twins can be put together. A little bit of a problem. So these are the sorts of issues that I think we need to be thinking and debating and discussing. As a client on infrastructure, you have to be thinking about that smart tech that you may be buying into. It's not something that is a whole world. It's a domain in itself of technical complexity when we think about comms networks, how that's going to work, how that gets pulled together. And you need additional skills and help to understand that world and begin to put it into the perspective within which you're looking. Be thinking about the security of that data and that information. It always scares me with my kids putting everything on Facebook because they don't own any of that information anymore. It all belongs to somebody else. The way in which we as organizations might use that data, we have to be very, very careful how that works and how people can actually break into those sorts of networks, particularly when on our infrastructure geography, we've got all sorts of monitoring systems that are widely spaced. We're adding to our portfolio of assets with all this equipment for monitoring. And actually, there's this huge, as I said before, there's this huge mishmash, or huge gap in terms of life cycle of your digital phone and the type of kit you have in the car is really quite short compared to the length of time these assets will be around. And yet you may be thinking of putting a lot of this equipment in to manage those assets. Well, you're more now into managing an awful lot more assets, and you have this issue of obsolescence. How quickly is that system, is that actual network provider or the equipment actually going to be around in 10 years' time, giving you what is vital information to you. So you've got a whole set of things there that may need to be thought about. So understanding what you need is really rather obvious. I think the issue about collecting a whole variety of digital solutions, which may be great in themselves, which can give you rather a mishmash of a toolbox, needs to be carefully thought about. Otherwise, you're going to have all sorts of incompatibility issues. And so we need to think in the few moments about the way in which much of this can be mitigated. How do you deal with some of these problems in creating the digital twins, which I have to say are a good thing as evidence-based? But how can you manage these sorts of sometimes contradictions that we have and sometimes challenges from an infrastructure perspective? Well, okay, we talked about understanding what information you need. Absolutely vital, particularly information that you've got. Again, transforming old data into information is a good thing where you can. But you do need to, I think, and I would suggest to you, you need to be thinking about how you work digitally anyway as organizations, not just as project delivery projects, but organizations. Digital twins require their own plan, I would suggest, within that type of strategy, because you do need to think about how your toolkit is going to fit together, how the analytics is going to work, and how that information is going to help you manage your business. Back to that sort of feedback loop of understanding your asset information. So preparing, if you're not there yet, preparing a plan and preparing a roadmap is critical, because you can then map things out. Because you can't do everything at once. You have, again, starting small in one area, start on critical assets alone, all sorts of things you can put into a plan to make things happen. Thinking about procurement, thinking about how do you bring these digital twins into, how do you make digital twins alive? How do you create your family of digital twins? Well, clearly the easy way is when you're building new stuff is just to lock it into the contracts. That's kind of straightforward. But you can actually extend that principle in thinking about across into other assets. I'd absolutely, and you see it with, I think, Network Rail, a great example of developing alliances, developing associations with academia to drive into your business knowledge that's coming from there. Those sorts of long-term partnerships really do add value, I suggest, to you. And then things like considering alternative forms of contract to reduce some of those issues you might have in terms of obsolescence. Where I go with this, I would suggest thinking about finance, because you'll build by bringing in these additional assets for your into your asset register for your digital twins. It's going to cost you money. So you have to think, are there other ways of doing that? Well, why not take the Rolls-Royce engine route? Instead of buying engines, they buy hours, engine hours, buy the data, work with supply chain for actually purchasing the data, and give somebody else the risk of the obsolescence and time. So trying to think about other ways of work, other ways of funding the information that you need. Think about drawing down, if you have long-term, if you can show long-term maintenance benefits through using digital twins, draw down on those future costs. I've seen that done as well. And an interesting thing for me is things like what the Highways Agency have done. They looked at the value of data in their organization, and when they looked at their entire cost of assets, 300 billion, they worked out that their information was about 60 billion, 20% of the value, the capitalized value. I'm not going to spend any time looking at lots of examples that I could show you of digital twins, other than to say across a great sort of range of Network Rail here working in partnership, bridge performance and bridges as well in partnership. There are many examples of good digital twins. And my key thing, I think, for me, is that they do give you much better decision-making. There are things to be thinking about with the operation cost benefits that you can, maintenance cost benefits that come from them, but you do need to plan and think how they're going to fit together to reduce the risks of bringing them into use. Thank you very much.
Thank you very much, Malcolm. I think there was a lot of information, a lot of wordings in your presentation. It's good, I think, that we can all collect the presentation and look into that afterwards. You also mentioned something about blockchain. Luckily, we can already prepare for somebody able. We'll get one of the presentation in the afternoon. He will slightly touch on the subject. Of course, there's different opinions on what can be useful, what not, but I fully agree with you that it all starts with having a plan in place and making sure that you have a roadmap that will deliver in the end to your strategy, to your business strategy. For now, before we go to lunch, is there any questions from our digital audience? Victor.
I have a question from Karim Duke, who is Head of Operative Asset Management at SBB. He would like to know, does BIM have a clash detector really, as a clash detector really reduce costs, or is it a replacement of well-experienced people that railway companies may not have or find anymore?
I think that's a question to Leah, right?
I think so.
Did you understand what the question was? Right. Yeah. Is the mic working? Oh.
Okay, so the question was about BIM detection. On AOL, we use BIM detection to manage the clashes, but we also use another method, which is 2D synthesis. And we use the two in a complementary way. At first, we didn't have our model was not at a sufficiently advanced stage, so we used to use more 2D, but now that the model is more developed, we tend to use more the BIM detection clashes. But we don't use the automatic detection clash, which comes with the software. We use in the method that we adapted to our needs because we found out that it was time consuming.
Okay, thank you. Is there a question from the audience? Over there in the center of the room.
Again, question for Leah. Nick Nom from Bentley Systems. Leah, you talked about having more than 300 models in your BIM management process. How did you deal with data quality issue and suppliers or different consultants delivering those models against the requirements? Was that a manual process? Was it difficult? How did you engage with supply chain to make sure those models are being delivered accurately?
It was very difficult because at first when we started the BIM process, there were no rules or requirements or anything that was fixed. So it was the beginning of BIM at SNCF Réseau, and things were not really structured in a formal way. So it was like an experimental test. So we started modeling, started creating the models without even having a structure. And in BIM, it's very difficult to structure after we have launched the process. So that's what we tried to do. Some of the models are not really very accurate in terms of data, but the new ones are much more accurate.
Thank you. Okay. Do we have another question in the room? Victor, you have any?
No, I think we can take a break for lunch.
Yeah, I thought you were saying that. Yeah.
I just like to remind anyone, if you are not logged onto the platform, please meet us at the registration desk. We will log you on so you have visibility thing that's happening in here.
Okay, so I guess we will all be back at 2 o'clock, right?
Exactly.
When we start here, also for the people at home or in the office. do have lunch and enjoy something or take a quick nap, and we all get together here again at 2. Thank you. Because we don't use the heat.
Check, 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 check. Check, check. 1, 2. 1, 2.
You'll be
we are going to. So that's, yes. I discussed with Peter, but I was just thinking, this round. You're sitting and then he's looking for it. Yeah. But we have a Q&A first. Yeah. And then yeah, I'm following your schedule. They've done my job. I was going to give you a break. Break is also fine.
Okay, welcome back, everybody. I hope also the digital audience will join us again. And we are ready for takeoff with the second half of our program today. Now I introduce you, let's say, from SNCF as well. Musa, you're a senior researcher, I think. And you will explain what you have been doing in this European project, also with regard to digital twinning. So please.
Hello, everyone. I hope you enjoyed your lunch. So today I'm gonna show you what we have done in the European project that's called Shift to Rail. And precisely the IntoSmart 2 project, which is for innovative, intelligent asset maintenance by integrated technology. This work took place in collaboration with the Mermec Group from Italy, Acciona from Spain, DB from Germany, Altametris, which is a subsidiary from SNCF Réseau, and University of Technology of Troyes in France. So this presentation is divided into 5 steps. First of all, we will set up the requirement to make a digital twin, all the operators, and then we will talk about the architecture of the digital twin that we made. And in step 3 and 4, we will talk about the data acquisition from different source, data processing and data visualization, the platform that we set up for this digital twin. And we will end with some use cases for intelligent asset management. So at SNCF Réseau, our ambition is to have more train that arrives on time and safely. To carry out our asset management for our railway assets. So as you know, every railway project is divided into 4 phases. First of all, the design. My colleague Leah talk about this morning. And build phase, when we will carry out the work to be done in the infrastructure, and operating and maintenance phases, which are too long, so we will focus on those phases for our demonstrator. But as Peter says this morning, every infrastructure manager has his own definition of digital twin. So ours was a digital replica of a physical system that connect with railway infrastructure and working practices. Its input came from reference databases in internal information system and also from the sensors fitted all around the network that serve to keep this data up to date in real time throughout the system life cycle. To make it simpler, we have here a figure that show the interaction between the human, which is the operator, the physical system, which is a real system on the network, and the virtual world, which is the digital twin of this physical system. So the operator needs information to better manage the physical system, and all the data that have the physical system are transmitted to the virtual replica of this system. And then the operator relies on this digital twin can better make these maintenance and operating activities. To make it also simpler, we have a digital twin that is divided in three levels. First of all, information level, in which we will collect all kind of data that we can get about the real system. And then we have the level 2, which is analytical level. We will analyze all data to get useful information for the operators and also for the maintainers. And the last one will be a configuration level, in which we will do some simulation based on the historical data that we can use to avoid any failure of the system. So to set up this digital twin, we start with a skeleton of digital twin. So we made a lot of meetings with all the specialists of the infrastructure. As we can see here, we have some catenary specialists, track specialists, station platform, engineering structure, and electrical mechanical system. But for some strategic reasons, we choose to focus on the track and the catenary system because we have a lot of information there, and we use a lot of time on those two specialists. So what we can see just here is a set of files that are needed by the asset managers, the operators, and the maintainers in catenary and the track system, and in which document we will get the information that he needs to do his daily tasks. And then we made a data model, a functional data model that will be the basis of the future data model of the digital twin databases. This digital twin can be updated by several kinds of data. This is what we can see here. For example, we have the data that come from track and catenary high output renewal train, which are equipped with a lot of sensors. We have data from 3-point cloud. We have data from drones and images, and also IoT everywhere in the network. And also the data from the human that he managed the network every day. So he can use his phone or his tablet to update the databases directly. Once we get all of this data, we have to structure them, to clean them, and then to process them, to extract information from raw structured data. And then we can update automatically the database of digital twin. So to show you an example of data that we can process, here you can see a 3-point cloud data processing. So we have some interacting devices, some tensioning equipment that we can recognize with some deep learning algorithm for object detection and recognition. And we will get at the end some files that will allow us to update our databases of digital twin. So the asset manager today, this was for a demonstrator. So we made some meetings with some asset managers at SNCF Réseau, and he can use this platform, which we call Altimetry Suite, to better do his job. So as you can see here, you have a lot of kind of information. You have 3-point cloud information, you have some images, and you can we can have also some BIM digital mockup here if we want. This is how we can use it for asset management. So the asset management for us, this is also our own definition. It's cover all the activities of an organization which contribute to optimize the risk. So for optimizing the risk, we have to know more information about our assets and how are they to optimize also the cost and the performance of physical assets. So every data are needed to better manage them. And also we have to take the strategic and business objective of SNCF Réseau. So tomorrow or in the future, near future, the asset manager based on the digital twin updated may have several possible services depending on its needs. Just an example that we have just achieved. We have there a construction site that we run off this approach. So we can see here before the work, during the work, and after the work. What we have before the work, we have the as-is site. So the site with all assets. So we can get a lot of information by drone, as you can see here, by LiDAR in statical or dynamic system, by operator. So we can run all of this data collection, data processing, and data cleaning, and then we update the databases. Then during the work, we can run some high output machine to get more data about the work that have been done. And at the end of the construction site, we get the as-built. So the site after work. This is completely digital way. Because we had to use some file document with some digital document, but it's not it cannot allow to update the databases. So today we can use all of this kind of data to update our databases and to get a visualization of the work that have been done. So the asset manager can see all the new changes after construction and compare them with what was designed at the beginning. Thank you for hearing me. And don't hesitate.
Thank you very much. I think we're going to have first presentation now of Abel before running into the questions. Can I please announce you? Now you're coming in your setup of for UCL, right?
UCL, so
University College of London.
Yes.
We also know each other from East West Rail, like Joao, when you're partnering to the digital twin project. And now you're also going to update us on your vision on digital twinning and digital engineering. And for most, there will be something in it for
blockchain.
Blockchain. Here we go. Special request of Malcolm.
Right, so just see if it works okay. Yeah, so a little bit about myself. Dr. Abel Maciel, I'm a senior research associate at University College London, just down the road, literally 3 minutes walk from here. But I run my consultancy on computational design, and it's called Design Computation. I'm the founding director of the Construction Blockchain Consortium, so you can find more about that in constructionblockchain.org. And there we examine blockchain technologies or DLT technologies for the construction and the built environment. I'm also the academic member of Hyperledger Foundation at UCL, and Hyperledger Foundation, or sorry, I should say Hyperledger Project. It's a project that is part of a Linux foundation, and it's developing blockchain and distributed ledger technologies for the world, and it's open source technology. And it's possibly the most industry grade type of blockchain technology you can find out there. And at my research at UCL, I look into things like artificial intelligence and machine learning, human-computer interaction, computer-supported collaborative design, digital twins and build information modeling, and also behavior modeling and game theory, decision-making theory, and distributed ledger technologies and blockchain. I run an open source platform for computational design, and you can find more about that in designcomputation.org. I'm the director of the construction work group in the Accord project, which is an open source project for domain-specific language for writing computational legal contracts. And I'm a reviewer for the SIGGRAPH, ACM SIGGRAPH, which is a computer graphics conference. So yeah, I lecture at UCL, I tutor my students there. but I also collaborate with other institutions like the Architecture Association, the École Spéciale in Paris. I used to lecture for some time at Nottingham, run a unit there. I supervise PhD students in University of Sydney, and I collaborate with the Alan Turing Institute, which is also down the road at the British Library. So about Design Computation Limited, very briefly, we do systems modeling, lots of BIM, smart contracts development. Traditionally, I used to work a lot with the building industry, the build environment, but now with East-West Rail, I'm working in transportation as well, and leading the BIM and Digital Twin initiative there with the digital engineering team. And I have some nice clients, very happy to have this list of clients here, people like Hedwig Studio, Bureau Happold, Arup, EOC, Zaha Hadid Architects. I just did a competition with Zaha Hadid a month ago, Foster Partners, etc. So very, very lucky to work with nice clients in the construction industry. And work on those nice projects and being BIM lead or BIM manager of the projects. I was fortunate to work in some projects like the Apple campus, the Google campus, the vessel in New York, working on the geometry of the vessel. If you've been in Manhattan lately, you probably saw this huge sculpture in Houston Yards, and the Royal Theatre of Rabat. And what we see happening is that the BIM management and coordination advancements are all about dealing with more complex projects, higher quality projects, you know, the tolerances are pretty tight, dealing with more complex geometry, etc. We expect more predictable results, and we want projects to be less risky. So, for example, in the Google campus in Mountain View, we have about 30,000 robots operating inside the building. And they do everything from collecting stationery in the basement, going to the lift and going back to the office space. It's quite impressive. And it has had to be delivered in BIM. And then because of that, I started to think, you know, what else can we use for improving BIM and improving digital twins? And the one thing that we came across with the Bartlett Faculty of the Built Environment at UCL was the Construction Blockchain Consortium. This is about knowledge transfer, research and development, and education and training, and trying to understand how blockchain is used. We've been very lucky to collaborate with a number of institutions, but also the UK Parliament. And one good thing about it is that this collaboration with the UK Parliament is leading to a number of white papers you can all download and read and get familiar with the blockchain technology in the construction industry. Oh, I need to breathe a little bit. I was trying to recapitulate quite a lot of things in my head. Just a second. Yeah. So one thing that we are working now is this digital practice, how we can create an architecture for the digital twin in East-West Rail, for example, how this digital practice should be conjugated and conciliated with the enterprise architecture that we are developing, and how we go about bringing what we are learning from the vision in the enterprise architecture into systems engineering. So it's all about systems thinking, processes, people, tools, systems approach to structured delivery, transparent processes, people having access to the information they need to do their work, breaking away from data silos, and this is very much the BIM vision, but not always possible. And all of this is work in progress, not only at the railway industry, but also construction. And having this federated workflows, thinking about the close coupling between teams and organizations, real-time feedback loops, etc., the long-term vision, the data quality and the data value. It's not only about solving the problem right now, but creating a data legacy that can be used later on to leverage more value. And there's data provenance as well, and what can you believe about the data you're seeing. So there are many components in a common environment and in a digital twin production. We need to think about the common environment, ECM, the BIM project, how the data from the BIM will migrate it into real-time infrastructure to inform what is going on and inform decision-making, etc. So what we see when we're talking about digital twins, BIM, this digital environment, is the need for provenance of the data, traceability, so you know where the data come from. We need to understand if that data is what it is, or it's a distorted version of what it should be, and how we deal with that. So something we've learned from the construction blockchain consortium, for example, is that it's important to have the design technology, your federated build information model. It's important to work on your Revit files, federate them, derive your CAD files, derive your asset data. You need that technology, but on the top of that, we need a layer of management technologies. And there are new layers of data manipulation emerging. They are very important. For example, management tech, we have like a team coordination software like Autodesk Construction Cloud or ProjectWise, etc. You know, this document management systems. But for example, in fintech, there is this entire world of a blockchain and tokenization and running tokenized ecosystems to deal with that value network. It's important to understand that when you talk about blockchain, it's not only blockchain. There is a bigger set of technologies. You know, blockchain is a subset of distributed ledger technologies, but distributed ledger technologies do not have to run on a blockchain. They can be just a DLT, and it is very light and fast. But if you want that immutability and provenance, then you need blockchain, or you need one of the new set of technologies that are not quite like blockchain, but also give you that immutability and provenance. For example, block DAGs. With block DAGs, you can run the validation and the consensus mechanism in the local devices, in the IoT devices. So you can validate that immutable ledger in the edge of your system. And then on top of that, we have an emerging layer of law tech. And this is quite interesting because you can run smart contracts or smart legal contracts in that distributed ledger technology. And this means that we can start to create very powerful automations with the data you can trust, because the data is immutable and is traceable. And even higher level is GovTech, and this is something that the British government was, or maybe is, very interested as per yesterday. I do hope they are very interested as they were before. And with GovTech, the good thing about it is you can bring a huge amount of automation on large, complex government processes because you're relying on data you can trust. So it's traceable system of systems for the build environment, but also for other industries. It's better governance in BIM and digital twins and reality meshes, and it's new models for network of value. So a little bit more about smart contracts or smart legal contracts. I like to say smart legal contracts because this means that we're automating the law and we're automating construction procurement or project procurement in general. So a smart contract can be a very simple thing, like you ordering a book in Amazon. That's a smart contract. It doesn't even need to be in the blockchain. You just order something, you pay, and then you receive your purchase. But when you start to talk about smart legal contracts, you can really start to think about getting procurement contracts or construction contracts like the NEC or the JCT, for example, and transform this into a computer script that you can execute in the blockchain. And because you can have this value network that you can trust, you know, it's immutable and it's traceable. You can, each token, when you have a transaction, it can execute commands, it can execute a script, a computer script, for example, and it can start to execute contract and that legal contract, but also manage a federated project bank account, for example. So it can automate payments. And this is a big step in transforming the construction industry, but also other industries. There are some good things about smart legal contracts. They are automated, as I just said. They are proactive versus reactive. Instead of having a printed contract form in your shelf and you never read it, you just read it when you have a problem. You actually have a proactive computer script executing that contract. They are resilient, so blockchains are pretty much impossible to switch off, and this might be a good thing or a bad thing. They are auditable, can be completely transparent and reviewed, and they are intelligent as well, because you embed some scripts. Those scripts can also be about machine learning and AI and other types of AI. Some implications is that they are untested, and that they do promise this unforeseen efficiency in many industries. And they are the foundation technology for the smart city or intelligent environments. It can potentially eradicate corruption in many industries, and it could create this transparent global development. One step higher in terms of computational legal contracts is that you can federate them, very much like the way you federate BIM projects. And this is interesting because when you federate a collection of smart contracts running on a blockchain like Ethereum or Cardano or some other blockchain that can actually cope with distributed computing, you have this potential to design a decentralized autonomous organization. I don't know if you came across that, a DAO. And a decentralized autonomous organization is an entity that in some jurisdictions can own a legal persona. It can own a company. And we had some examples of this a few years ago, like the DAO, for example, running investments in the New York Stock Exchange and deciding how to invest, running algorithmic trading and making money, and it owned the legal entity. And that's a very interesting concept because it's something that is very transferable and applicable to digital twins. So what other thing I should have said here is that when you have those smart contracts and decentralized autonomous organizations, you can have clients making requests on the blockchain using a tokenized system like Ethereum tokens and running processes using gas tokens in the Ethereum blockchain. And these transactions can be validated by third parties, but can also be validated by and verified by machine learning algorithms. And this is very useful for supply chains, very useful for plant tech. It can be used, for example, to get feedback from communities. It can also be a voting system in the blockchain, etc. And it is what it is. You know, there is very little room for manipulation of what has been voted for and how many and the votes counting and all that. It is exactly what you see there. There are some examples in the real world for systems using a number of federated smart contracts. One example is the health system in Estonia. Yeah, it's a known use case. It runs on the blockchain, and that the owner of the patient owns their data, and they only share with the doctor for a period of time. And the doctors in Estonia can lose their license if they use the data for longer or in ways that have not been allowed for. So it's quite an interesting concept. We are just finalizing a white paper on BIM and blockchain, and this will be released in 4 weeks and will be freely available in constructionblockchain.org. So now going back to BIM a little bit and trying to create the nexus between the work done at the Construction Blockchain Consortium and what I'm doing at East West Rail. So for example, here we have a BIM object. That BIM object has a container, conceptual mass that defines the container of that object. It has the main BIM object, and you can also have an instance BIM object in that larger BIM object, so you can nest objects. This normally comes from a template. You initiate that family using a template. That template comes from a library. And you have this cascading of a data hierarchy from the federated cloud project. In this case, I'm showing an icon of Construction Cloud that contains a federated project containing many projects. The projects have objects, and objects can nest other objects. And in any tier of this layering of data, you can have DWGs or DGNs or whatever you have in terms of CAD information. And they are referenced in as construction geometry. And the vision, I think, it's to depart from this isolated projects and I start to think about the big and open BIM architectures where perhaps there is a foundational layer for BIM where you can find all the objects you'll ever need and they've been validated and you know you can trust them. And then I thought, oh, this is a very good case for using blockchain. If you have a national BIM library that is hosted in the blockchain, you know you can trust it, you know it is what it is, you know it has not been modified, and you can use that library to compose your project. So what I've been proposing here is that we can have that collection of templates and collection of objects in a blockchain such as Ethereum. And then that would feed into the IFC for rail and the other IFC, the larger IFC ontology that I think would be a fantastic thing. And we should all collaborate and spend our time and energy in this open source project to complete this ontology. So we can then have this foundational layer that we can trust and that will help us to be agile to deliver that BIM project. So one thing that I worry a little bit, for example, if you're dealing with a BIM object that is not an IFC, if you're using, for example, an RFA, a Revit family, is that you have the IFC layer, but you have lots of other data that is not included in that IFC ontology. And somehow we need to understand how to manage that. What is going to be in the IFC, what is going to directly be populating the asset information management system, and how do we mitigate that so we don't lose any data or don't have any data duplication. So yeah, this enterprise smart asset management, as I see it, and please criticize me, it's for business case to domain specific use cases. It considers IDMF frameworks for the specific industry and therefore the ontologies. Exchange requirement as links between processes and data, and you have to have this layer of exchange with ontologies, object type libraries, the IFC extension for multi-verticals, and an asset foundation layer. Many industries still do not have a plan. So we need to consider very carefully our organization information requirements, our asset information requirements, project information requirements, and how they trace back to the enterprise vision. So something else that I do that is quite separated from the blockchain research is with my the lecturing and tutoring with my students at the Bartlett School of Architecture. And we try, in my research group there, we try to leverage the scientific method, which is not very architectural, but I try to leverage the scientific method for architecture, dealing mainly with cognition and choice modeling, and dealing with human factors and virtual environments. So we design augmented reality experiences to test cognitive processes and so on, see how people behave when they are dealing with augmented objects in a space, and how they behave using different interfaces, things like HoloLens, but also tablets. And this is quite useful to teach us how we should be designing the experience of our digital twin. So never mind having a digital twin, bringing lots of data and running those analytics and help you to make decisions. You can leverage this even more to apply it on the field. You know, when people are actually on site, looking at assets, how they should be seeing that information. And I think this is quite critical. I just had some conversations outside that people simply refuse to use them. You know, you can have the best digital twin kit ever. People just say, no, thank you very much. I prefer to just write on paper or something like that. So it's a very important thing, human factors and the cultural frontier, how we transpose that frontier. So smart assets and reality mesh, it's another critical point, I think. So when we're doing our BIM, we need to think about ISO 19650, very useful. Think about our suite of BIM requirements, very, very important. But we should not forget other things like IEEE, 828, system of systems and software integration. the ISO 12207, for example, system total life cycle, processes, design, ISO 55000, asset management, of course. Everything needs to converge to a common way of working. So if you want to know more about design computation, please get in touch. I'm based in London, an office at the Shard. We have a conference next month. It's very open. Everything that it's a peer-reviewed conference, but everything we publish is under Creative Commons licensing, so it's open for everyone to read through. I'm an Autodesk Select service provider. I work quite closely with Bentley Systems as well. And for the construction blockchain, we're literally down the road at UCL at the Bartlett School of Architecture. You can also visit our website. There's lots of information there. We're also running a conference next month, and it's a peer-reviewed conference, but we also have business presentations. We have industry presentations as well, if you want to contribute. Thank you very much.
Thank you very much, Abel, for giving a little bit of academic background to what we have been discussing until now.
Yes.
I hope you're still with me. I think there's a lot of things to lecture upon and a lot of things to share. Is there anybody who would like to dare ask a question to Abel? Yeah.
Blockchain questions, very happy to talk about them. Where's against blockchain?
Here's one. Yeah, Joao.
Thank you. Abel, very interesting presentation. I'm actually curious in terms of your perspective. We've been saying that Rail is very traditional. Some of the ideas are much simpler than what you presented today, and they're really hard to implement. Realistically, how soon do you think some of these ideas could be implemented in the railway sector? And I know we're working together in WHART actually to try and get some of that stuff in place, but.
Right. Is this, it's working? Yeah, can you hear me?
Yeah.
I guess the shortest, do you want the shortest or the nice answer? I'll give you the short answer. It depends how hard you push, you know, because in the construction industry, we had the BIM mandate. And I remember I actually started my consultancy because every day I had requests of people saying, please help me with BIM delivery because we need to meet this mandate. I think we need something similar for the rail industry. I don't see why not.
Is there any reaction to that statement?
So would you say that if you have a useful use case, success story demonstrating the value, you think that's sort of what's needed to actually implement this stuff in a larger scale?
Yeah, I believe so. I sincerely believe that if we have use cases demonstrating the value gain of the application of those many technologies like a BIM and digital twin, we need a top-down mandate from the government to accelerate adoption, because cultural resistance is very powerful. And I saw this in the construction industry. Until we had the mandate, the UK was far behind in terms of the construction industry in the UK, was very behind in terms of BIM adoption. When we have the mandate, now the UK is one of the leading countries in BIM. Yeah. So we need that push, and that push needs to be top down because that's how we propel adoption. And working with Royal Haskoning, working with East West Rail, what we see is we got a collection of use cases that clearly show the benefits of the technology. Yeah.
Okay. How is that mandate organized in France? Can you say something to that?
So it's
It's on. It works.
I think it's the same problem that we have in France. I mean, all the cultural policies that we have in France, they are fighting against digital transformation because they use it to work with, I don't know, usual way with their document paper and their practices. There is no clear process that they used to work with, so they don't want to migrate to the digital era.
But is the use of BIM in railways now mandatory in France or not?
We try at SNCF Réseau, we try to make it mandatory, but it's not. Yeah, it's not. We are working on some use cases to push eventually, but it's not.
Okay. Is there any other question from the room? To Musa or to Abel? Yeah, I would like to ask a question. I think you also explained that the digital twin of you have it first as designed, and of course as built, later on maybe as maintained, as is. How do you keep the digital twin actualized that you were using?
So to keep the digital twin actualized, we use a different data that we show, basically the 3D point cloud data, and also the data that come from sensors and the IoT system everywhere on the network. And we get those data. After processing them, we can keep the digital twin updated. So if it's not updated, it will not be used by the maintainers and the operators.
And how do you make sure that the quality of the data is then okay?
So we are working on some KPI to trust the data that we can see in the digital twin. So we worked with the users of those data to better understand what they do, what data they need to work. And we have an indicator of the confidence that we can have in data based on like a system like Facebook. So when we use the data, you can push a like, yes, get feedback, so the other people can trust more or less the data.
And does that work?
Actually, we have the demonstrator, but it's not implemented yet.
Okay, so we have to hear more from that next year then. Hopefully.
Yes.
Yeah. Okay. Is there a question or maybe from our audience, virtual audience? Victor? They all continued with their after lunch dip, of course. Yeah. Then I suggest we continue with yes. In the back. Yeah.
Hi, Brian Haddock from Network Rail. I just want to ask a question here because I'm slightly confused. In regards to the railway, I wonder if it's better semantics because there are lots of things that are already simulated, and you could potentially call them digital twins. I'm thinking in terms of signaling systems and traffic management systems that we already use. So how does that build into what you've just talked there about? Because it sounds like this is all very new, but actually I imagine as concept it's not.
Is that a question to Abel or to Musa?
There, the man in the middle.
For me.
Okay. Yeah, so there are levels of maturity of digital twin, the digital twin application and how they are put together. So running simulations, for example, a timetable simulation, for example, or energy and power simulation. This is not quite a digital twin. A digital twin is when you have your build information model, you have your timetable, and you put everything together, and you also have live stream of data from sensors, right? So that would constitute a digital twin level 0, I believe, or level 1. From the moment that you start to become more sophisticated, then you have maturity level 2, 3, 4. Nowadays, the highest level is level 5. And this is when you start to run predictive analytics to inform decision making, etc. So I think to answer your question is, yeah, running simulations is one of the components of or subsystem of a digital twin that has not been integrated yet on this live flow of data and all the many components you need to have, all the many aspects you need to have in place and integrated. Does this make sense?
It does, but we also run, from the predictive elements that come out of traffic management system, we run a amended plan for engineering works, for example. So the predictive bit is there. I just wonder how it integrates with some of the systems that we currently use, that's all. Because, and it's not just that, the human element, I guess, is that I feel that there's quite a lot of assumptions that if we take the human out of some of this, that actually these digital twins will just provide the perfect scenario for us, but we know that's not the case. And we learn all the time through the operation of the signaler, the driver, etc. I'm just saying how that gets embedded into these systems and at what maturity level.
Yes, again, I think we're all wondering, how that is integrated. Because if it's very robustly integrated and helps all the aspects of the enterprise, that would be a very good digital twin with a high level of maturity.
I think you wanted to add something.
Yes, I want to just to add something on the digital twin maturity. So I think we have the same with the BIM, because we have the load, the level of the details for the BIM. So we have the same thing. Digital twin concepts is so old, it's not new, I agree with you, but it was known for the manufacturing domain. And what we are trying to do now is for railway system. And we have a lot of assets on the railway domain. So it will take a lot of time. We have at the level 1 or 2, but in the future we will get the perfect level, I think. And for simulation, we need a lot of data structured to have the perfect scenario to avoid any failure or any dysfunction of the rail or the network.
No more questions for now? Then I would like to call Bas Peepsterboer from the Netherlands here on stage. Bas, you're advertising yourself as being an EAM evangelist. And probably some people do not understand what it means. Perfect. You have to convince them as it works.
Thank you very much. Does everybody hear me well? I'm quite far from the microphone, but my voice is quite loud. So, yeah, thanks. So EAM evangelist is, I am not a religious evangelist, don't worry. I'm not here to preach, at least not my gospel, if you will, is asset management. And I realized when I was preparing myself that there's quite a few 3-letter acronyms, or TLAs, as we call them, in my presentation. One of them being EAM, and EAM stands for Enterprise Asset Management. And the other one is the company that I represent, which is IFS, which originally stood for Industrial Financial Systems, and which is a Swedish company that I will introduce further. But first, about the evangelist himself. Oh, I think I should be able to click next. There you go. So that's me. I've been an EAM person, so an asset management person all of my life. Started out in the food and beverage industries, particularly Knorr dehydrated soups that you may sometimes buy. Highly recommend those. And after having worked in the maintenance department of Knorr soups, I moved over to the IT world, and I started as an enterprise asset management, or as it was called in those days, CMMS, or computerized maintenance management system. For a Dutch company based out of Rotterdam, moved into project management roles and later into more sales roles, and even a little bit of marketing. And since May, I work for the Industrial Financial Systems, IFS company out of Sweden, as an evangelist. So basically, I talk about asset management. Is what I like most, is also what I have a lot of experience with. Including in the rail industry, not with this company yet. I mean, I've done, and there are some people from ProRail here that are familiar with names like Asset Rail or Infraspeed out of the Netherlands. So those are companies that I've worked with in the past in previous companies. But I know the domain quite well. Also from a rolling stock perspective, which is not today's topic, here in the UK, I've worked with Southeastern Rail. Phil, you have to tell me. Abellio, ScotRail, for example, and OneRail, which became Greater Anglia. So I know the railway industry quite intimately, and I want to talk about what IFS does in this industry to be special. So that was the three-letter acronym. So today I want to talk about a little bit about the introduction. I want to talk about the company so that you know who IFS is. I know that everybody knows SAP. Not everybody knows IFS. After today, everybody will. Some observations about the infrastructure sector. I want to talk about a few industry challenges that we see in our customer base coming out of, let's say, the old normal into the new normal, into the current reality. And then how to maximize the opportunity based, of course, on, let's say, a software provider vision of digital twins, asset investment, and all the topics that I've heard people talk about today. It's very interesting for me to see these perspectives, and especially the scientific ones. Thank you very much. Because I can relate to many comments that I heard. Also, I think your question was spot on about, you know, digital twins and digital transformation is hard, right? And it is hard for everybody, I can tell you. But still, you know, we all want it, we all need it, and somehow we need this to provide the outcomes that society expects from us. So anyway, IFS, just in one slide. So IFS is a Swedish software firm. Originally started out as a maintenance management application for the nuclear industry. Our mantra is it started in a tent. 4 students basically built a maintenance management system from the ground up for a nuclear power plant in Sweden. And they were sitting in a tent while they were overseeing the construction and designing their system. The system has grown massively over the years. So we have now around 5,000 employees. We sell approximately 1 billion of our, let's say, not 1 billion worth of our product per year. It's a cloud-based application suite, and it is one product. So our product is called IFS Cloud, and it basically covers asset life cycles. This is what we really want to portray: enterprise asset management and asset lifecycle management. That's what you do with IFS. So, having said that, we find you will find IFS in many sectors. You'll find us in large airline operators. You'll find us, our companies maintaining oil and gas installations, floating oil rigs. You will find us in wind turbines and wind farms. But let's say if we focus a little bit on the infrastructure and construction sector today, you'll find us in infrastructure, railway infrastructure, telco infrastructure, energy infrastructure, utilities, construction engineering, and telecommunications, plus manufacturing and, let's say, other sectors that I will not go deeply in today. So just a small subset of our customer base in the infrastructure space. I think that the most relevant ones are the ones on the top left, which is NG Bailey, construction firm, Babcock Rail or Babcock International. Babcock does not only maintain and build and construct and design a railway, they also design warships with our software. But all their projects, and I have a little bit more information about Babcock in a second. Systra is a large French that you may be familiar with, construction firm. Then EDF, the renewables, I think it's nice in the UK, and it's also a little bit in the spirit of sustainability today. 36 wind farms, you know, in the UK that are being constructed and operated by EDF Renewables using IFS for the asset life cycle. There's many others that you can see that we will not have to mention, you know, each individually. So one in particular I wanted to mention is Babcock Rail. Babcock Rail, you will find IFS not so much on the owner side of railway infrastructure. You'll find us on the owner side of telcos, of utilities. On the railway infrastructure, or you'll find us predominantly on the contractor side, such as Babcock Rail, but also Systra in France, which use our application to build, maintain, and manage these critical assets, you know, that you see a little bit in the background with this Babcock engineer. In total, so that includes other projects for other sectors of Babcock International, you'll see that they manage more than 4,000 projects with our, or they haven't been managing more than 4,000 projects with our software to date, based in multiple countries. And I think that what sets us apart from, let's say, other vendors in the IT space or in the enterprise software space is that we very much focus on these two areas of the asset, which is the project to construct, to commission, to build, perhaps to design, and then the operate and maintain, so the asset part of it, which is like indeed operate, maintain, decommission, refurbish, redesign, etc. And these two factors are not always, let's say, available in the, let's say, in the EAM or in the asset management, in the software space. As I said, I come from another, let's say, a competitor of IFS, and there we implemented, for example, at AssetRail. In AssetRail, we kind of had to struggle to link the complete asset lifecycle in one solution. We had perfect maintenance capability, but we did not see that kind of a link to the design, the commissioning. And what I'm very happy with on the IFS side is that this is completely integrated, so we can fulfill that complete story, just like these guys do. So Babcock Rail, they do not only, let's say, railway infrastructure, consultancy, on track, they do rail training, but also telecoms, track projects, track renewals, signaling, etc. So quite complete set of projects along the linear asset with everything that comes, all the point assets that are found alongside. There's even a customer case study of Babcock Rail to be found on our website, mostly for their other projects like the Navy warships. And I think Phil mentioned a few things that they, and now it escapes me, the other things that they construct, they are large. So that's Babcock. Now the infrastructure business today, I think, well, as I said earlier, and I'm sure that it is cliche to even talk about COVID, even though some people say that it might be coming back. The new normal is the new reality, but simply traveling here, for those of you that came on a plane or maybe on a train, you have noticed that stuff is different, right? So after COVID, what do we see? Well, we see personnel shortages. I had to wait longer than normal to get checked in on an airplane in Amsterdam this morning. We find also that our IT systems have been, let's say, exposed to a situation almost like a black swan event that we would never have expected. Like all of a sudden, we couldn't go to work, we couldn't access our computer terminals, and basically the companies that were sitting with their application, let's say, with the application landscape in the cloud that could still be managed remotely with, let's say, employees that could access via an app or via home, they were resilient, whereas like others that had still kind of on-site IT systems, they were struggling to keep the business going. So we see a huge trend to move even, or to accelerate the move to cloud-based applications than what we saw before COVID hit. We see a change in customer requirements. I think, given that we are working from home, I'm sure that all of you also see that less people are using public railway infrastructure or public transport infrastructure. And if they still do, they do it differently. And this, of course, has implications for everybody. This is implication for funding, for finance, for maintenance, for asset management, for all of that. And I think all of these changes, we see new business models, maybe not so much on the railway side, but I'm not sure whether you heard of this concept called servitization. But servitization is a trend that you see a lot now in the manufacturing space, where instead of selling you a car, people sell you kilometers transportation, right? Instead of selling you, I think I was looking it up the other day, instead of selling you a vacuum cleaner, people sell you a cubic meter, or no, probably a square meter of vacuuming as a service contract. This is nice for at home, but we see the same thing happening with wind turbines, for example, that the owners of wind farms are no longer owners of those wind turbines. They're actually buying them on a kilowatt hour basis, for example. So huge changes in business models that kind of were accelerated from, let's say, maybe this 3 years that we were all sitting at home and thinking how to change the world. Supply chain has changed. This one I don't need to mention. I think I saw a debate in your parliament or in the UK parliament on TV when I walked into the hotel about energy prices, and every country I think is struggling with how to manage this, how to mitigate it. But what I've seen already in our own customer base, that plants are shutting down, like heavy industry plants are shutting down temporarily simply because the energy is too expensive to keep on producing. This is huge. And all of this is kind of coming out of that geopolitical / climate situation / corona pandemic that we've been experiencing. And the last one is labor availability. I already mentioned that I had to wait longer than usual, at least getting checked in. I'm not sure if that is pervasive in all airports in Europe, but I know that in Copenhagen, in Stockholm, where I have lots of colleagues, traveling back and forth, this labor availability also has or let's say unavailability, has a huge impact on how we do business, how we run projects, how we maintain assets, why we maintain assets also. And all of these factors are looking for a solution, sometimes political, sometimes economic, but definitely also system-wise. So you need to adapt. You need to be able to adapt, to transform yourself. And everybody, I think when you mention the word sustainability, people think it's a kind of a cliche word. Now there's a new word for sustainability. It's called ESG. You may have heard it, another TLA. ESG stands for environment, social, and governance. ESG is a new term to say how we can operate sustainably. And it includes also the social aspect, what is it, like gender equality and many other things that we want to kind of take into account when we do our business. All of this has changed, and all of this is changing the way that we do stuff, including technology and including asset management. So there's a need to act, because somehow we do need to create these stable revenue streams. We do need to cater for asset lifecycle providers. We have new outcome models, and the technology is advancing, and you mentioned it. How can we use that? But somehow, since the scholars create use cases, and we all want to adhere to them, but of course, it's not so easy to implement that on an industrial scale. But we do have those asset outcome-based models, yeah? Vacuum cleaning per square meter instead of buying a vacuum cleaner, just to keep it simple. New ways of construction, asset performance management, increased efficiency, agility, nice words. In the end, these are the outcomes that you want after your transformation, if you will. So the critical enabler to do these things requires automation, requires robotics, requires drones. I have heard that the next presentation is about drones, so that's perfect. We've talked about a little bit IoT. You mentioned it also. Predictive maintenance, predictive analytics, artificial intelligence, digital design tools. There was a lot was said about BIM today. Mobility, cloud solutions, and then an integrated business systems, obviously, to put it all together. Somehow somebody has to do the job. The only thing, I loved everything that I heard today, but the one thing that I kept on thinking is, it's great to make these models, it's great to have these investment plans, but somebody still has to do it, right? So, and this is actually where we play. I think we and also our colleagues from Germany, the other three-letter word, is to help your constituents, your stakeholders, your contractors actually do those things that you are thinking about and thinking of and developing. So the world is changing. The world has changed a little bit, but I think, well, with the current situation, with the energy, with all these new models in the back of our mind, there's a couple of things that I wanted to highlight as kind of trends that we see, and potentially, interesting things to discuss about further. So the one thing would be, or the first thing would be contractor integration, and contractor, take it widely. I think, there's many people that work on a railway infrastructure. That can be contractors, that can be workforce that is internal. But especially on the contractor side, we see that there's a lot of demand and need for tighter integration. I think you mentioned, the data that needs to flow from contractors into the asset owners' common data environment. All of these things have IT implications, because somebody, again, has to actually do the work, right? So we cannot tell a robot to go and fix a switch somewhere or to change a switch from electric to gas fired. There is still somebody that actually has to do all these things, and they need agile IT as well. Digital transformation, obviously, I mean, everybody talks about it. I loved your statement, and I have a nice slide to illustrate exactly what you said. It's important. It's what we're doing, all of us here in this room today. We're digitally transforming our business, but it's not easy. And you need to know where to start, and it needs to be based on those outcomes. It needs to be based on, let's say, the outcomes that you predict and that you want, and the results that you need for this, let's say, for this digital transformation. And the last thing is, and of course, this is a little bit where IFS comes in, of course, is this integrated, holistic solution of, let's say, asset from cradle to grave. I think it either says in the introduction or it says on our flyer that you can get from our table outside. This full asset lifecycle support that I want to dedicate a few words to. So let's start with contractor integration. It's clear that not only related to COVID, there is increased competition in everything, but especially in finding labor. Apart from that increased competition, there is an aging workforce, and there's a lot of knowledge that still sits in the heads of well, when I started in the Knorr Soups, it was my uncle Pete who actually ran a team in the maintenance department of the soup factory. Uncle Pete unfortunately has died in the meantime, but all those people that he worked with are now pensioners, and they had so much knowledge about the machines, the assets, the processes, how the plant worked, etc. So this is still a pervasive problem, and of course, it doesn't get much better, and especially when we have to compete for labor, it only gets worse even. If we don't have the right tools, we don't have the correct productivity. I think there's pressure on everybody, and especially now with the energy prices, with the situation outside as it is, that margins are extremely under pressure. So there's this enormous pressure to keep on performing, to keep your assets alive, to keep them doing what they do, but the price that you have to pay will stay the same or should be lower, and the cost to run it is actually increasing. So these are all difficult themes to work with. There's a couple more here that you can see, poor project delivery, or performance, low investment in technology. I don't want to talk bad about the construction firms, and definitely not about our own clients, but what we see is that this workforce requires tools. Also, when I worked in my previous role with the Dutch rail contractors, it was mobility is what they wanted. So I think, and I'm sure that we are not the only one, providing workforce scheduling, workforce optimization, dynamic scheduling, and mobility for those people. But I think it is key to have the right tools in the hands of the people that actually do the things that we are all talking about today, right? So there's still somebody, gray-haired or not, or both, just like me, to actually do these things. And these things need to be done in conjunction with a digital twin, whether that is a GIS system or whether that is a BIM or whether it is a CAD, more three-letter acronyms, and probably not the last ones either. So to work from the map, to have an attractive, easy to use interface for the people, whether they are highly skilled and schooled or whether they are not so highly skilled and schooled, data acquisition and data entry must be easy for everybody, and people must be, especially in your sector, able to orientate themselves when they are out there in the field. So work from the map. Digital transformation. This is the slide that I wanted to mention. I think if you look at this slide, and I'm sure maybe I was sitting in the back this morning and I couldn't see these small prints, so probably you can't either. But the first one is BIM. Interestingly, in this list, which was compiled by KPMG, it says that BIM is the most implemented technology in all these digital transformation themes. You see BIM, there is a virtual reality, augmented reality, RFID, AI, and many others. Speaking of AI, AI is a critical component of many predictive analytics tools and many predictive maintenance solutions. Everybody talks about it. If you go to a conference, not this one, a more commercial conference, there's one software provider like me, and then for every one software provider, there are 10 AI providers with very boutique solutions for a particular use case. There's a lot of availability on technology, but if you look at this, I think there's that the most adopting, let's say the most forward-thinking companies are actually implementing BIM. Almost nobody. Only there's a small portion of these forward thinkers. That's the top line, by the way. The laggards are the lowest line and the top thinkers are the top line. Artificial intelligence. Everybody talks about it. Everybody wants to apply predictive analytics for asset performance. But how many people actually do it? Well, not so many, because it's hard. Because you have to, this whole ecosystem has to kind of come together, right? Data acquisition, data gathering, you need to have the technology, the smart assets, you need to have the technology to do something with it, and then to roll it out to the people that actually have to execute this predictive maintenance. You know, to have a model and to have a prediction is one thing, to have a guy from another company, a contractor, actually go out on site and do it and know where to do and what to do, that's another. So it's not so easy, but it is there, and that is great. So, oh, this one. I clicked too quickly. Yeah, excellent. So just to sum it up, I think digital transformation, so the previous slide was not so easy to read, but it gives you a kind of an idea. BIM, especially in the UK, I heard about the mandate, very popular. AI, very popular topic, not so very popular to implement yet. But still, all of these themes are technology themes that people need in their asset lifecycle, whether it is contextual intelligence, which to me is almost like digital twin from our perspective, but a little bit more about that later. Augmented reality for the worker on site, maybe with remote assistance. This is one of the, let's say, attractive soft, let's say, solutions that we have in our cloud. The possibility to have the gray-haired expert still productive, but sitting at home and guiding the younger guys into, let's say, seeing what they see, but guiding them in what they have to do. IoT for data, automation, simulation is a word that I picked up in the previous implementation of previous presentation too. And then digital twins. I think digital twins and contextual intelligence, for us, it's almost the same. For us, the digital twin, and I think I heard you say that there are many definitions of digital twin. So here's another one. We see the digital twin as the enablement, or let's say the visualization contextually of the asset, but also the function it performs, the process that it belongs to, and the organization that it is, let's say, the owner or the maintainer of it. You cannot, in our view, only talk about the digital twin and say, well, this is a pump or a motor or a turbine or something like that, and we're looking at it, and this is now our digital twin, and we contextualize and visualize all that data. It's also important to know where it sits, you know, what is affected if it doesn't work, and which business objectives of the organization, the system it functions in, etc., are now affected if this digital twin. So there's multiple levels of digital twin, if you will, and so this is a little bit our spiel. I think sometimes when I talk to people about digital twin, they say BIM and CAD, and that's it, right? So I think we all agree that it's a little bit more than that. Okay, good. At least the science agrees. So digital transformation, and then the last thing was to do, let's say, to say what sets us maybe apart from others when we talk about asset management. And I think, you know, the key thing is what is asset lifecycle? I picked up, and these letters are small, but you can find it for yourself in a document that's called the Anatomy of Asset Management by the Institute of Asset Management. And they say asset lifecycle, 80% of the cost, total cost of ownership of an asset, and this is excluding energy consumption, I think, because energy consumption is a pretty important factor for the total lifecycle cost, is the inception, the design, the commissioning, the buying, etc. So we cannot ignore that, but you know, the world that I come from originally, the asset management space, talks about work orders to fix, work orders to maybe to repair, work orders to replace, but not this whole process that sits at the beginning, the project space. So it is project performance plus asset performance. Once you own the asset, that together is asset lifecycle. If we take this a little bit further, you know, there's a nice slide of all the things that we do when we talk about projects: shipping, commissioning, handover, project inception, etc. on the construction side, and then on the engineering side until you finally have it, with a description of what project performance is, according to us. And then asset performance at the same time, which is once you have the asset, once it is installed, once you are maintaining it, which is to do reactive, preventive, condition-based, reliability, predictive, you know, IoT, all those fantastic things, improvements and planning, you know, and let's say all the other tasks. But look at the description on the left. The description on the left actually comes from an industry watcher that says, you know, it is about, you know, creating reliable or creating asset reliability and availability goals. This is what asset performance management is. It's not about doing the act of maintenance. It's actually providing outcomes. Why do we do things, right? So we, and I'm guilty, often talk about the what. You know, we provide fantastic systems to you. but we forget to ask you why you should actually use it, right? So you should use that in order to become better, to be more sustainable, to reach carbon zero, to make more profit maybe, or to lower your cost, or to be more ESG. Those are the reasons why we do asset performance management. And of course, digital twin, always in the middle. But of course, since there are hundreds of definitions of digital twin, we have our own. What IFS do is that we combine the two, so that we have, the project and the asset interacting in almost like a closed loop. Once you have the asset, once you buy the asset, it's a project, then you have the asset, then it's an asset performance. And then of course, when you need to replace or when you need to modify, it becomes a project again. So the one thing that I wanted to add to this, and then I'm almost done, is where do people take this from here? I heard somebody say, I think it was Tim, I don't know where you're sitting, oh, over there. Some names of companies that provide asset investment planning tools. We work with those same two companies that you mentioned, because they're kind of the best of breed, top of the bill, AIP. It's always nice to be able to have something yourself, but we realize that the knowledge that comes from those two that Tim mentioned, and I will tell them to you at our booth, if you forgot, are, let's say, the next stage. If you take your asset performance, so you know your degradation or your decay, and you have the models and you have the actual performance of the asset, your next step is to create these funding pictures and to evaluate project alternatives and investment alternatives, and to spread out, let's say, the financial needs, appropriately in function of the asset performance. And I think also in function of the social, I would say, environment and economic environment. You can say that I want to focus all my money on creating more performing assets, but if nobody buys what you make because the energy price is too high, maybe you should not focus on asset performance at all, and you should just minimize your own cost and make sure that you survive kind of the economic downturn until you can start selling your stuff again. So there's so much to talk about, but this is what asset investment and asset project portfolio tools do. They help you create this long-term investment plan, the annual investment plan, the investment strategies based on all the things that you know about the assets in the project and that you know about the assets performance. So just a couple of slides to finish it off. I think, a digital strategy is what we help our clients with. Of course, we would say that it's a must-have for that particular reason. What we see a lot, if we take the two, let's say, parties or stakeholders apart, there's contractors and there's asset owners. Typically, we cater to both. I already mentioned to you that on the railway side, mostly for us on the contracting and engineering side. But still, what happens is that there's a myriad of systems, and not only, they are very kind of, well, of course, it is drawn like this with many arrows on purpose. And then I think I also heard somebody say there's lots of Excels. Everybody has Excel and Access and maybe also other tools to do these things. And then, how do you make one solution out of it? Of course, here comes the marketing, just warning you in advance. The IFS, but really what we want to, what we want you to take away from this is that there is like the possibility to have this project focus of the asset and the operate and maintain focus of the asset in a nice tool that has all the other digital enablers, ready for you as well. So, of course, we are not alone. And some of them were mentioned already. So there's even some names of competitors here, but they're not listed here as a competitor. It's more like an example of an ecosystem that you probably own. For your project planning, you might use an Oracle Primavera. I know that there's a gentleman from Bentley in the room. So fortunately, your logo is there as well. Hopefully also in the right bracket. So there's BIM tools, there's CAD tools, there's collaboration tools, investment planning tools, GIS information systems or GIS systems. But all of this needs to communicate, right? So, and I think, you mentioned blockchain. We were not there yet with blockchain, by the way. So it is mostly web services, RESTful APIs and that kind of stuff. Open standards, yes, for data exchange. And I think it is key, and neither our competitors are going to do this complete picture with all the design tools. You have your own flavor of design tools, your own flavor of digital twin design, and your own flavor of project planning tools. But still, remember that one thing, maybe if you just remember one thing, there's always this one guy that has to do what you are thinking about. He actually has to go to that switch and change it. Yeah. And this is the person that needs to be given the right tools at the right moment, scheduled efficiently and all of those things that apply. But this is where we shine. So, well, there's just a couple of screens of our presentation. I think, so it was, I hope that I didn't overstay my welcome.
No, we are running into the break anyway. So.
Excellent. So I have another 10 minutes. Okay, then I go back 5 slides. Just kidding. I think what I hope that I pitch to you is that, that IFS is a provider, and we would like to talk to you about these outcomes, about what we can do on the life cycle side, on the asset outcome side, on the investment side, on combining these projects with finance, with let's say with asset management. And just for the gentleman over there, so we also integrate with SAP. So I mean, IFS is an ERP system, but we are completely aware of our ecosystem. And even though we did not put, let's say the logo of our competitor on the previous slide, we actually do realize that, they are incumbent in many owners. Fortunately, that leaves us a lot of space on the contractor side. At the same time, we can also integrate our software with other ERP vendors. So IFS is sometimes known as an ERP only, and this is not true. So we are a project and asset engineering solution, as well as a financial place. So I think, yes, I only have the thank you slide after this. So we'd like to help you with this. Thank you, Peter. Thank you, other speakers, and you guys in the room for educating me today.
Thank you very much for your contribution. I cannot think about that somebody would be in this room having a question to you, but you had one question to us, being the audience. Does everybody know now who IFS is? Is there anybody that does not know how IFS is? I think then I suggest we go all out, have a break, and if there's questions, they can ask you.
At the break, and by the way, we brought some nice coffee mugs. I have to say, it's not so sustainable, the paper cups. So come and collect your own IFS mug at the IFS stand, around the corner. And if you don't like mugs, come and get a pen. Okay, and I hope to see you there. So.
We are all back at 15:50 in this room, please. Yeah. Thank you.
Welcome back, everyone. So we're now starting the final sessions of the day. We have a presentation from Infrabel and SPV, and we'll start with the Infrabel presentation with Didier and Sylvain, who are going to talk about two use cases on use of digitalization in Infrabel. We'll have time for questions because they both have to leave prior to the end of the session. So we'll have a couple of questions time, and then we'll move to the SPV presentation immediately after that, which is the video one. So Didier, please, the floor is yours.
Okay, thank you, Joao. I would like to thank the organization to give the opportunity to Infrabel for the presentation of some use cases. Infrabel is the Belgian railway infrastructure manager, and so we are responsible for the maintenance and the renewal of the infrastructure in Belgium. I am the manager of the division of civil engineering. So my division is responsible for the policy of the maintenance of our bridges and tunnels, and we also write the regulations on the maintenance and renewal of our structures. And we are also responsible for the design of the new bridges in the case of renewal of the existing infrastructure. So our presentation is in two parts. I will deal with the part of drones inspections, and my colleague Sylvain will treat the automation of inspections of drones, of switches and rails. The maintenance of bridges in Belgium is organized as an inspection-based maintenance. So we inspect every bridge every 4 years. So we make a report of this inspection, and based on our the conclusions of these reports, we build up a maintenance and renewal program. So that means that we have to organize ourselves to take a look at every bridge every 4 years. The last few years, we used drones to give us a help with these inspections. And drones, we should interpret it as in the large sense of the word. And it can be as well a flying drone as an underwater drone. So it's every remote operated vehicle that gives us a help with the inspection. The first case I would like to present is an inspection that is executed by Infrabel itself. We are divided in 5 geographical areas over Belgium, and in 3 of these 5 areas we have our own drones. So we use the drones for specific inspections of our bridges. This case here is a metallic structure, a bowstring bridge with a span of about 100 meters. And we wanted to inspect the high parts, the connection between the inclined hangers and the arch of the bridge. And we also wanted to take a look at the condition of the corrosion protection system on top of the arch. So we gave very specific instructions to the pilot and the inspector to make photos of these parts of the bridge. So this is very important to give the right instructions to these inspectors. And these instructions are coming from the design engineers. So here we have details. We can see we have a clear view of the top of this structure, and we can take a look at some specific welding details who are at high risk for fatigue. This is an example of a connection, a bolted connection of the hangers with the arch. So we asked specific for control of these details. On the left, you can see that there is traces of rust. So this is very suspicious. And indeed, there were some bolts who are cracked and there was a problem. Okay, this can be seen from on the ground. There are traces of rust. But in the right picture, there are 3 bolts that are missing. So this is not very easy to see it from the ground. So we need to give the right instructions to the inspectors to get the right information to include in the report. Here, the report is just a document where we include the photos. Now let's take a look at a large structure. This is a viaduct of about 500 meters long between Ghent and Brussels. It was an old viaduct in concrete, reinforced concrete. And then 10 years ago, we enlarged the track with 2 extra tracks. And so we added a steel structure to the viaduct. So it's a quite complex, big structure. And there we asked a private company to make an inspection with drones. So we got a lot of information, a lot of photos, even videos, and the question is, how do we treat this information? How do we present the results in an easy way to consult? So we made a sort of model, total overview of the viaduct, and then we made spots with every photo. What is important is that we know where the photo was taken. So we got the coordinates of every photo. So when we come back within 4 years for the next inspection, we can compare these photographs and we can see if there is evolution or not. So we decided to make some categories. Here you can see 4 categories with different colors. So it makes it easy to see where there are some problems. We also used some artificial intelligence to give us a hand and to make some suggestions of some defects that could be detected. Here you can see some cracks in the concrete, and they were proposed by the artificial intelligence. So here you can have a general view of this structure, and you can see the zones where we have potential problems and where we will need to spend money for maintenance. We have different categories, and it's easy to filter these categories and see to get the right information in an easy way. For us, drones can also be used for underwater inspection. Here we have the inspection of a pier in a river, and we wanted to know the state of the foundation. So we used a drone equipped with sonar, and we also had a diver to make some checks whether the information was correct. So the images of the sonar are quite difficult to interpret. So you need a specialist to make the conclusions out of these photographs. We were lucky that the water was quite clear, so we also could make some photographs, and there we can compare the results of the sonar with the visual photographs. And some spots with holes holes in the structure were identified, and we could get a good correlation between the sonar images and photographs. So this is a very good way for inspection of underwater structures. We also use it in tunnels. There we have to equip the drone with a sort of protection around it, against to protect it from collision to the structure. And we also need some artificial lights. And then on the right, you see some photographs with a good result. And this enables us to give us an idea of the situation of difficult to reach places. You see some other examples. And there was some rust. Detected. Of course, can also be used for our colleagues of catenary and telecom to get an inspection for these installations at difficult to reach spots. We also use it to inspect rock falls, rock faces, to get an idea of the state. Of course, there it's sometimes difficult if you have trees and so on, but it's a good tool to get the dimensions of these rock faces. It also can be used for as-built plans as a layer with when you make photos of these sites, and you can add some information on cables and other equipment. And then you can also calculate volumes if you have photographs on two different moments with two different forms of the platform. You can make the comparison and determine the volumes of excavation before and after the work. I would like to end my part referring to a UIC project. This was done on the harmonization of inspection. A lot of countries participated, and a document was published at the end. And there was also a SORA analysis that was published according to the EASA directives. SORA is specific operation risk analysis. This document is can be downloaded on the website of UIC, and it can be very helpful for inspections with drones within your network. And there will be also a revision of one of the leaflets of UIC. This is leaflet 778-4 on the maintenance and defects on bridges. And this will be turned into an IRS, International Railway Standard, and the results of this project will be integrated in this new document. So I will hand over the floor to my colleague Sylvain with the aspects for switches and tracks.
Thank you very much, Didier. I'm also really happy to be here and to talk to you about Infrabel's journey with our measurement trains and newest measurement systems. I am Sylvain Berten. I'm a track engineer at Infrabel for more than 8 years now. A special track engineer because I treat a lot of track data. I will explain the role of my team in just a few minutes. My goal today is to explain to you what Infrabel has done the last years to automate the inspection and controls of tracks and switches. I want also to give you a realistic view of what we've done, what works well, the advantages, but also what does not work so well and the problems that we are facing at the moment and we are trying to solve. Yeah, of course, a few years ago, we already had a measurement train, but the scope of this one was to measure the track geometry on the plane track twice a year. When I say track geometry, these are parameters like track gauge, the cant, the alignment, and so on. So track geometry was already automated with a measurement car, But to detect the visual defects, we had to, and we still have to send local crews on the tracks to detect the visual defects. So they have a kind of a smartphone, and when they see a defect that is worth to be noted, they just have to register it, and it comes into our follow-up system. For the switches, it's also the same. The visual defects have to be inspected by a crew that goes on the switch itself, but there are also specific quotes that needs to be measured. These are specific quotes in the switches, and these are measured by a kind of a ruler that every local crew has and allows us to measure those parameters. But we wanted, of course, to automate these processes. And when I say automating, it means that we want less people going on the tracks for safety reasons, but also for efficiency, because as we will see, a measurement train can measure a lot more in one day than a crew. So that's why we started with the automation of the switch process. So in 2017, we launched what we call the switch measuring and video system. This is a measurement system that we installed on our existing measuring car, the EM130. And it consists of, first of all, a system of lasers. What does the laser do? It just scans the tracks every 2 centimeters. So what we get is kind of a 3D visualization of the tracks continuously every 2 centimeters. We also have an IMU that measures the track geometry that is more classical. But like I said, we also need to detect the visual defects. And if we want to completely remove the people on the tracks, then we have to also have a camera system. That is what is represented here. We also have a camera system that consists of 10 cameras under our measuring trains that captures images of the switches under different angles. So we have what we call the ballast cameras. When they are together, it's like we have a complete view of the track. We also have specific cameras like the top rail cameras, which allow us to see in black and white the top of the rail. It's specifically designed to see the cracks or the small defects on the rail itself. And we also have side cameras, which allow us to see the fixation systems and the fish plates. So with both these systems, then we have all the tech we should need to perform a control of the switch without going on the switch itself. But in order to do that, we had to design a process which is here overly simplified. And this is also something that I wanted to share with you today. Having the tech is one thing, but having a good process around it is even more important. I think so, at least. So how does it work? We have a bit less than 10,000 switches at Infrabel, and we decided to take the 3,000 most important switches in the scope to start with. And how does it work? So these 3,000 switches are divided into 50 measurement runs of 60 switches each. So it means that in one night, we measure approximately 60 switches with our measuring train. So that is the role of the team of my colleague to design specific routes to measure all the branches of all the selected switches. So the train might go this way, then go back this way, and so on and so on. The goal is to measure all the branches of every selected switch. What is the output of this first phase? Is that we get raw data. We only get cuts every 2 centimeters, and we get raw images, but we have no useful information at this point. And that is the role of my team, the track data cell, the team that we call the track data cell, is to transform those data, raw data, into useful information that are then transmitted to the local crews that have then to decide if they have to do maintenance and when to do it. So like I said, this is overly simplified, but it's the process is crucial. Quickly, an example of one specific quote that we measure. So what you see there is a cut of a specific quote. And then automatically our algorithm selects the points that need to be taken into account to measure the quote we need to compute. And this is exactly what somebody on the track would do with the ruler, exactly the same. There are, this is maybe my most important slide for the switch part. We faced many challenges when we developed this project. The first one is the biggest issue that we are facing at the moment is also linked to the process once again. If the train fails, then what happens? The switch still has to be controlled or inspected. And then, of course, our backup system is the local crews, which were supposed initially to control the switch. But if the train fails too many times, then it still has to be controlled. Then we have to ask the local crews, yeah, sorry, the train has failed. Please go and control the switches in place of the train. So this is really difficult. So this is crucial to have a reliable measurement system and a good process around it to have this situation as not too often. The second challenge that we faced, it's that in the past with the measurement ruler, this is a static measurement, but with a train, you put multiple tons on the tracks, and of course you have a dynamic measurement. So you might expect at first to have the same quotes measured by one system or the other, but it's not the case. Of course, with the dynamic efforts of the train, you will have differences between what is measured manually or with the train. And in some cases, this can be a problem. Here, I show you in millimeters the thresholds for one specific quote. The nominal value is 1395 millimeters, and the immediate action limit, so the value at which we have to do immediate maintenance, is 3 millimeters less. So just imagine what it is, 3 millimeters. And of course, you might measure something manually that is okay. And when you come with the train, then you get a few millimeters off. And then it means that you should have to do immediate maintenance. So it's been a huge challenge to deal with these differences. A third point also is that, like I said, we have images and we detect manually on the images what is a defect, for instance, a missing fixation or cracked sleepers or I don't know. And then we put that into a report, a nice report, and we give that to the local crews to analyze. But it's not the same as being on the track itself. It's not the same because with our cameras, you get a static angle. You cannot zoom in, you cannot move, the lighting is always the same. And it's not the same as being on the track itself and take a picture with a nice angle and so on. So the feedback that we get from the local crews is that sometimes it's quite difficult to know what to do with the pictures that we provide. The fourth challenge is maybe linked to the second one. We work with immediate action limit defects. And when we started the project, we detected a huge amount of immediate action limit defects. It does not mean that they were not present in the past. It means that we were not aware that there were so many because they remained local on the local crews. And it also can have a link with what I explained with the difference between static and dynamic measurements. Okay, so that was the part for the switches. I will hurry up. Then we did the same for the plane track, and that is quite new. We started this year. What we do at the moment is that local crews have to go on the plane tracks to detect the visual defects. And we also wanted to automate this part. So we installed the same camera system on another train just to capture images of the track and to detect the defects. Something I maybe didn't mention clearly, for the switches, we do not have any kind of automatic defect detection. Why? Because it's quite complicated. We have so many different kind of defects and so many different kind of switches that we did not invest at first into automatic detection. For the plane track, it's not the same. We cannot ask someone to just scroll through hundreds of kilometers of data. He'll go nuts after a few meters, I think. So we implemented automatic defect detection. But the question was, which defects do we want to detect? So this was not an easy exercise. We are aware that we are not able to see all the possible defects on the plane tracks, but we decided to choose which one we would detect automatically. So this was a compromise between the most dangerous defects and the defects that we the most often encounter on the tracks. What is the scope of the process? So we decided to go and to move on carefully. So we only take in our scope what we call the standard track. So standard track is concrete sleepers, patrol fixations, and long welded rails. And also, this is really important, we also alternate between a classical pedestrian inspection and an inspection with our measurement train. Why did we decide to do that? Well, because we cannot detect all the defects with our system at the moment. And also we wanted this was kind of a validation of what we did. If we measure one defect at this step, we expect to find it there too if this was not maintained. So this was a really nice exercise that we did and that we're still doing to make sure that the system works. Some results, I will go really fast on this, but this is kind of interesting. Let us focus on one bar here. It shows for one specific run how many kilometers we wanted to measure and how many kilometers we succeeded in measuring. And if I take this one, for instance, we wanted to measure a bit more than 100 kilometers, and we succeeded in measuring 87 kilometers. So it might seem good, but no, it means that we ask the local crews to manually go and inspect, I can read here, 15 or 20 kilometers of tracks manually, and they were not supposed to do it because the train was supposed to do it. So this is a big challenge. And for the last run that we've had, this was even more difficult. The second chart, I will also maybe take the example of the orange bar, the last orange bar. It shows how many defects we communicate to the local crews. And what does it mean? For 100 kilometers of track that we measured, we've sent 90 defects of fasteners, missing fasteners, for instance. But we had to manually validate more than 10,000 defects. And why is that? There are two effects. The first one is that our current automatic detection system gives us a lot of false positives. So 90 to 95% of the defects that we have are not real defects. So that is something we definitely want to improve in the coming months. The second effect is that if you have one missing fixation, okay, it's a true defect, but it's not worth mentioning or telling it to the local crews. So we have special rules to group the defects and categories of defects depending on how many fixations are missing, for instance. So like for the switches, we are facing many challenges. I will not go in all the details of what is written on the slide here. I already talked about the higher workload that we expected because of the number of false positives. This is something we will try to improve in the coming months. I also spoke of the hardware problem. If the system fails, this is a big issue for the whole process. Still, Infrabel believes in these systems, and in the coming years, we will try and we will extend the scope of what we are doing at the moment. For the plane track project, we started this year, so we started lightly. Next year, we will improve greatly the number of kilometers of tracks that we will measure, and we hope that in 2027, we will be able to do almost only train inspections on plane tracks. For the switches, we are currently measuring 3,000 switches a year, and we hope to move to more than 4,000 in 2026. So the conclusion of my presentation, like I said, those system, Infrabel believes in those systems. There are obviously a lot of advantages in those systems. The biggest one to me is that people do not need or need less to go to the tracks to measure the switches or the assets. But like I said, a failure in the measurement system has a huge impact on the local crews, and this is crucial for us to improve in the coming months. So, like I will say it for the 10th time, maybe having a good tech is great, but the process around it is really, really, really important. And the last point, I didn't mention it. It was also a good thing for us to learn for the change management within Infrabel. So we design all those projects to be as much as a black box as possible for the local crews, having the same reports, having the same integrations and so on. But that is still a change for the local crews, and they have to be very well accompanied and supported to make sure that they accept these new systems and that they work with those systems every day. That was it for me. Thank you very much for your attention.
Thank you both. We now have a few minutes of questions before they need to leave for catching their train. Is there any question in the room? Yes, there is one up here in the front.
My question is to Silva about this the system for monitoring switches and the plane track. I understand that for the switches, you did not automate the defects, completely understandable. But the question is, what level of processing was done by your team? Because I understand that the raw images were processed to a certain extent before being handed over to the local crews to make a decision. So just wanted to understand what kind of processing was done for the switches specifically.
Yeah, so, okay. For the measuring part, so the part with the lasers, almost everything is automated. It means that automatically the good points are selected to compute all the codes. What my team does is to check if the algorithm worked fine. For the visual part, it's something else. We just purely scroll through the videos, and we have all the cameras that are lined up in 3 different screens. And when we see an actual defect, then in our system, we have the capability to drag a rectangle around it, to note a description of the defect, its localization, and then automatically it is transformed into a report that is then sent to the local groups. So the visual part for the switches, it's purely manual by scrolling the images. I don't know if it answers the question.
We do have another question on here online for Didier, if you just bear with me. So Didier, do the drone inspections of the bridge's high components need the catenary to be off? Or is it possible to do it during train service?
Yes, indeed. We managed to do the inspections with train in service and catenary in service. So we do not cross the tracks. So we try to do it from the outside of the bridge with the track in service.
Just one more question there. Final question.
So I have just a question to Sylvain. When you collect the data, the image on the track, how you can transfer them to the data center, what you use.
It's a good question. It might look old-fashioned, but all the data is stored on SSDs, hard drives that we physically transfer from the train to our office. The defects, well, the raw data are stored on SSDs. We want to upload them on the cloud at some point. But what we already do is the defects that we note or the defects that we mark on the videos are then automatically stored into the data center using just network connection.
Using a Wi-Fi or?
It's not Wi-Fi. I'm not an IT guy. It's just.
Sorry for the
sorry,
question.
no. But in our office, we have a direct connection to the data center, and then the IT guys at Infrabel have come to make sure that when we want to launch a defect, it's done with a specific configuration, but I could not tell the details of it on the IT side. Sorry.
Okay, thank you.
Thank you very much, both. I think we will let you go now to ensure that you catch its brain, and we move to the presentation from Herbert from SBB that is going to be done via video, I believe.
We won't be having a Q&A after the video presentation, obviously due to the technical challenges we've had with the Q&As today. So if you do have any questions for Herbert after the video is played, please feel free just to send him the questions on the app directly. He is aware and will respond. Thank you.
Ladies and gentlemen, dear colleagues, I kindly welcome you to the presentation, to this session at the Rail Infrastructure Asset Management Summit, and I will introduce you in the SBB approach for risk-based asset management for railway bridges. Before starting with the topic, I want to show you a short overview about our portfolio of civil engineering structures at Swiss Federal Railways. It's dominated by these two main asset categories. There are the tunnels with a length about 470 kilometers and the bridges about 6,000 bridges, 6,000 numbers in the whole network. It's completed by other structures like the culverts, retaining walls, and noise barrier walls. As you can see, the high number of assets make it necessary. Ladies and gentlemen, dear colleagues, I kindly welcome you to the presentation of this session at the Rail Infrastructure Asset Management Summit, and I will introduce you in the SBB approach for risk-based asset management for railway bridges. Before starting with the topic, I want to show you a short overview about our portfolio of civil engineering structures at Swiss Federal Railways. It's dominated by these two main asset categories. There are the tunnels with a length about 470 kilometers and the bridges about 6,000 bridges, 6,000 numbers in the whole network. It's completed by other structures like the culverts, retaining walls, and noise barrier walls. As you can see, the high number of assets make it necessary to consider how we can prioritize our maintenance activities in the network. And in the next slides, I want to introduce a risk-based approach, what we have developed for the bridges, but as well as thinking about how we can expand it to other infrastructure parts. Here you can see a statistic about the bridge portfolio. The horizontal axis is the year of construction and the vertical is the number of bridges. As you can see, it's well known in the very beginning. It's dominated by masonry, followed by some steel bridges with this violet color. And in the last decades, it was dominated by reinforced concrete. As you can see, the portfolio is so quite very inhomogeneous and very different in the material, but as well in the type of structures, what is due to the geographical situation in Switzerland with mountains and also in areas with many rivers. At the next slide here, you see now the map of Switzerland, and each dot of what you can see here is represents bridge. What we plotted here is the condition categories. So we are, according to the USC standards, you see the green dots here, it's a bridge with a good condition, and going down to alarming condition with these red colors. So each of these dots represents one bridge, and I want to show you two examples. The first one, what we see here, is a concrete arch bridge. It's very close to the capital city of Bern. It's on a main line, and it's in condition category 3. It was built about 60 to 70 years ago, and is crossing over one of the main river. The second bridge I want to show you is here. It's a single beam steel bridge. It's on a side lane next to Zurich. It's a condition category 4. It's one about over 120 years old, and the side lane means that this bridge is one freight train per day is crossing the bridge, and there is no person trains are going over this bridge. So with these two examples, I want to introduce when you have to consider as asset manager, asset owner, you have to prioritize your resources or your costs or your inspection teams. You have to choose which of the one bridges you want to spend your resources. And it's different to make this make these decisions only on a condition rating. And in the next steps, this is the reason why we started with a risk-based approach, where we are using more parameters to make a decision for which bridge we should spend the resources for this example, for this theoretical case. The overview, the maintenance strategies, we have the reactive maintenance, preventive and predictive maintenance. In the last years, Swiss Federal Railways for civil engineering structures, we used this condition-based maintenance, and now we want to go into risk-based maintenance. Risk-based maintenance means for us, we are considering the probability of failure, it means the unavailability of line and the consequences of failure. How to do this? Here, the first overview about the method. When we are talking about risk, we have here the simple formula. We have multiplied failure probability multiplied by the consequence of loss. And to define these two parameters, we need different data and, of course, individual attributes for the bridges to define this failure probability or to calculate this failure probability. And in the next slides, I will introduce how we have developed this approach and how we are using this now. Actually, we need data. What we have available is, on the one hand side, the assets database, this information of bridges, the maintenance database. We have the operating database with numbers of travelers, and we have a different database of costs, what we can consider here. We have developed the algorithm to combine this using this data for individual bridges, and then we can making a risk analysis and the risk based decision when we are talking here for failure probability as a function of damage of loss extent. Same on the right hand side of the slide. It's in the end we want to have risk-based costs, and the risk-based costs are calculated as a function of loss expenses, failure rate is part of it, and as well the condition category. At the next slide, we have here the overview about the operating database. You see here the map of Switzerland and the average daily traffic in our network. You can see here the two well-known peaks, the morning peak at about 8 o'clock and the highest peak is about 20 minutes past 5, where we can see how many travelers are on the network. And here, once again, we have the main line between Bern, capital city, and Zurich, and side branches for the bridge, what I shown before, is here with a very low traffic. And so we can use this data. We know how many trains with how many passengers are on the network and can consider this as input variable for this risk-based examination. The second is the asset database. That's the map that I've shown before. Each dot represents a bridge. And now we will zoom in into one bridge and I show you an example of a steel bridge. What you have here in our database are different parameters for this steel bridge. What we are using here, we have information about the coordinates, about the responsibilities, we have the maintenance, and what we are using for this risk-based approach is the year of construction. It's the span of the bridge, the type of the bearings, the static systems, the continuous beam in this case, and we have as well some specialties of the bridges. It's core hazard because it's crossing over a bridge, and the bridge is 140 years old, so it's about broad iron, a very brittle material, what you can use in our risk calculation. With this database, we go to the next to evaluate or to define what is the probability of failure of a bridge. And here we used the approach that we are looking about international databases, and look about the cost of bridge collapses worldwide. What you can see here is an overview about the cause of bridge collapse and the relative frequency. Pictures taken from the book Bridge Collapse Frequencies versus Failure Probabilities from Dirk Drosten. And he was as well the author, the developer of this method, what I'm presenting here. But you can see the main causes of bridge collapse are score, flooding, and impact. And for example, seismic or degradation have a very low frequency, what is here in the database for cause of bridge collapse. With this information, we start our approach. Here, the overview for the method. We on the left branch here, failure probability, and we are calculating now the collapse probability of an individual bridge. And how we do this is that we are taking an approach for the death tooth curve that we see at the very beginning. Is the age of bridging years. That's the failure of probability. That's in the beginning, the early beginning when using. The probability is higher of failure, and it goes down to very stable area, and then the end of the lifetime, then the probability will increase. That's the theoretical example, and our the university where we cooperated developed this function, what means more or less the same. The further factors what we are using from this asset management database is that we are taking account about the condition of the bridge. We are looking about the type of the bridge with building material, what is beyond the bridge. Is beyond the bridge a river, or it's a road or a street, for considering impact loads. And here you can see an overview about the sensitivity of these different factors what we are using. With these different factors, we can modify the general probability of failure to the individual boundary conditions of each bridges by using these correction factors what I mentioned. On the right-hand side, we have here the consequences of losses. So we need now the loss expenses for an individual bridge failure. We have the replacement failure of the bridge, price of freight train or passenger train. And the most important here is the value of for the avoidance of a fatality. And for this value, we have to use official numbers from the authority. So by using now these parameters, we combine this, and as I mentioned at the beginning, now we have a risk map of the SBB bridges. Now, in difference to the condition classes, we have here risk classes, and the dark red dots are bridges with higher risks, and the green dots are here bridges with lower risks, what we have calculated with the introduced approach, what I explained before. And with this risk map, we can now differentiate on a network level and considering and know where our top bridges in the network. So coming back to this slide at the beginning, these two bridges from our network on the main line and on the side line. And the results from the risk approach is that the arch bridge on the main line here with 1,000 trains per day and rank about 800 of 7,000 bridges, and the steel bridge here is about ranking about 100 of 7,000 bridges. So from a risk perspective, you see it's 8 times higher than the arch bridge. It's maybe easy to understand from the structural perspective. You have a very robust arch type to a very vulnerable steel bridge. So only from the risk-based approach, it will be recommended to spend your money or your resources to maintenance this bridge. So we are on the last slides, 2 slides for the implementation. Now we have as Swiss Federal Railways, we have used this, and now about our top risk bridges, we are doing safety verifications according to the standards, and we are using this tool for prioritized planned maintenance measures. The next steps would be that we are looking about the monitoring of engineering structures, that we can divide between high risk and low risk monitoring. Maybe for low risk, it should be suitable to do it with drones. Maybe my colleagues from Infrabel will introduce in this topic more detail in the next presentation. What I mentioned before is risk-based asset management will enable a network level differentiation and identification of top risks. You need, of course, it's a correct asset information. And also important to say is that risk assessment does never replace an analysis according to the standard. And the last insight is 2 bridges that had to be closed in our network in the last 2 years were in the top 20 of the risk list. So we see also on an engineering judgment that this very theoretical approach work and can be used for these 2 goals, what I mentioned in the first. Slides, I'm on the end of my presentation, and thank you very much for your attention, and looking forward to discuss with you later in the Q&A session.
Victor said there will be no. That we're facing, so we'll quickly move on to the next session, and we're going to have Brian Haddock and John Beckford presenting. Brian is from Network Rail. He's the head of seasonal and weather resilience, and John Beckford is a visiting professor in the Department of Civil Engineering at UCL.
Good afternoon. Yeah, so I'm Brian Haddock. I'm the head of weather resilience at Network Rail in systems operator. And I think I'm going to give a presentation. I'll kick it off with an introduction to the problem. And then John will give a presentation about the solution. And John and I have worked together for many, many years now. A lot of stuff with climate change and all sorts of other things. Through today, there's been a lot of discussions, lots of presentations and things around models. I feel like I'm a digital twin midwife. I was just working out how many times digital twins has been mentioned, and asset data, asset information, all that stuff, data lakes, data silos. And I think from the operational side of things, we've got tons and tons of information coming in, tons and tons of data. It's actually completely useless unless we have a process or something to use it for, or we have competencies and controls to make that information useful to the passenger. And there's been bits touched on it all day today. Sylvian's presentation just there was spot on. You know, processes around these things are absolutely critical. We have things in Network Rail called the National Operational Principles. So we have standards, but unless the principles are acted upon, it doesn't work. So I think one of the frustrations I've had over the years in ops is seeing all these developments, innovation, all sorts of things, but trying to work out the quantification of the benefit to the passenger and freight user. So what we don't have in Network Rail and what we don't have in the UK is very good information around the impact of adverse and extreme weather. So we've got lots of information from assets, we've got lots of sensors on switches and crossings, we've got things on overhead line equipment, and as you've seen, there's tons of stuff off trains as well in regards to data. And I think there's an element where we understand linear relationships between specific individual weather events and specific individual assets, which are very, very kind of linear. One of the examples I'd give is critical rail temperature. If we've got, you know, if you're in the middle of summer and you know you've got a long duration of sunlight on directly onto the rail head, and it's continuously welded rail or not, then we understand that relationship quite easily, as a lot of rail technicians do. But as soon as you start adding in any other weather parameter or any other complexity, it becomes a very, very complex system. We don't really understand the impact of non-linear systems, and we certainly don't understand the impact on our line-side neighbours. I've seen lots of LiDAR stuff today and lots of things about how we try and understand the changes that go on at trackside. But, you know, if a farmer decides that he's going to plough his field in the wrong direction, we can have all the best rail asset data in the world, but we'll end up with a washout or a flood on the track. So we're trying to build some of these things into a model that we're completing at the moment. At the moment, we are very much dependent on delay attribution in the UK. And the delay attribution is based on a number of codes, which are highly dependent on the controls receiving the information about an incident. And most of that isn't based on direct asset information. It's normally the driver reporting that they've seen something. And that information is collected, and for weather, almost entirely all of it is under what we call an X code. So it's actually external to the rail itself, so the railway system itself. So it's really difficult to quantify the impact of any weather parameter on our network. So I wrote a paper to what's called our Network Performance Board, which is kind of our senior leaders and the grown-ups in the rail industry in the UK. And we came up with a kind of statement saying that we need to understand the impact, and we need a better system of being able to unify all these systems and understand it. And of course, we had a fatal train crash in Stonehaven in August 2020. We killed 3 people in a HST that derailed. There was a convective rainfall event the night before, but actually, if you look at the external code, it wasn't down necessarily to weather, because it was actually to do with the design of a system for drainage that was line side, that we didn't have much information about. But of course, in regards to weather impacts, that will go down as external delay, as with the Dawlish seawall, etc. So what Stonehaven taught us was that our forecasting systems, our weather data, the way we manage weather data is very reactive. At best, it's 2 to 5 days. And that's okay if you've got a big low pressure system coming in. And we know the weather prevalence in the UK. We normally get southwesterlies that come through, and we get a big storm, and it's normally well forecasted, and we understand the impacts of that to a certain extent. But the only mitigation we've got is to either slow the train down or stop it. So, and that's a really clunky way of applying all this technology, and we still do that even today. So what we learned from Stonehaven was that we needed to look at something a little bit more spatially and temporally granular. And that led to, rather than a big geographical forecast area that we currently forecast in, we looked at line side forecasts. So specific line side forecasts set to our thresholds for all other weather parameters, including rain, snow, wind, and heat. And we had to divide the railway up into geographical sections that we've not done before, which are called operational route sections, so that the driver can receive a call through the GSMR radio to the cab to tell that driver that they're approaching an area, not in it, but approaching it at line speed, that has just triggered a threshold for convective rain. Now, what we took that map, and this map was created by our weather forecast providers. We took the map and we took the forecasting areas within operational route sections. And we took all of our thresholds and looked at it. And we realized is that actually, if we aggregate the operational route section, and to give you an idea of that, it's really quite simple. It's either from station to station or station to a junction. It needs to be something that the driver can observe and obviously understand. So you can't have anything at night. That's why we use stations, because of the lights, etc. And then we aggregate those operational route sections to understand the individual impact on individual passenger journeys. So currently, as I said, we use all sorts of things to measure. I'm sure you're well aware of the PPM measurement, when you get sort of local services within 5 minutes arriving at their destination is still in time, 10 minutes for long distance. And we measure cancellations, part cancellations, and full cancellations. That seems to be what we measure our performance and success on. So this is a very different way of looking at it. So we've utilized the terrible, tragic accident at Carmont to make sure that we do something very, very different and understand not necessarily the information that comes in from assets, but looking at the system's impact on an individual passenger or freight service. Now, I'm going to say one more thing, John. The reason why we do that is because our Department for Transport have asked us many, many times, what is the level of service that a passenger will accept in adverse and extreme weather? And we can't answer that. We try and run everything we can, and we leave it to controls all the time to make it up. The last minute, even though we've got 2 to 5 day processes, they make it up at last minute because they're protecting their revenue and they want to run as much as possible. But to quantify the actual impact actually justifies trying to write and validate a proper amended timetable for weather. Now, we've done a lot of work with ProRail, and we know that the Dutch system is very, very good at this. And it's something that, as long as the system that John's going to show you now is getting us to a point where we can actually quantify the impact, and we'll take that back to the Department for Transport, and we'll ask every operator to have an amended off-the-shelf plan that is ready on a 2 to 5 day forecast, or a day A for day C timetable. It's not difficult because we do this for engineering works almost every weekend. But John, I'll hand over to you.
Right, I brought my water with me because I tend to get hot. We may need some rainfall on the way through. Somebody earlier in the day mentioned systems thinking, mission systems engineering. I'm a cybernetician, which is a little bit weird, and I'm going to talk cybernetics for the next however many minutes it takes to get through this thing. The cybernetics is the study of adaptive systems, the study of learning systems. And I've heard a lot today about assets, a lot about the new systems that we're going to create and all that sort of stuff. I haven't heard a lot about adaptation and learning, so we're going to do a little bit of that now. So the seasonally agnostic railway model, the core idea is it shouldn't matter to our passengers whether it's hot, cold, wet, or windy, we should be able to run a train service. We can only do that if we understand the impact of the weather event on the train service and can adapt accordingly to what's going on. So the live development of an adaptive timetable would be a dream for me. How good's your quantum physics? Anybody know anything about Schrodinger's cat? Yes, superposition. You put the cat in the box with the nuclear device and you don't know whether the cat's alive or dead. Yeah? Similarly, Heisenberg's uncertainty principle. We can know which way something's facing, we can know how fast it's turning, but we can't know both. And the problem with a 20,000 mile long, 30 meter
asset base, which is what we've got in this country, is we cannot know to a certainty what condition it's in at any particular time. We can only know what condition it was in the last time we drove a train over it. Okay, so we can't know whether it's working or not until we actually turn up with the train, which is quite scary. And when we then try to accept that we do that with inadequate asset data, and it's inadequate because it's 200 years old in many cases, we don't know what's underneath an embankment, et cetera, all the things that you know that are wrong with the asset information, we've actually got to be able to make, go back to our previous friend, risk-based decisions that help us to understand what's going on in the railway. And what we're trying to do with this model is simplify all that to something that we can actually work with as normal human beings. Seasonal challenge that Brian presented me with is, can we assert the impact of weather on the railway? We ought to be able to, but can we? Can we understand what assets are at risk and what action we might take to ameliorate that risk? Can we predict and prevent and preempt failure? And I don't mean in the next 5 minutes. We could look forward 6 months maybe, or going back to the chap from the ORR this morning, maybe we should be looking forward 15 years into our assets. So we decided to build a seasonally agnostic railway model. I can't remember how the name came up. Key thing, can we tell the passengers how late for tea they're going to be? So if we can do that, the passengers will actually be happier. Can I tell you how late your parcel from Amazon is going to be when it turns up? We want to anticipate, prepare and prevent, and develop risk-reducing, performance-enhancing changes. So if you improve performance, it pays for itself. I heard a lot today about cost and cost management. I heard very little about value. The trade-off between investing in good assets, which generates additional revenue, versus the cost of generating that additional revenue is quite an interesting space to go to. B flat, I think, isn't it? Okay, so conceptually, I sat at my desk at home in West Berkshire with this problem that Brian had thrown at me. And said, oh, don't know, I'll scratch my head a bit and think about that. And I came up with this, was first conceptual model. This consists of 3 informational homeostats. Homeostat's a thing that keeps things the same, like a thermostat in a room. The first one, has this got a pointer on it? It has, marvelous. The first one says, what are the weather people telling us is likely to happen? And frankly, how right are they about their weather predictions? If they're plus or minus a degree, plus or minus 10 mil of rain, we can understand the accuracy of the weather, because the accuracy becomes important. We then feed that weather into understanding what the specification of the railway ought to be to deal with the weather we can expect. So if the weather people are saying it's going to be minus 15 in the middle of winter, and we've designed a set of assets that are only robust down to minus 5, we can be pretty sure the railway isn't going to run at some point. Okay? So have we got a seasonal specification that matches the seasonal weather? Critically, have we then built a seasonal preparation plan and maintenance plan that maintains the railway in accordance with the specification we set, which matches the weather that we've created for it? Okay, so we've got 3 things going on in our heads simultaneously. Okay, a triple homeostat. And of course, when it all works, it's greened and we get the timetable that we planned. If it's not green for some reason, it goes a bit amber and we slow the trains down, or we might cancel some services. But we can do it knowing in advance that we're going to. So we can say to Mr. and Mrs. Passenger, terribly sorry, you're going to be late for tea, have a pizza. And when it all goes terribly, horribly wrong, we can say, we're not going to run that train because you'll get halfway to Clegg-Eaton and it'll stop. And you don't want to be stuck halfway to Clegg-Eaton, believe me, I've been there, and it's not great. When you created that model, and we did, and start to think about it at the operational route section level that Brian just talked about. And we've actually built the original prototype around the one that runs at the bottom of my garden, which is about 3 miles long. It's nice and simple. The problem that most organizations have, whether it's Rolls-Royce or Network Rail or any of the other people we've talked about today, is they tend to buy big systems. Big systems are never right, they're never complete, they cost a fortune, they never deliver value for money. If you build little systems where you can comprehend the problem properly, understand it properly, and build a system that solves the little problem locally, and then make it talk to lots of other little systems also doing their own thing, you can build a big complex system which displays big and complex behaviors, but each individual bit of it is quite small. Just like the thermostat in this room that's kept it nice and cool today. It's got one job and it does it well. connect all the thermostats together, and you can maintain the temperature in the hotel pretty much any way you want to. Put one big central controller on the roof, you're stuffed. It's never going to happen. You're never going to get the temperature right in any room, let alone every room. So we conceived building the model around the ORSs and then adding them up. So we've got a line of ORSs from Paddington to Penzance. If there's a delay of a second on the first one and a second on the second one, etc., we can add up all the delays in all the operational route sections, and we can get a cumulative delay across a line of routes. Of course, we can then add up into the entire railway. So all the work that's going on is being done at an ORS. The great part about that is when Brian turns up with his weather forecast and says, look, I've got one. And it says the whole country has benign weather, except the 3 miles at the back end of Beckford's Garden, which is going to have an extreme rain event. We can choose to slow the trains down at the bottom of my garden and let them run at line speed everywhere else, because we have that degree of choice in what we're doing. Even better, if Brian gets me the weather forecast in advance, we can go and rob the drains at the bottom of my garden so it doesn't flood, so we can run the trains at line speed anyway. So we're trying to design something which is individually agile and local, which responds locally to a particular locally forecast problem, and then aggregate the effects nationally through a simple system. So hence this diagram, which basically says, look, we're getting the data here, and we're forecasting, predicting individually at that level. You can do it very accurately, you can do it very fast, you can do it on a laptop, which is what we're doing. To give you an idea, I built the first version in a spreadsheet on a laptop for a whole operational, in fact, I did 3 operational route sections, and it runs in instance of a second. Then you can add the line of route, but then you can look at a region, so we can report regional performance, and we can look at the whole railway, aggregating the information. We can also give control rooms information, and we can distribute it to passengers via those means. So we can play with the outputs of the model at a very immediate level. Gets a bit more complicated now, but not very. This is the same as the first diagram, just represented differently, just for those of you who'd worked that out, obviously. So up here are your 3 predictive homeostats. What's going on with the weather? What's the specification? What's the plan? Down here, we have a series, these are little homeostats that compare what's happening with what we said was going to happen and guide us to improve our asset maintenance plan, to take corrective action in advance. And they add up, again, operational route section, line of route, a region, and the whole railway. And critically, today, what's going to happen this afternoon? And can we do anything about it other than tell the passengers? But now, what date is it? 5th of September, 6th of September? If we can look forward 6 months and say, as the weather starts to warm up again in February, March next year, how might we anticipate what we need to do in terms of our seasonal planning and prepare for that, given that we know asset X, a signal set, a power distribution system, a set of points, is likely to fail when X happens, whatever X happens to be. So we've got now, thanks to Chris Stanley and his team, I must just say at this point, a whole bunch of sets of data about assets on the Wales and West line, the Western route, which has helped us to create the first version of this model. It is incomplete, and it will always be incomplete. So when you then start to think about modeling, I've heard a lot about perfect data and getting the data right and getting the history. Utter rubbish. It can't be done, ladies and gentlemen. So actually, you've got to find a way of making decisions with inadequate data and making them right enough to rely on. They don't have to be super accurate. They have to be right enough to deal with a set of parameters that they're presented with. They're quite broad. So it looks a bit like this, but it doesn't, but it would do if I had it here in front of you. So up here is a table of assets per ORS. What are they? Where are they? What's their position and distance? What do they do? And what are their failure parameters? What's the specification under which these things fail? And importantly, what's the consequence for trains when they do? So we have to reduce the speed from line speed by 50% or whatever. So all the warning levels, I think some of them got 5 warning levels for reasons I can't yet understand because I've only got 3 different triggers. But nonetheless, table of assets, a weather forecast, a set of timetables, because timetables are quite important on railways, apparently, it turns out. A table of extreme weather. We're not interested in all the weather that doesn't affect train running. We're only interested in the weather that falls outside a particular set of control parameters. So we can ignore all the stuff in the middle. Very, very efficient in terms of data processing. Here, we can work out the running speed, because you look at, go and talk to asset people, 100 miles an hour on that stretch of the track. If you look at the timetable, they're running at 68, not 100. So when you do the calculation of how delayed are they going to be, you base it on 68, not 100, because the line speed is actually 68. Take that, take the impairments, when these things happen, that thing happens, and you end up, in effect, with a timetable with impacts in it. It says, this service, 1K08, is going to be affected by rain, is going to be 3.75 minutes late on those 3 operational route sections. And that's all we want to know. And frankly, plus or minus a minute or 2, who's going to care? Here, we've got accumulated rainfall that's going to stop 1C77 completely. 999, stop the train. And that's what we're doing. Very, very simple. But of course, we're replicating it. There are, I'll get the numbers right in a minute. We'll go to this bit first. So what are the weather, simple questions. What are the weather parameters at a particular time? Do those parameters exceed a performance threshold for the assets that we've got? If they do, is there a train service? If it rains heavily at 3 o'clock in the morning and nobody's driving a train, who cares? As long as it's not going to flood the track. So is there a train service affected? If so, how many minutes delay is it going to experience? Now, doing that in real time, great fun. Doing it 6 months out and being able to say to asset managers, look, guys, if you did a bit of taking dead badgers out of the drains in September, removing dead trees before it starts to rain in October, you wouldn't experience all these delays. Well, guess what? You can put a value on that. You know what it'll cost you to drag the dead badgers out, but you also know what the value of a running train service is. Offset one against the other. The thing pays for itself. Okay, very simple. So where are we at? We're working through asset data. Thanks, Chris. Timetable data, weather data. Chris, I'm so being nice to Chris because I'm going back for more data next week, you see. Lots of it. We've built 2 initial prototypes, one on a spreadsheet, one we've moved into a database. And we can identify the impact per service, i.e. by service, at the ORS level, by service, by weather type, by affected asset. So I can tell you what train's affected, what weather's caused it to be affected, and which asset it is that's getting in the way. Which, of course, as an asset manager, quite useful, isn't it? Fix that one, it's broken. And of course, we can aggregate it, we can add it up. Where we're going next is, of course, we're making predictions. People have talked a lot about AI today. So we have some proprietary AI that we're starting to use. Because if I'm saying it's 3 minutes late, we're going to be 3 minutes late, I want to know whether that's right or wrong, don't I? So we're building a bit of AI that will learn about the rightness and wrongness of the model, feed that back in and modify the predictive capability. So we will teach the machine to teach itself to be more accurate over time. Okay, I can't make it more accurate, but I can teach it to make itself more accurate, which is really important. So we'll be comparing what we said should happen with what actually happened using, for example, trust data, comparing the two, and then using the difference to modify the prediction next time round. So we'll need lots and lots of data running through this eventually. And this year we're extending to a whole line of route. So effect on weather at varying temporal and spatial levels, effect of seasonal planning and maintenance, preempt service failure, evaluate the money. Was it 20 billion pounds they said this morning the government's giving 19 or something? If you can go back to the Treasury and say, guys, we can probably save £1 billion a year if we do X, they're going to listen. They won't listen to anything smaller than £1 billion, by the way. They're going to talk to the Treasury about £500 million. I'm not interested. For passengers, we can assess the service impact. And for me, as an occasional, I stress occasional user of trains, I caught one last year, assessing the service impact is the bit that's really going to matter to people. Now, all of that we have done. All of it kind of works, and we're just going into a testing regime and evaluation regime. Because, you know, first of all, is it working? Second of all, is it accurate? And then we're extending it out. We are currently recruiting, to give you an idea of the scale of this, 3 PhD students funded by Network Rail to work at Loughborough University, looking at making reliable decisions using unreliable data. Because it's a whole big area of understanding that we need to have. Developing and applying the ML and AI to a large-scale predictive model. I'll put the numbers in here because they're important. There are 3 homeostats, about 34,000 data points per model, and about 36,000 models, each of which will want to talk to all the other models that are broadly adjacent to it. And doing AI on that scale is sort of a bit mind-blowing, even for weirdos like me. The third one will be working with the industry, working with the organization to gain acceptance of the idea that you can use information in this way. Because much of what I've heard today has been really good ideas, really thoughtful, really useful things, but underlying it all is, and how do we get the industry to accept it? How do we get the blokes and girls with spanners and shovels to actually accept the information that we're providing with and act in accordance with it? And that will be a long-term problem. So we have to be able to be confident in the rightness of what we're suggesting, again, right enough, in order to persuade these people, engage them. So we're looking at how do we do all of that stuff. And that's about me, because that should be an end slide. So thank you very much.
Thank you, Brian. Thank you, John. Any questions from the floor?
I'd be offended if there wasn't one.
Sorry. Thank you. Impressive. I understand your model contains a lot of data and analysis. Does your model already include also, let's say, mitigation scenarios based on timetabling or simulations?
We're working on that. So it's in there in the thinking. What we're playing with at the moment is something we did in the pharmaceutical industry a few years ago. Was you take model one, take the existing model, you build a parallel one alongside it as a simulator, simulate the effect in the right-hand side and feed it back. Dynamic timetabling, I say particularly in this country, we have complex crossovers on the railway in this country and complex interactions in the timetable, as you know. And when you start to play with them, it gets messy. So we're sort of exploring to what extent can we do that and produce useful outcomes. And it's the utility of the thing at that level that the whole driver for the sort of relationship with Network Rail is my team have to keep producing useful results. Otherwise they'll cut off the money supply. It's perfectly reasonable, but that's, what's useful, what takes us to the next stage. I think I would like to get to the point. Intellectually, I know we can build dynamic timetables. Actually getting a machine to do it for you, slightly different problem, because the machines aren't quite as clever as the human beings. And again, that's something that we haven't really touched on today. Our ability, ladies and gentlemen, to interpret and nuance what we hear and see in terms of the data and the facts, do something useful with it, vastly exceeds any of the machines that we won't want to talk about. So we need to keep that in our heads, that this is ultimately a human system, which is informed by a technical system.
Also, as I started, when I did my introduction, we're really clunky approaching it with extreme weather at the moment. We do vast geographical line speed reduction. So sometimes that's a whole route. So if we can just have a day A for day C, so it'd be a little bit like running a Saturday timetable. As long as we can justify why we'd be doing that would be a middle stage getting to a dynamic timetable. And I know that's stuff that ProRail already does.
You have another question from people there in front.
Yeah, thank you very much. Question about top-down and bottom-up. So there is a digital twin case study for the IBM headquarters in Dublin. They have the local thermostats and local things, but when they start to use a digital twin, they drop the energy cost by 30%. So how do you see this being conciliated with digital twins, etc.? And how scalable is it?
We'll find out over the next 12 months, won't we? Ross Ashby, who was a sort of a forerunner in the cybernetics world in the 1950s, and building early forms of robot, determined, and I haven't got the arithmetic in my head anymore, that centralizing decision making because of the latency, moving data to and fro, kind of doesn't work. So you have to be able to make decisions locally, and what you export to a center is a result rather than anything else. If you do that, the thing only works at the level where you stimulate it. So if I've got 36,000 ORSs and only one of them is stimulated, only one of them will do any work. So consequently, your energy cost and your production cost remains under control. The problem is all of our computers have centralized control. They have a thing called a CPU, and all of the software is designed to work that way. So we're going to have to kind of reinvent computing as well at some point in this process, I'm sure.
Yeah, no, I completely disagree, by the way. I think, you know, edge computing, shore computing, cloud computing combined together can do that.
So latency is your issue. Your issue is latency. If you are, I have a nephew whose job is designing integrated chips for mobile phones. And when he looked at the energy consumption of a mobile phone chip, about 75% of it is the chip talking to itself, because it parcels out a job to you and then spends all its time saying, have you done it yet? 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 And actually most of its energy and most of its heat is generated managing itself. So if you can think about a way of distributing so that it doesn't do that, but a job gets stimulated locally and only passes across to the center those bits that are residues, your energy consumption drops quite dramatically. Your pace of response, your agility of response is much greater. There's probably, and I haven't determined out where it is quite yet, there's probably a level at which you need to bring it together. So it might be a line of route. So it might be Paddington to Reading, Reading to Swindon, Swindon to Penzance or something. Chunk it up and sort of start to build a model at a sort of a modular level beyond the local. But we haven't had to encounter that problem yet. When we do, we'll solve it. That's and the whole thing for me is we're exploring. So the whole project is characterized in the contractual terms as a research project, and that's a great place to be. It really is.
Thank you. Any final questions before we move to the final session?
Hi, I've got a little bit of experience, well, quite a bit of experience in Network Rail previously. I'm aware that the drainage information that they have is not tip top. It's often quite a mysterious asset even to people in Network Rail. I just wonder how that plays into your knowledge of location by location, whether the rainfall based on the condition of the drainage will, higher rainfall will be fine in some places, but worse in other places in terms of impact.
We'll have to literally rely on the quality of the data that comes through. If we, so as an example, if we have a prediction of a flood and we don't get one, well, we kind of want to go back and say, well, why didn't we get a flood when we thought we should have done? Just as much as when we get a flood when we didn't expect it, a flood when we don't get is useful information because it's telling us something. And then back to the cultural thing, that the whole notion of adaptation is not to determine whether or not we're right, but to determine what questions we now ought to be asking, given what we've actually seen. So educating people to use the information outputs and say, well, the model predicted it would do this, it didn't do it. So what actually did happen? And it's, should we modify the model? Should we modify the parameters? What are the questions we should ask? And that's sort of quite a big ask because organizations typically are very busy doing the day job. And actually getting them to recognize that improvement is the day job is quite challenging. But it's a really good question. Thank you.
Thank you. Thank you, John.
Thank you very much.
Thank you, Brian. I think we'll move to the last session of the day. We have two final speakers, Lawrence Chapman from HS2 and Mark Norris from the IAM. I'll probably ask Peter if you want to join the table as well for closing after the session. Okay.
Yeah, hi everyone. I really appreciate being invited to
come along today and speak to you around this particular topic. We obviously want to talk about sort of best practice about how we reintroduce new assets in information into the existing maintenance systems and keeping asset records up to date. Agree one, okay. Oh. Yeah, so basically the key challenges we have is how quickly can asset owners regenerate new asset information from renewables projects into the existing asset management systems to actually improve the operational process, and how can we work with our supply chain more effectively to make sure that we can use things like common standards and things like that from our supply chain and to get the information back into us. We need to look at best practice of record keeping and keeping up to date responses to renewals and enhancements. And also, again, we need to keep an eye on research and development around not just within the UK, but globally, what's going on and what initiatives are going on and how can we introduce some of that best practice. You may have seen this diagram several times before, but it's just to set in context. We have sort of the hierarchy of ISO standards that we need to fit in with. So obviously we have our quality management systems. We have around ISO 9001. Around that, we're then looking at our asset management around ISO 55000 and ISO 21500 for project management. And the bit I need to talk to you about here is about the ISO 19650s around information management within the context of asset management. And we split that down into two different phases. We have the delivery phase and we have the operational phase. So it's the main subject of this is that interface between those two different pieces, between delivering a project and making sure we've got the operation and maintenance information that's going on between the two. So ISO 9650 comes in 5 different documents at the moment. So the first part is around concepts. The second part is around project delivery. The third part's around operation and maintenance. Part 4 is about information exchange, how we exchange information to and from. And the 5th part is around security. Again, how do we make sure we're not sharing things like video cameras and things like that that we shouldn't be sharing with different aspects of people. Breaking that down, we have what we call defining our information requirements according to 19650. We start at the very top level, which is about our organisational requirements. This could simply be, well, how many trains an hour do we need to run? What should the journey times be? Again, which we heard about, what sort of weather conditions do we need to be able to respond to? And then that separates into 2 separate items. What information do we require to run the project? And what information do we require for the asset to hand over back to the asset and maintenance? And we structured that in a document under 19650 called the Exchange Information Requirements. And this is the particular document that goes into the contract to say this is the information we would like you, the contractor, to be able to manage your project, to understand that, from a client's perspective, how that project is actually going, and also what asset information are you going to hand over at the end of the project. And that's, I say, that now is in a government mandate that we have to all comply with and make sure that it's done in this particular way. So just coming on to the systems at the moment, to be able to actually manage that in a collective, cohesive way, there are 5, depending on where you go, but basically 5 more main common systems you would need to build together into your digital ecosystem. The first is your asset register. The next is some sort of GIS system to say, effectively where assets are located. The next is your common data environment. And the common data environment is not just your document register. That's also where you should be exchanging information between all different parties. It's where you do your reviews, your commenting and acceptance of information. And also that means where we can have information at different suitabilities. So you may have information that's approved at scheme design that's not fit for purpose for tender purposes or not fit for purpose for detailed design. So the status of that document within that common data environment is really, really important. The next is around your data warehouse and your analysis tools. We need some sort of repository where we can collect all sorts of information in for a variety of different systems. You know, talk about Network Rail. How can we get information in from things like Ellipse or CARS or GeoRhythm and actually be able to use that in some sort of meaningful way? And the other component is about reporting and analytics. And again, we've heard about some of the computing we need to have and how we can actually make sensible information out of that reliable and unreliable data. Right, so for me, the most important element of all of those components is the asset register. And the asset register is not just a simple list of records. Certainly it should describe what it is, but it also needs to describe where it is, what systems is it connected to, and when's it going to happen? Because an asset register, you know, say it doesn't just describe what existence in today. It should also describe what it was like yesterday, and should also describe what the asset is what assets are going to be in place tomorrow. It may also deal with scenarios based on your work sequencing and your work planning. You may not have actually tied down what your future railway is going to look like at different points in time. You can build that into your asset register. And the final element there is around cost, because you need to actually understand if you can build in things like your control accounts into your asset register, you can automatically generate so much more information like your cash flow forecasting, your budgeting, your forecasting, your bottom up forecasting, all by having that built into your asset register. So for me, that's one aspect that needs, again, everyone has an asset register, but does it really do what you need it to do? And can you actually, expand the processes? You may have heard many times about the golden thread. The golden key to me is your asset ID. Your unique asset ID is the vital piece of information that goes for a whole variety of different systems, and it lives and breathes within your asset register. Your asset register also tells you exactly what you are going to have to build and what you're going to have to commission. That's your single source of truth that you need to get right for your project. Next thing is about the location. And what I'm talking about is locational breakdown structure. We can locate an asset using Easterns and Northerns, but we need to actually identify where that is in a hierarchy. And there's two different sections there. So that the part on the right-hand side is around a geographic asset. So a thing like a station or a depot, you would describe in a particular way. And obviously with the railways, it's a linear infrastructure. We need to break that down into a linear hierarchy. So again, we hope we have our routes and our operational route sections right the way down to individual trainages. We need to associate individual assets to either or both of those locational hierarchies. That ties everything all together. The latest release of the ISO 19650 gives the standard of how we should be describing linear hierarchies within the UK. So that's pipes, rails, road, something that gives it a consistent standard of how we should be describing it. Next asset is around asset classification. We need to also clearly define and group different assets together into common sections. So we need to group, say, all bridges together, all tunnels together. We may need to group all interlockings together in a common type. So we now have a mandated classification standard that we should be using across all across the built environment, and that's UniClass 2015. And this has been developed over a number of years. A number of years ago, it wasn't fit for purpose, but there's been huge investment by the rail community from New South Wales Railway. Certainly in the UK, there's been a lot of contribution by Transport and London Underground. So we really have a robust classification system. And I often hear a number of people saying we can't use UniClass because it doesn't have this element. Now, within Uniclass and the UK BIM for Rail group, we can introduce any new element into Uniclass within about 3 months. So if there's something not there, then we can get it in there, and let's make it even more a usable classification system that we need. So top thing, we've got every single asset should be classified for a different type. And once we classified it as a particular asset type, then we can start building in the asset attributes we need to capture against each and every single asset type, and we can have specializations of different assets. So again, really important how we build that together. The next critical part of the asset register is its ontology, and the ontology is about how we decompose the railway into its different sections. And right away from I wish I could note my slides, I can't spell railway there, but it's making sure that we can break down right away from the very high level railway, station, bridge, right the way down to the smaller components, your interlockings, your railways, your sleepers, your clips, is completely broken down into the ontology. And again, you need to make sure that asset hierarchy is broken down, and you need to understand what asset is connected to whatever asset to be able to actually put together that complete asset system. And I'll come on to talk around what the global industry is doing to try and address this later on. During any projects, there's always some sort of conflict or balance we have to do between the asset management community and the engineering community that needs to get on and deliver the project. The assets are constantly changing from a variety of different sources. So again, as we're doing renewals, as we're doing operation and maintenance, we're replacing components, we're updating it, and the engineering community wants a fixed baseline to which they are able to deliver their projects. So we need to see how we can balance those two operations together. So one of the things I would like to bring on to now is a case study of the Transpennine route upgrade, where we try to bring all this information together. So first of all, we tried to set out what the vision is. We wanted to make sure that we joined the whole variety of those different systems up together. So we joined up our BIM, our GIS, and our common data environment into a digital ecosystem. We wanted to focus, okay, we didn't want this information just to be accessible just by the geeks in BIM corner. We wanted it to be available from project director down. How do we make this information, put it in the hands of decision makers and put the trust in that information to be able to make, again, reliable decisions based on reliable data? Can we make reliable decisions? Unreliable data, I said the comments of the previous comment from John. Single source of truth for the data, again, we hear that a number of times, but again, when we have so many different systems that often use different varieties of systems that overlap, we really wanted to eliminate that. We want to be digital by default, and we wanted to join the dots up between the different systems into a single place. And we wanted to, one of the key things is that change would happen. We didn't want to, we needed from the very outset and says, you're not going to do things the way you did things last time. We want to do things differently. Be prepared for that change, and we brought in the change management teams to help change that culturally as well. And we want to be open and collaborative approach. So the one thing we didn't want to do is set up a project team and just be focused on that delivery. We've reached out far and wide as possible, right the way throughout the Network Rail and in industry. We brought in things like the CD Centre of Digital Work Britain and say, look, this is what we're doing. How can you help us? And a number of fellow travellers we brought together to make sure we could, who are interested in building, effectively one of the first digital twins of a railway project, we're able to bring that together. So just skipping through this, we had a whole host of core Network Rail systems. So we had things like Ellipse, we had cars, and we wanted to try and connect information. So this is our standard asset registers we had to deal with, and we wanted to bring that information together into a central data warehouse. And this is where the data warehouse is important. It means that, you know, where we had our main systems, we wanted to see how that changed over time. And you can only do that if you bring that information into a data warehouse, and the data warehouse is also where you would structure that information into a single place. The other thing we developed was the extract, transformation, and load processes. So we can make it really quick to say, okay, we want to refresh the data, overlay it, and really quickly, there it is. Overnight, we had a refresh of the data every time that we could go around and play with. So again, that was a lot of work went into that. We also had another section where we can actually bring in asset data from other sources and manually enter it. We also had sort of analytics and systems we were able to connect through into that data warehouse. So once you've got that data in a single place, we can build the data analytics tools. Jacobs, who are main delivery partner on this project, they had their in-house tools that they wanted to bring with us. So they brought with them their project-wide CDE environment, their project mapper environment that was effectively their GIS tool that maps all sorts of GIS layers, not just from GeoRINUM, but also, you know, Environment Agency or other sort of weather systems, bringing that over the top. And also they brought in what was called the track records. We had things like track video and things like that playing over the top. So it just brought this together all into a single place. We had the Bentley guys here, so big shout out to Bentley. We really did a fantastic job in pulling this all together using iModel Hub and iTwin to bring us together and make that information visible as a single source of reference. Do you know, we spent ages trying to get approval to buy this for the project, and we've probably spent something like 10 months trying to get approval to get this. But when we actually got approval and put it in, again, we implemented it really quickly. I think within about 3 or 4 weeks, and within 6 weeks, the project had paid for itself. So getting it through approval took absolutely ages. And so within 6 weeks, you know, the quality issues we found immediately, just, you know, the survey information and bring it into a single place was absolutely, you know, tremendous. And then through that, we're able to, you know, visualize, make it available to, you know, from the project director to around the project director at TRU, put it on his desk. He was driving his team meetings using the Bentley iModel or iTwin. And as soon as we got that senior level engagement, the project flew. Yeah, and then we then sort of integrated our 4D planning and 5D cost analysis off the back of that as well together. So the way we structured that, all from having that information, but again, bottom up approach, your asset register, that's all where it's driven from. Yes, it's a similar thing. I'll skip through. There's a video that plays on that shows some of the I can just click the video bit and I'll just see if I can talk it through. Yeah, so this is just effectively the bit on the right hand side. We obviously got the central data warehouse here that we were able to do our all analytics, retrieving information from the asset data from ellipse and cars, bringing it into a single place to be able to do our sort of reporting analytics, looking at relationships between data in a very sort of visual way. Again, discovering relationships between information that we didn't know it existed. Things we know with future, we're looking at graph databases. Common data environment, this is again putting information all into a particular place. And again, this shows some of the project mapper track record, and this is a little video of iTwin of you know, the actual project assets of how we're going to be putting this together. Bringing in survey and point cloud information. Again, again, so many different uses. You know, we use this for local residents to say, well, what work was going to happen overnight, how would they be impacted with it. So again, this is becoming more prevalent now in a lot of more projects. But this was to say one of the pioneering projects, you know, about two and a half years ago now. And again, this is actually some of the modeling software we brought all within this common data environment. That this is again the link through to our asset database. So again, we've got the model linked into the asset database. We also linked it through to safety base, which is our safety system, so we can identify hazards, brought that into this single place. And again, part of what we're able to do is identify hazards within a particular location and do our sort of risk analysis based around all this common data. Okay, the final part of the presentation is I was going to say, well, what's going to be in the future? And I work with an organisation called Building Smart, and we're the sort of the centre organisation where we do open standards for BIM. And one of the things we recognise is that there are so many different client organisations around the world that have their own standards. You know, Network Rail has their Ellipse data standard. We've got SBB, they have their own standard. China Rail have their own data standard. And we can see that there are multiple, our supply chain work right away across the continent, all having to deliver to different client requirements. And we saw this as a real barrier for change, because at the moment, every time we ask one of our supply chain to give us information in a particular format that we want it in, they had to go away and develop their own processes, their own tools, and their own systems. Software vendors out there like your Autodesk and Bentley, they're not going to tailor their software to meet specific client requirements, but they will develop their software around an open standard. So we've been working with Bentley and Autodesk and other vendors around the world to develop a set of common open data standards around delivering of information. So the first part there is about the information delivery specification. And the way this works at the moment is that it's a bit like you know, how we have XML or the way that the internet works at the moment, that we have the transport protocols in between. So the information delivery specification is about the digital specification of information and be able to define that in a common way. So if we can define that in a particular digital way, we can then give that to the BIM authors to deliver that information against that specification, so they can import it into their BIM authoring tools. You know, your Autodesk Revit or your Bentley Open Rail or something like that, projects like that, and populate that information against that information delivery specification in a common open format. When that's actually then populated, we can then exchange that information in the exchange format, which is integrated foundation classes. And then when we receive that back, we can check and validate that against the original specification to say, does it meet the spec or not? Or is it correct? And the other final part of the puzzle is, well, okay, we've got this open data schema, but I can't import it into my Ellipse system because it doesn't meet my Ellipse data standard. So what we've developed within Building Smart is the Building Smart Data Dictionary, and that does your translation between what Network Rail calls a switching and crossing, or a component, or an interlocking, to what the open data standard says. So we've got that translation. So either end of the booking with the information delivery specification and the exchange format of industry foundation classes gives you that complete life cycle of being able to exchange information from your requirements to your BIM authors, to your validation and your check-in, and back again in a complete cycle where it means it's completely interoperable. So it's not fully robust yet. It's work in progress, and it should be we do some pilot projects within the next year or so. But this to me is how we really unlock productivity with some of our renewals and new projects, is making sure we digitally specify, we digitally validate, and we digitally receive information in a open way that our software vendors can actually build solutions around. The IFC Rail project this has been developed over the last 5 years, and this has gone through and taken every single element of the railway. And like I said, we have railways in this country, we have railways in China, we have railways in Africa and Asia, many similar different components. So what the IFC Rail project has done is identify all those variety of different products and decomposed every single element, right away down from your bridges to your tunnels, to your stations, down to your different, your track, your track panels, your interlockings, right the way down to the component level, and defined all your attribute data that you need to associate with every single element of the railway. It's also flexible, so if you do identify something that you haven't done or is particular to you, you can actually define those elements within that scheme as well. Your company specific standards or information you need to capture that's not there, it's already built into there. So again, I really encourage all of you to look at the IFC Open Rail project, because again, this is another influence on how we're going to use open data standards to unlock that productivity. Type of things here, that's not just, as I say, we broke that down to the aligned side equipment, your substructure, superstructure, tunnels, bridges, so that it's all dealt with in there. So again, it's a complete hierarchy or complete ontology of every single element there, and a whole variety of different data attributes that you to the heart's content. So you don't need to go and invent your own. And again, this is just an example of where we've got a track panel. So again, different elements, and these are sort of the right way down to the elements that we're actually we're capturing. That to me was all I had to say. So hopefully that gives you an overview of best practice, where we are, and also a future look at where things are going in the future.
Thank you, Lawrence. We'll move on to Mark's presentation now, and we'll take questions at the end of the session. So Mark, final presentation of the day, final but not last but not least. And Mark is representing the Institute of Asset Management today here.
Thank you for hanging around for the graveyard shift. Can we get the house lights dimmed, because it makes the slides a bit easier to see? Okay, my name is Mark Norris. I am a member of the IAM's UK chapter, and I'm here to present this on behalf of the IAM, looking at getting smart with digital solutions and aging infrastructure. I am a fellow of the IAM and a registered asset management professional. So part of this is also a talk about what the IAM does. So I'm going to talk about the drivers behind the growth in asset management and maturity, the role for new and emerging digital solutions, and there's a bit on the end about the Institute of Asset Management itself and how you can get involved, what it is we do. So understanding purpose and value. We are focusing now on what the purpose is of your organization when we talk about objectives. Now, this is part of the move to go well beyond level 3. ISO 55001 is simply a starting block. It means you've achieved a basic level of asset management. It is not an excellent asset management system. It's just the first step towards that excellent asset management system. But what we haven't had so previously is the type of guidance required. So now we're looking at that purpose and value. We look at our planning wheel. And understanding the purpose and value allows us to set decent objectives, objectives that everybody will buy in, part of the organizational objectives. And when we align our asset management objectives to them, we're also ensuring that the assets are delivering value by achieving the purpose that we set out. Okay. So we come on to using that planning wheel. So here we're talking about providing a service. We're not talking so much about providing products, although we've had lots of people standing up here talking about software and so forth, and the type of instrumentation that they're put on. But for the railway, we're providing a service. So meeting those demands, what are they in terms of society, environmental? We have sustainability demands. We have demands from the customer. Now, we were talking about what the customer actually wanted in terms of they want the service to be reliable, they want enough space on it, and they want it to run on time. I'm amazed it took a survey to find that out, but it's not a surprise that that's what they want. So in terms of developing a purpose and how we deliver value, well, the purpose is to achieve those and keep our customers happy. So there's a little bit in there. So the wider purpose of the organization. So that's providing that service to move people from one place to another efficiently and effectively. Using excellent asset management approaches enables you to do that effectively. But again, it's understanding that purpose and how the assets are going to deliver the value that gets you there. So asset management maturity, where have we come from, where are we going to? Well, the Institute of Asset Management formed back in 1994. But come 2000, with the Hatfield rail disaster, asset management started to grow legs and started to get its teeth into British society and into the utilities. So then we come up to, even I'm struggling to read that. Yeah, Ofgem. And so it goes on. So each step improves the asset management maturity. So now we're looking at rail having come full circle and now looking at it being beyond ISO 55001. So there's quite a few people who stood up here and said that they have been certified to ISO 55001. Now, part of the requirement of retaining that certification is continuous improvement. So we are now starting to step beyond ISO 55001, and even the regulators are getting involved. In 2014, the DFT said for the new rail franchises, they needed an asset management system to look after the stations. The stations hadn't been handed over to the franchises before. They'd had the ticket office and given it a lick of paint, but they didn't have the stations as part of their portfolio. But now they can fully develop the stations. But in order to do that and to hand it over and say you're going to have good stewardship of our assets, they wanted to assure themselves that they had an asset management system that was robust. So they asked for ISO 55001. So asset management maturity is a journey. And there's plenty of guidance as to how to get here, how to get up to basic level of competence, but not so much guidance about how to get beyond it, to go into optimizing and then get into excellent. And once you're into excellent, that's where you are never standing still. You are constantly improving, constantly striving to do better. And that's why we now have a document within the IAM, which is the pathway to excellence. So this allows people to have that additional guidance as to where to go in terms of the next steps. So level 3, competent, not an endpoint. Getting beyond level 3, 3 characteristics: criticality, understanding the asset system criticality, the scale and complexity of the portfolio, and the volatility of the business environment. And we've all seen how volatile that can be because we've just been through a pandemic. We've also been hearing about digital solutions and digitizing of the railway. Now that's a key part to moving beyond competent. It's moving into that optimizing zone and beyond it into excellence. So we're all familiar with the 6-box model, and that's still very applicable and appropriate up to level 3. But like everything else in asset management, things improve. And they definitely have improved because you can see the quality of the graphic improved. As well as the fact that we've now broken it down into a 10-box model. And right at the top is that purpose and context. So we talk about value and outcomes. So it's a different slant. We've added leadership in there as well. Okay, risk and review have been separated. And it gives us a better idea of where we are going in terms of that purpose and context. So, what is the role for these new and emerging digital technologies? Well, we've heard an awful lot about it today. We had Stephen at the beginning asking about best practice. It's like, well, here's some guidance on best practice. We had Sin and Sylvan both talking about converting data into information. When I was fleet asset manager of 4 London Underground lines, I was looking forward to receiving my new Victoria Line trains. I had Bombardier happily announcing that I was going to get 9 gigabytes of data off the train every day. Well, that's the difference between data and information. That wasn't information. I needed 2 kilobytes of data that told me something was going to go wrong tomorrow. So, purpose. Developing that guidance helps organisations exploit digital technologies because we know what good asset management looks like, because we know what our purpose is, and we know how our assets will deliver value by achieving that purpose. Looking at data as an asset. Now, we had earlier on Malcolm talking about monetising data to determine its value. He also talked about considering buying data, so data as a service. So instead of trying to implement the system yourselves, you get somebody else to look after the technology, which is a good idea because it guards you against obsolescence within the system. Because technology moves so quickly, you could put a system in that in a week's time, it's out of date. Something else even more clever has come along. Identifying the role for value in the organisation as stakeholders and customers. Again, we can do this, pull this out, the purpose and value. And the IAM guidance talks about the adoption of alternative digital approaches. It talks about digital twins. Now, again, as people have said today, there are all sorts of definitions of what a digital twin is. You need to decide what a digital twin means for you and how it adds value to what you are trying to do and what you are trying to achieve. And it's not just a shiny new toy to play with. Understand the levels of digital adoption and the maturity and readiness and how to do that. And Abel was talking about human interaction with digital twins and augmented reality, which is a good point. How will people interact with this? We also just heard here about what are you going to do with this information when you give it to people on the ground? What are they going to do with it? So, a real world example of what can happen. Now, this is taken from work that I did with Black and Beach, where we instrumented a wastewater treatment works, in fact, 4 of them, as a pilot study. It was subsequently rolled out to 71, and you'll see some of the reasons why. We instrumented it and plugged it into Harvey, which is a water-based AI system. But it's not just for monitoring the assets, it monitors everything around it as well. So it monitored the entire plant. It wasn't just looking for failures, it was looking for how well is it being operated. And we also had people talking about weather. Well, we fed weather events into it, local events, whether or not there was a football match or a festival or something that would place additional demands on the system. And we could teach it how to behave. So every month it would be taken off and we'd examine it. Again, we've heard how human beings are still more clever than the AI at the moment. We would go through it and tell it what to ignore and what was actually pertinent information. At 8,000 data points a second, it can go well beyond human beings. And it would throw things up and say, well, when we had these 6 events, these 3 things happened every time. So we can start to have a look at that. What do we think? Correlation isn't necessarily causation, but we might learn something from that. And it might taper it down. The first time it does it, it says these 45 things happened. well, that's not helping us much. But the more the event happens, the more it manages to narrow it down and say, okay, well, now it's just these things that are happening. We can start to make active decisions. It would do things like it would monitor the weather. We told it what the weather was like historically, and it would monitor a local weather station. So it would be prepared to damp the system down. So rather than saying counting overloads on a pump after 8 overloads, we know that pump's going to fail, it would prevent the 8 overloads. So it was a predictive operational system, as well as looking at predictive maintenance, but it was trying to avoid the types of overloads and the types of incidents that would demand maintenance to happen. And therefore we could keep our assets running for longer. And again, this is delivering that value and going that step forward. By the time it had been rolled out across the various places, we had achieved a quite substantial saving. Okay, this one. We talked earlier about the asset inventory. Well, we went through, all of these are historically ancient sites. Hardly anybody knows what's on them, not all together. Having worked in London Underground, every time we sent somebody into a tunnel to do some repair work, they'd come back out saying they found a live cable. 31% reduction in reactive maintenance tasks. That's quite substantial. 280 condition-based maintenance tasks were identified. And 490K saved on the first site. When we rolled it out to the 71 wastewater treatment works, they saved 60% of their maintenance budget because they weren't chasing their tails anymore. Quite substantial. And when we were talking to the people who were there, who were a little concerned that this might reduce the number of staff there, we pointed out that 20% of the staff within 2 years of retirement. So it's exactly what we needed to protect ourselves against the loss of those staff and the loss of the empirical knowledge that went with it. So a little about the IAM. As I said earlier on, formed in 1994, 350 corporate members. We have a world focus with our chapters and branches, and that's getting ever better. We had an international version of our conference, which was held online very successfully, and now the various branches, and each branch is a different nation's branch. They're starting to hold their own conferences. We have ours in November in London. We have a network of over 30,000 people, and there are patrons who make significant contributions to keep the IAM running. Network Rail, Transport for London, MTR, the Hong Kong Metro Railway. And they were one of the places that I took the guys from London Underground to go and see how things could be done, because they had 65-year-old fleets running ridiculously reliable at the time that I took them down there. So the IAM, there's our regional chapters and branches. Then the regional chapters are the national ones. We have the centre and the rest of the world as new places start to emerge. We are a knowledge transfer organisation. The idea is to spread the knowledge of asset management. And hat off to the guys at Metis for bringing in such an international flavour to this. I've been to plenty of events like this, and it's all just been local, all UK. So it's good to hear what people are doing elsewhere, and the fact that there are similarities in what they're doing elsewhere. So we talked about the drivers behind the growth in asset management maturity, particularly in terms of digital, how we're moving to a new phase of looking at value and purpose, the role for new and emerging digital solutions. I spoke then about an AI system. We heard earlier that AI systems aren't implemented very often because they're difficult. Well, we did it. And that was in a difficult scenario, a difficult place. We couldn't put wiring in, so we used some sensors from an organisation called 8Power. They have little piezo cells in them, so long as they vibrate, they self-power. They're Bluetooth enabled. Stick a Bluetooth box on the wall, you only need one bit of cabling, and you're into the system. So we could instrument ancient waterworks without having to festoon them with wires. And a little bit about the IAM and how to get involved. Thank you.
We're about to finish, but I would like to open the floor for 1 or 2 questions for the last presenters of the day. Any questions from anyone? We have one from Abel. I guess, yeah.
Okay, so we just have one online question first I'll go through.
Yeah.
I think this was for Lawrence. Where did that asset anthology diagram come from? I think the question was.
That's from the Building Smart railway specification, or it's the Building Smart railways project, and there's a rail specification. So again, if you'd like to contact me afterwards, I will certainly send you a link to the document. It's a full detailed specification of every single element in the railway.
So yeah, thank you very much for 2 excellent presentations. A quick question to Lawrence on your information delivery schema and how this ties up with the BCF and also with the national, the NBS, the National Building Specification plugin for BIM, for example, if this NBS could be extended to address.
Yeah, MBS, or certainly Uniclass is governed by MBS at the present time. Uniclass is a classification which is slightly different to an ontology. So it's classifications about grouping together of similar assets. The IFC, which is the decomposition of the railway, is the ontology. So they're slightly different, but part of the ontology, we have classification included. So because IFC or Building Smart is an international organization, we can use any classification system within IFC. But IFC, so Uniclass is only sort of mandated within the UK, but is open to others as well. So there's like Omniclass and things like that. It is also being used. Just to say, ISO is now going to be looking at developing a ISO standard around classification that should tie into IFC, which is also an ISO standard. So at the ISO level, these different things are tying together. Does that answer? Yeah, BCF is a great open standard for commenting and reviewing on documents. So again, it's another open standard that's been developed by Building Smart, to say that if we're doing it, one of the great things is when we do things like clash detection, where you identify a clash in some clash detection software like Solibri, you could automatically pump that clash back into the BIM authoring tool and actually have that comment reviewed and changed. So again, it's that open standard around how we do that review and a change of information. So yeah, it's again another really good piece of work by Building Smart. And again, it certainly ties into the IDS point, which is the specification. You have your data dictionary, which does your validation, and any sort of commenting and reviewing of documents is done through BCF. We've got the complete package there. We just need to, again, work with the software vendors to bring that framework into software.
Thank you. Any final question? Okay, I'll ask one to Mark. Mark, you mentioned that with the use cases demonstrated that there was a lot of value from that initiative, but I think we still see a lot of excuses potentially to promote improvement and continuous improvement, particularly as required by ISO standard 55001. Why do you think that happens? Is there any reasonable explanation that you can find?
We come back to purpose and value. people perceive it as being expensive to make those improvements. But as you've just seen there, 500,000 saving on one site when there were 71 of them, and a 60% reduction in maintenance expense. I mean, you can't afford not to do this, quite frankly. And the idea of pushing it out so that people can provide these systems, provide this information, but they take the technology risk. I like that one from Malcolm. That's a good push. But again, the way we instrumented it, it was nice and straightforward. Those Bluetooth boxes going up on the wall, plumbed into the bits of data cabling and so on they had. We didn't have to put in massive amounts of infrastructure. We could use what was there. It was just being clever with it. And the AI itself would learn whatever you told it to learn. So again, we've already heard that human beings are more intelligent than the AI at the moment. So it's picking the right things to be able to tell it. And within a water system, knowing weather events, knowing what the local load is going to be, we could put it in there. We could also teach it to scan newspapers so it would know when events were coming up and go to listing sites. So bit by bit, we backed away from it. At the time at which I left, they were going to voice operation. So you could walk in to your control room on a Friday afternoon and say, I need to reduce power consumption because it's getting expensive. So it would back the whole system down to minimum throughput. Or you could say, we've got a big event on, we need to get as much through as possible, and it would ramp it up. So the AI would monitor it and say, okay, if you want maximum throughput, it looks like this. If you want minimum power consumption, it looks like this. And off it would go. It was quite phenomenal.
Thank you very much. So I think we're closing the session. I would like to thank Victor again and Mattis for organizing this. I think it was a very interesting event. It was a long day, but I think a lot of interesting presentations, a lot of useful use cases, and I think ideas that we all can learn from and potentially make us a bit more active in pursuing this and a bit more optimistic that actually we can make some changes and innovate in the railway system and be successful at that. So I would also like to thank all the speakers and probably just pass to Peter for a final comment from himself as well, and thank him for co-hosting with me.
Yeah, happy to. Maybe two observations from the day. It has been a long day indeed. And also from my point of view, thank you very much, especially for all these diehards that left now in the room. One is related to the presentation of Mark. I think indeed it's about the value and the mission and the purpose. And I think we all have in common that we have one purpose, is to deliver a better public transport, a better railway system. There we have a lot to improve because the demand for capacity is high and it will only become higher, especially related to sustainability issues. We have an aging workforce that needs workflow to be automated, and we have big expectations of the passengers and let's say the freight forwarders. And then answering then the question that Tim Kersley asked on the day, do we embrace the technology available? I think we have seen lots of good examples that we do experiment with it, we try it, and maybe making BIM mandatory also in other countries would definitely help. But I think we can do more and we can do faster. And what we certainly can do all together as a community is learning from each other's experiences, sharing applications and things that we know. And well, let's try to be here also next year, maybe discussing a few things that can help all of us. So thank you for me.
Thank you very much. I'd like to obviously a warm round of applause for Peter and Giles for hosting today. I think they've done a fantastic job as co-chairs. Always difficult to split it between two people, but thank you very much for your approach to this. And also thank you obviously to all the speakers who've presented today. As you've all alluded to, it has been a very long day, but this is the Metis way. What we are going to try to do is, for those who couldn't see the slides or the presentations on screen, all the presentations will be on the platform this evening. So you will have access to all the videos and all the presentations. So don't fret, it is all there. So you can take your time to view that on the platform. We now have drinks, but we do have Martin from ProRail, who also during the drinks break is going to be demoing a system that I'm sure he can best explain to you if you come over to his stand just here during the break. But it should be fascinating for some of those who've been talking about how to calculate risk. Thank you very much.